How are you?
I'm good. I'm good.
No.
You give it to me right now. Because that's what's going to be going on through the system. So I want to go find the rest of the people who come up with your slides too. So meet.lpc. Meet.lpc. And I'm trying to help them.
Thank you.
Yes. It's one of the things that. Oh, no.
No, I do more visualization. Okay. So visualization. So let's Oh, I see, yeah. We never use it. But KVM.
That's what we do. Just basically, everything is basically all through the system so that it's good for virtual.
Automotive is just inputs in. Interesting, Stefano works for AG now.
You uploaded this one? Okay, that version of that. Okay, I'm looking for it. There we go. Hey, and welcome everyone to the Linux Plumbers 2023. If you have not uploaded your if you are a speaker in the main track and you've not uploaded your presentation, please do so. And we will be getting it going, but I'll make sure to point out and say thank you very much to all our sponsors. Their logos were visible just before we come in here and before I start, but right now we'll get right started on time. And I'd like to introduce you to Kasim, and he's going to be talking to everyone about early access to hardware for the automotive industry. Come on, come ahead. Thank you.
Let me check the setup here. So
Should be able to move forward there. Should be controlling here.
control from this one.
Yeah, that should do it. There we go.
Okay.
Go for it.
Thank you. So, good morning and welcome to Plumbers. Very exciting environment here, and I'm very thankful to Plumbers for selecting this talk and putting me first speaker of the day. So it is making me a bit nervous. So let me start on the topic. So I'll get into more details, so it will clearly present what exactly what this topic is about, and what exactly I want to get conveyed. So before this, like when I got here, so I see many known faces around, so I know many people, but they don't know me. So just to introduce myself, I started at TI in 2002 and started working on Linux device drivers way back. And then a lot of my contributions you might see only in 2.6, so very way back. And then I realized like we need a lot of open source hardware and open community platforms for really open source community to work on. And that's when I collaborated with Jason Kreidner, so at TI, and we started this beagleboard.org initiative. So I was one of the co-founder member for beagleboard.org. And then I wanted to do more of open source work, and then I joined Linaro. I started working on 64-bit Android for ARM v8, and then Greg is here. We started working on Project Ara under his leadership, and then we started working on Android for ARM servers, getting Android working on Docker containers. I saw Lee Jones here; he was our lead then. And then at last, like I was working on yoctification of all the ARM UEFI and ARM kernel, so making a bunch of releases for ARM N1 STP there. And then now I'm back in TI, so doing a lot of open source stuff again. But now I get to meet a lot of automotive customers there and automotive OEMs, and they bring to me a lot of requirements on automotive use cases. And first thing I try to propose them is the Linux solution, and I get hit back on when I start proposing general Linux open source solutions for any of their problems that they are bringing to me. So three things that they basically haunt me when I'm proposing any open source or public or even Linux based or Linux way of doing things in automotive industry. First thing, the solution that I am proposing, is it safety qualified? Does it comply to safety certification? Now, what is it? How are we supposed to do a software which is there in public, get it to safety qualification? That has always been a big difficult challenge on me to explain on how we can get no fault or fault tolerant software, and how we build that software from scratch. And that's one key aspect where I struggle to explain, and how we can make basic things, fundamental things which are there in Linux for so long, and how we make the automotive industry use those fundamental concepts and software and public software that is available and which is not safety qualified, and I get hit back on that. The second major challenge that hits us is on the performance of early KPIs. We call KPIs in auto world. So basically, you turn on your engine and your camera, if you are on a reverse gear, your camera should start streaming within 750 milliseconds, and you got to give a CAN response within 50 to 100 milliseconds. You have to get all your sensors which are there in ADAS, which are connected over Ethernet, and then you have to get them all connected to the server, and it should start running analytics and giving you the real-time data and real-time response to those sensors. And above all, like HMI application, basically, if you are on IBI, you want to, as soon as you turn on your car, or even before your car is on, like you just want to have splash and completely 3D graphics, accelerated needles and things showing up. So we, like a decade ago when I was working, like my first initial issue of getting early splash was like I wanted to show an Android logo on my device as soon as my mobile is turned on, right? Like that's what I know, and I know how to get the splash working. But here the requirement is basically when you are seeing, you are bringing that entire system up, starting from getting even a simple CAN response to UART based device, to sensors, to display, to camera, to audio. Almost everything in the system should come up within few seconds. Like the target that is set is within a second. Within a second, getting all these devices up is becoming way too tedious when we try to, unless we tweak in Linux a lot. And that's something that challenges me. And then the most important aspect also is, like I have seen, I was not observing auto industry, to be honest. And when I start looking at the automotive industry for last 2 years now, I am seeing that the device, the way they have configured the system, the way the devices are, and the way the software stack is, it's not power optimized. But we see today entire auto industry is behind EV, right? Like in every segment of auto industry today, starting from two-wheelers to your high-end trucks, like they're all going on EV, and every single milliwatt is going to add to the battery life. And power management has to be thought through and well thought through. And when it comes to Linux, again, we have very good power management solutions, but then when it gets to automotive, we are struggling to take those things because they need some more additional tweaks and hooks which are not available to user space, and that's where it's getting stuck. But it's not like we have no solutions to that. The industry already has been evolved in last decade, and we are seeing a lot of penetration into every single domain. And the way they have solved all of these issues is by going into heterogeneous processing. Like for every single thing, if they can't solve in Linux, put an MCU, put an R5, put a extra core which can take control of the system. Like you want to start a camera early, put an MCU, connect it to camera, and that takes care of your camera solution. You want Ethernet and you want it to be connected to sensors and it should be fast, then just hook on an MCU and connect the network, and then get all the sensors control data to through MCU. So basically, every single problem has been converted into an MCU problem and a microcontroller, and the firmware that is running there is safety qualified and compliant, and therefore they meet all their ASIL A, B, C, D requirements that are imposed by the safety certification bodies. So these things are really affecting us in taking Linux deep into solving all automotive use cases. So every single problem, as I said, every single use case that are imposed or that is being asked by the auto industry, we have solution in Linux, we have solution in open source, but when it gets to deployment, some of these challenges are really hurting us in taking it broader. So the whole reason for me to get here is like I just wanted to brainstorm these, like as I'm seeing these issues in when I am working with my OEMs and my customers. Definitely there should be similar issues with other OEMs, other semiconductor partners, and so on. So what I want to do here is just to have a brainstorming session here, and I will be here for next 3 days. I want to see if there are similar issues that are faced by others and how they have solved. If we can collaborate and get these things in a Linux way and solve these things in public and open source solutions, and get our Linux kernel and bootloaders and things hardened to meet all of these automotive requirements. If we can do that, that's the end of like that's my goal from this meeting here, and also like how I can evangelize this in next 2-3 days and get more and more people interested in taking the open source way to solve all these automotive problems. So like I have few use cases and studies which I want to present here. So I want to just showcase what the problem statement was, like what was the general ask, and how the current solution and implementation looks like, and then what should be our long-term solution if we want to take this in the way that Linux community would maintain or manage it. So basically, the entire auto industry is in the hands of autos today, and then the proprietary operating systems and things. So how do we turn it around and make Linux drive some of these concepts and take control of these use cases and solve these use cases for this industry? So first major thing or first issue that comes into play here is about the bootloaders. So like we know our traditional way, like we have SPL, ATF, U-boot, Linux, and Linux basically gets mounting file system and starts hypervisor. So this is our traditional way, right? We all are used to this. But as soon as we get into the auto world, the first thing that gets cut down is the bootloader. Like Auto World says, this SPL and bootloader, we don't know where it is coming from. The sources are not public. We don't know the secure implications. The code quality is not safety compliant, and there is no fault tolerance added into the bootloader. So they don't trust if we bring in SPL and U-boot into the boot flow, and that's where first thing that gets hindered. First thing is like to get booting Linux kernel within a second, so which can be achieved. I don't see that is a problem here, but then all the safety certifications, the MISRA-C compliance of the code, the LDRA tool execution, and these things are becoming too complicated when we take SPL as the standard bootloader offering for automotive industry. So what should be the open source way of doing things then? Like, should we take SPL out of the boot flow and suggest a new methodology to handle automotive industry in terms of bootloaders? Like from TI, like especially, like we have an SBL bootloader which we have put in public. It's available. Like I have shared the link here, which is there on GitHub. But I'm not personally. I would say the code quality, the semantics, and things are not the way the Linux community, like we all are used to. But then this is still public source that we have put out, and we are committed to make this safety compliant, like all the MISRA checks, the LDRA checks, and things that makes this code as a safety compliant. We can make those things happen. So I can commit to that part of it. But then we need a community collaboration model here, which we can take it and get get this component more broadly deployed and used and consumed. The biggest challenge here is like you solve bunch of problems in SPL and U-boot today. Like you get eMMC working at HS 400 speeds, all your boot modes are supported, DFU is supported, every single thing is already cracked and maintained and well thought through in SPL and bootloader. But same thing is not getting into custom bootloaders, and they spend a lot of R&D cycles to even mix and match things. So but I mean to say, there is a complete duplicate effort in the industry which is happening on bootloaders, which can be avoided if we can collaboratively work and get this public bootloader. And in some form, I'm not so intent towards taking the bootloader that TI has published, but if there is any other bootloader today which has safety compliance, I definitely want to hook onto it instead of doing any custom solution. And that solution has to be open source and industry accepted. So this was one problem area which I wanted to touch base. The second key area is basically, as I was saying, like when I go near my car, the car automatically turns on, and then all the subsystems in the device should come up with, from the displays to cameras to sensors and network, everything should come up, right? The way today, as I said, it is done in the industry today is by putting all these device drivers and device drivers and firmwares in an MCU, and the cost of this solution is way too heavy for a two-wheeler cluster or a two-wheeler domain to handle. Like, okay, BMWs and others can handle maybe because of the cost of the things, but when you want to give similar experience in a two-wheeler which is running in India, Taiwan, Asian countries, like the solution becomes too expensive. Now if you want to give a very cut down solution, then you need to bring the cost down, the BOM material cost down. But if you have to do that, then all of these things should fit in the Linux environment. And in order to fit into that Linux environment, you cannot have, like if you have 4 MCUs in your SoC handling each of these peripherals and cores. So that's not acceptable. Then what is the solution that Linux community has in order to handle all of these peripherals? So the first thing that we are doing in our SoCs today is, like, as soon as you power on or turn on this SoC, the MCUs are booting parallel to the A core, which is your A72 or A720 or A53 core. And by the time Linux is booted to prompt, these MCUs have configured these sensors. Now, for example, we have one sensor which has around 4K registers to be programmed over I2C before Linux comes up. Now, if you have to do this after Linux driver is up over I2C, it's going to take a long time. Now, in order to avoid that, the solution we have is today is through MCUs, and they doing all the I2C and transfers and getting the device ready, and then Linux comes up and takes the control. But can we do this as part of bootloader? Like, can we have a multi-threaded bootloader which runs on A72 or A53 core itself, and bootloader is basically configuring all these peripherals one by one in a multi-threaded environment, and then Linux is also coming up on a core, and then later Linux takes control of all the other cores which are there in the system. So can we come up with a simple solution which can make U-boot the owner and master of configuring all these peripherals early in the boot flow instead of relying on uh, MCUs to do the job for us? So these were some of the thoughts that we have in mind. There is a bootloader for automotive written in Rust. Okay, it is not certified, but there is a safety certification. That's too good to know. Thanks a lot for sharing this. So yeah, this is what I want to do here. Right? This is what I want to get away with. If there are more such things, I just want everybody to be following the open source way instead of inventing, reinventing, and doing the proprietary way of things. So as I said, like, we need a long-term solution for early DMA, early I2C. Sorry, go ahead.
Anytime, or should we wait?
Should we wait and ask questions? Yeah, it's okay. My session is more. It should be working.
So my question was, so like there are times embedded devices you just never turn them off. So could you speak on the need to boot? Couldn't you just keep running, whatever?
Sorry, I did.
So my question is, could you speak on the need to boot Linux every time you start the car, for example? Wouldn't it just be running all the time, like in a dormant state or something like that?
It can be. It can be in that state if you have, like, that's what is happening in some of the cars today, where even if you go nearby the car, your car basically starts booting the operating system, and it's ready for you to, even before you plug in your key or turn on, Linux has already booted into the system. But same experience if you want to take into a two-wheeler cluster, like how do you do that there, right? The experience has to be similar across a high-end EV car to a small two-wheeler which is running on EV. So the same experience has to be adopted, right? So as I'm saying, industry has already solved these issues. They have solutions for all that what I'm saying, but these solutions that they have are all completely proprietary, tweaked, and taken Linux for granted kind of things. So how do we converge back, and is there a mechanism to converge and start using some solutions which are readily available in the market? So even again, like as I was saying about DMA, right? Like there are bunch of registers that you want to configure, and you can use DMA to configure. But if you wait for Linux to boot and then initiate the DMA, can you start DMA way early in bootloader phase, like at the SPL phase itself, and let the configurations happen in the background, and you boot Linux in the front end? So can we come up with these kind of solutions? We are thinking about these things, but there is no immediate answer to it. But if somebody has already started working on similar concepts, then we would definitely be interested to collaborate in those areas. And one of the very important topic, as I was saying, is power management, right? Like as I said, in the last decade, the complete automobile was always thinking like they have gallons of fuel, and always the power was never a requirement for them because it was already always connected to power, and there was no battery concepts there. But today, as I was saying, like everything is on EV, like almost all devices are, almost all automotive segments are getting into EV, and every simple milliwatt is an important thing, and we have to save the power in the system today. So when you look around in the Linux solutions, right, like the SoC architecture is like you have ARM multi-core system, and then you have bunch of accelerators. Like you have one device doing camera analytics, one core doing camera analytics, one core doing graphics GPU analytics, and you have another core doing all the safety applications, and something managing the complete display subsystem. So you have multiple cores in the system, which are like simple MCUs. Now, how do we? There is no mechanism in Linux today to, or there is no definition in Linux today which says this is what a remote core should do when I hit suspend, or when I go into deep sleep, or when I go into, like, first of all, there are so many modes for a core itself. It is no more like simple CPU idle, suspend, resume, or deep sleep kind of thing. There are multiple modes that these SoCs are offering, which we need to which we want the user space application to handle. Plus, how we do, like we have remote proc driver today. So remote proc driver on a suspend sends notification to all the cores in the system, and it's left on the mercy of those remote cores on what exactly they would be doing, like what these firmwares will be doing. But as from the Linux subsystem, we are not setting some rules saying you are supposed to do these things. Like if I put you in DDR self refresh, you are supposed to do these set of things. And if I go in idle, like what should be your what should be the rule of engagement for power management in these remote cores? So those definitions are completely missing or lacking, and every simple organization to auto OEMs, they are doing things on their own. And when somebody publishes these power numbers, like when somebody says this is my dry stone number, right, like we are comparing apples to apples, like one SoC is being compared with another SoC, and you are measuring same dry stone, LM bench, all these things, right? They are standard tools. But when it comes to power, and when somebody says this is my runtime power, this is my idle power, this is my deep sleep, or things like active power, these numbers don't match, because these numbers are getting cooked, and it is coming up after making some manual corrections to it. So therefore, we need a standard tool and standard mechanism and standard metrics, so that industry works on those areas to optimize power. So power definitely is a very important concept here, which we need to start working. The other area is like in mobile segment, like we have frequency scaling, where we do scaling of the voltage and scaling of frequencies, and we reduce the power consumption, right? Similarly, when you are working with remote cores, like where you have say 10 MCUs in your system, and each MCU behaving differently for different power mode, we need to see like how we can scale the frequency of these MCUs independently. So a lot of these things will also bind to the way SoC is designed to handle power. But similarly, we also need Linux standards to define how remote core would work with the main processor which is running Linux. And these standards should be published with the tools, benchmarking tools, and that will really help us in doing better on power management with automotive things. The final thing is Ethernet connectivity notifications. Again, this is a very important area, because all the sensors that are connected in a car or in any automobile is over network port and network cabling. And there are a lot of hacks. I just gave one example here, like we want to get a file link up as soon as the device is powered. And simple hack that I find in the code that we had is like we moved Mac open from system network D daemon to a CPSW probe. Like we have probe function, so we move Mac open in probe function, so it initializes all the switch, and the switch the file link is up as soon as the probe is done. That gives very clearly like 2.5 to 3 seconds of savings, but that is completely wrong, right? We cannot follow this methodology for everything else in Linux subsystem. So what should we do for these kind of tweaks which automotive industry is carrying? So we need to find a way to discuss these solutions in public, and then also have some mechanisms to build these kind of areas in Linux subsystem. So this is one thing. Along not just Linux, right? Like the CAN interface, the way we handle Ethernet, and the way we handle USB, most of the things are tweaked today to meet to these automotive standards and automotive use cases. So this is basically like all the code base that we have. I have the links which I shared in each slide. So as I'm saying again, so the solutions are all there. We have solved most of these problems in non-Linux way. Now, how do I get these solutions into a public open source and Linux way of doing things? So that's what I want to achieve. Now, what should we do with these? Like, should we discuss in the ELISA form, or should we continue to discuss in Linux kernel mailing list and keep discussing on how we want to improvise these things in Linux? Or, and the other important aspect, like even Android Automotive OS, like all of these issues and use cases and problems that I described for a Linux subsystem applies to Android as well. We also are working consistently on Android, so I see similar issues there, and lot of tweaks and hacks happening on Android subsystem as well. So again, right, like when I look at ELISA and Android Automotive OS project, so they are solving the issues which are above Linux kernel, like the way dealing with the hypervisors, and how do we solve the IVI kind of issues and things. But what I am talking here is all the fundamental things, like from boot of the device till the way till the boot gets handed off to Linux. So there lot of tweaks and lot of hacks are present which we need to standardize it. So that's the overall intention. Again, as I was saying, like how do we get into safety of the safety certification for all the open source software that we have in place? So again, if somebody wants to collaborate, and if there is a collaborative way of doing these things, so please reach out to me. And also, like, I'm here for next 2 days. We should get these things sorted. That's the overall intention of this slide set. So I'm open for questions, and thanks to all our open source solution partners like Libre, Consulco, BeagleBoard, and especially Linux Foundation and Linaro for us helping in these solutions when we are coming up with. I'm open for questions, though I may not go more detailed, but definitely I'll be interested to know.
So as you were mentioning the ELISA project, first of all, I guess the ELISA project is very open to discuss it with you. Within the project, the main focus is currently on the Linux kernel side, so not on upper layers. So for this part, definitely it's interesting to see also the lower layers, which are in there up to the kernel part. But I guess a lot of parts which you put in also for power management and so on, they are discussions. And I directly, when you're mentioning power management and idle cores or reducing dynamic working frequency scaling, I reminded me to the first slide you shown where you say, okay, safety. And I would say there's a lot of things to discuss what happened and could go wrong when you, by mistake, put a wrong frequency on something. Is your workload there in time? Nevertheless, I would say from what you show as the architecture, it would be brilliant to do everything in a Linux domain, but there may be also requirements that you will anyway have still a microcontroller next to it, right? Because the microcontrollers are typically certified to much higher safety integrity level than the microprocessors. And for this, you end up in the system. So we discussed it for a long time to say how much can you get into Linux world, but maybe you also would like to get, let's say, for time being, it doesn't cost any hurdle, and it's more than if you're running on this microcontroller Autosar world, consider also an option to say, I use an open source RTOS here rather than a proprietary Autosar or something, and look for a certification part there. So I think there's a lot of room for discussion on this. We could also take in the next day. So I'm very happy to take this forward.
Discussion. Again, I'm not so worried on certification. So even like when I come from Linux world, so when I was first introduced to the safety and safety certification, so even I was worried, like what does it mean? And but really to get any project safety certified, it's really not that big deal. So there are some bunch of tools, bunch of mechanisms that known good standards that you need to follow. Once you follow, then the software can be made safety qualified. Now, as I said, like we are committed to work in open source and also solve safety. So definitely a lot of collaboration can be done in those areas if we have some running projects there.
Yeah, I was just wondering about how a lot of the traceability and documentation requirements for ASIL and stuff sort of are at odds with the Linux development model. Like how do you have that end-to-end traceability and documentation from design down to implementation when the design process is a mailing list discussion?
Few areas where we manage to get that done. Like for example, there is a constraint where you need to show, there is a very clear baseline quality procedure that safety certification team introduces us or imposes on it. Right? Like you have to have design, then you have to show test plan, then you have to show test coverage, then you have to show where did you review your reviews and things. So for review, it is easy. Like you go take bunch of patchworks and club everything and show that this was a review. Test plan, we have a lot of LKFT, we have so many tests that even Renaro deploys a lot of tests in Lava today. Even every organization, we have our own test infra, like we publish test results publicly, where we are showing, here is our test case plan and test case metrics, and here are our test results. So that is that is made public. So definitely there are a lot of initiatives in open source world today where we can deploy boards in public form and start getting the test results and publish those results for certification. So I don't see a big challenge for us in maintaining the test results in public domain. And it is possible. We are doing it today in TI. Like if you go to our CI/CD portals, we are publishing our test results live on daily basis. And that test plan is safety qualified. We can publish even the test plan that we have for safety certification.
So in the ELISA project, there's a couple of different groups that are probably going to be relevant and interested in participating in this discussion. One of which is obviously there's a spot for us to have more discussions on automotive side. And so obviously some of these things are going to be very relevant to that side, but there's also the Linux features group that's trying to figure out how to deal with all the parameters and configs and everything else in Linux to set up configurations for certain scenarios and do it most efficiently.
So Linux features group and then ELISA project is what
the automotive one. They're both, there's a bunch of working groups underneath ELISA, one of which is the automotive working group, obviously. But then there's also the Linux features group that's looking at how do you start to configure Linux and put the right parameters in place to assess for certain properties. And then there's also a third group that's relevant here, which is the systems group. And so Philip will be talking a little bit more about that later in the week on how we're trying to put a full system together, which is some of the things that you're talking about here too as well. So I'd say come more talks with us and Lisa. We've been trying to tackle some of these same problems a lot, and your help would be very welcome. Any other questions? Oh, okay.
So if I got you right, you just said that with the certified test plan, you don't see a huge problem with getting a certification. But what kind of what level of certification are we talking here? It's probably not SIL 4, right? Is it SIL 1? Is it SIL 2? Or what are we talking here?
Yeah, very good question. Like there are a bunch of certifications. Like if you have to be a very time critical and very sensitive device, there is like ASIL D kind of class of certification. There is ASIL A, ASIL B. Not every automotive component or like the subsystem device qualifies to be an ASIL D, right? Unless you are an airbag or something you are monitoring or operating, you have to be in that high quality certification, which can definitely be in RTOS world and can be managed by real R5 cores, which are ASIL B to begin with itself, right? Those segments are okay, but there are a bunch of other segments which don't need to be in ASIL D certification. Like if you are an IVI or you are a camera subsystem or you are a two-wheeler automotive cluster or you are simply a speedometer or things like this, right? So in automotive, tons of electronics, even to turn on your lights, even to project something, even your rear view camera, rear view mirror, so many devices are there which don't qualify to be a real hardcore safety SLD kind of thing. So for those segments, whatever safety certification that we are suggesting should be good enough. But few time critical and safety things we should still deal with them separately.
I want to touch base on what you said about requirements and design and so on. I guess testing is one thing, and putting this, even if putting it into public, is quite easy. But if you put a lot of requirements on components and so on, you need to also maintain those requirements. And I guess this would be a very high take, because a lot of things you may make use of in Linux or related components are also used in many other use cases, and the demands from automotive are very high. So I assume that it's important to make an argumentational base, because typically the safety standards just say you need to do it exactly in this way. They say this is a practice and show me an equivalent class of it. So I believe it's also a lot of thing to just improve the documentation. For example, see that the man pages map the implementation, because it's not always followed one-on-one. And we have much more document on this, so that most likely a person who creates a system maintains also own requirements, derives requirements, may be willing to share it, but I guess the responsibility will be very hard to transfer to a Linux kernel or maintainer community to write down requirements. Nobody is willing to do all this overhead and put it maybe in a formal requirements to.
I would answer is somebody in the ecosystem is willing to do. Like I have a test team, I'm already doing the requirements capture, I'm already doing the testing. I'm willing to open it and make it public and do validation for a public repository, right? So it's mainly, it comes down
Okay.
to collaboration. It cannot be a generic
So,
thing.
so one of the things that just got open sourced is a tool from Red Hat called Bazel, where we can link the requirements, the code to the tests. And so if you guys could start help populating that out, we could start to crowdsource that in areas where people care about things. And maybe that'll be a starting point for pulling this all together into something useful for all of us. Because if you've got pieces and other people have pieces, I completely agree. We need to start collaborating this stuff to pull it together and so it's usable.
So do we have actually a taxonomy or a dictionary of existing systems? So I mean, you outlined earlier the difference between the Linux way and the Auto way, and you sort of kind of summarized your experience with how some of these designs are made in the automotive system world. But do we have an actual sort of dictionary of here are 10 cars and here's how those 10 cars solve the problem? Because I guess that would, I mean, give practical or empirical data of how these different things have been solved. And somebody coming from the exterior that doesn't know that field and doesn't have a sense of reference points of stuff can at least look at that and say, okay, well, maybe I have some experience that's related to that from other fields and then apply it to the automotive business. So is there such a sort of compendium of systems that existed?
Not like that's where I was coming to it. Where should I, if I have something like that, where should I come and discuss this? Discuss this in a user forum, or should I discuss this in kernel?
Yeah, honestly, I mean, if you were just to build a database of that, like here's a website or one page we have, okay, and here's like 10 examples of actual real products in the market and what they struggled with and then what they ended up with, and just having that as something you can point people to, maybe that would be sort of something interesting to, again, give some reference points to people that are trying to solve the problem with you.
Let me work on that. I think like as I said, power management is new to the entire industry. Maybe we may not have the running use cases, but mainly in the networking domain and the bootloader domains and these the early KPIs that I mentioned. So a lot of our learnings can be shared, and I can come up with that dictionary kind of thing which can clearly articulate how we have solved and what we can learn from other domains of Linux.
Yeah, because I guess what I'm trying to say is if you keep it at the level where there's no sort of data about these things, then only the people who are in the field will be able to participate in the discussion. Whereas if you actually have a database of systems and problems that have been solved, and somebody that's, I don't know, from the server world or whatever can come back and say, well, we had this problem and this is how we solved it.
Regarding kind of a database, I guess it's nothing existing so far, but when you create a system on Linux, you need to comply with the licenses along with it, right? So I think it's often not that easily to be found, but if you start searching, typically you find a system composition, I would say, in the OEM's repositories or web pages. So I know that Denso, Bosch, Toyota, Mercedes, they have certain web pages where you can download the created source paths. So I guess there's no real database in this, but at least the sources are out there. And typically, if you get an indication of where things are, if you have a car, for example, you should be able to find the license information, right? If you see there is a license information somewhere because they're obliged to do, you have a point of contact, and I guess it should be possible to also figure out where all these kinds are in use and how the things are configured.
Getting back to your point about bootloaders, would there be any? I mean, I know there's a lot of work going into. I think Microsoft calls it secured core or something like that, where they do a lot of attestation and secure really around that related to UEFI and stuff. Would any of that be leverageable? I mean, I know a lot of things use U-boat today, but I mean, there are some x86
I think the
automotive
most newest
solutions as
thing
well.
that I see what Philip has mentioned about one of the REST-based bootloaders, I think that might come very closer. UEFI didn't really help us because these bootloaders have to be very nimble and solve a different kind of problems, like as I was saying, on the sensors, on the cameras, and things like this. So, yeah, again, all these issues are solved, but they are not in a tweaked way, which we need to collaborate. Yeah. So yeah, what I was saying is like all these issues are solved, but then we need to make it public and start make it broader and standardized way of things. So UEFI didn't help much in basically in these kind of domains that I have seen. I personally have worked on UEFI on ARM V8, also on the Octo side of things, but I didn't see this as an important item to consider.
Okay.
So regarding the proposal to sort of use the repositories that are public, I think that's great. But I think what Kasim was saying also earlier is that a lot of the other pieces are like proprietary, like talking to MCU, doing whatever. So yes, I think that using the reference things, whatever is published is great, but it's a starting point. But there's also like a higher level design that may not be reflected in the sources per se.
Think we are done with the time, so we will thank you very much. Thanks for showing this interest for this topic. Hope it was making your interest feel. Thank you. Thanks a lot.
Okay. Thank you everyone for being here. This is the main Raspberry talk, where I'm going to try to give an overview of what everybody has been doing, all the projects that we have. Here's an echo. Let's echo in the back. So yeah, let's start with it. So it's the first time Rust. So I suppose this is the first LPC that Rust is in our first LPC where Rust is in the main kernel, so it was added with once right after soon after the previous LPC. So Wesson is has been doing a couple of work with the for personnel, but he cannot he couldn't come in person, but he will be around in the chat in DVB, helping with questions, answering things. So you can send questions, and he will probably focus. He will be able to reply in while we are speaking, and at the end we can also take some questions. So the agenda. So we're going to speak about, as I said, a bit of a status update on the different bits that we have been doing in the last year. Then we are going to talk about what we have been upstreaming and what is also coming. And finally, some discussion topics that we wanted some feedback from the Kernel community. So the status update. So this is a plot of the growing community. One of the ways I try to show how it has been growing since the beginning. We are now more than 460 subscribers in the mailing list. The plot is a bit, you can see a bit erratic because I was taking samples more often early in the project. And now it's going up and up, and I take samples mattering. Another way of seeing how the interest, basically a proxy for the interest of the community, is the SWIP statistics. Here we see the number of users, which of course, there could be a lot of, it's open to register for anybody. Sorry. No. Sorry for the virtual attendees. Now? Okay. So, sorry for the virtual attendees. Yes, I will continue from here. So we have 500 users now, more than 500, and growing. You see the plot there. Last year, as you can see in the slides, we had an uptake on the last part of the Q4 of the year, probably due to the merge. And another way of seeing the progress as well, or how the community is growing, is the regular or 15-day active users in the Zulip statistics. As you can see, we have a big spike there as well last year, and then we have now about 70 regular users, I would say, in the Zulip chat. So it's quite there's quite an interest, I think, from the overall community. And also in the statistics, we had 8,000 messages in Zulip in the last year, which probably is not much compared to other places, but yeah, it's active. We have also been growing the core team. We call the core team basically the people listed in the maintenance entry. And recently, we have added a few things in that list, which we will talk briefly about them later. In particular, I wanted to highlight the new members of the team joining last year. First of all, Benno, who has been working on the Pininit API and the field projection IFC for the Rust language. He has a talk on the Pininit. Sorry, he has a talk on the Pininit API in the Rust MC. So please go
to see his talk on Wednesday. We have also Andreas, who has been working for quite a while now on the Rust NVMe driver, trying to push it upstream, trying to convince maintainers that is a worth endeavor, as well as the null block driver. And finally, Alice has joined as well last year, and as you may have seen in the mailing list, she just sent last week the Android, the Rust Android binder driver RFC, which was in fact one of the first things we worked on back years ago. And she has been taking it from really, really experimental prototype to actual working and everything. She also has a talk, and Andreas as well has a talk on the Rust MC, so please come to the Rust MC. If any of these topics are interesting for you, please go to see their talks. Also, we have patch series submitters as another way of showing how many people is contributing. These are people that have actually sent patches to our mailing list. Of course, there are others that are not listed here that have given reviews, reported bugs, etc. I'm sorry if I didn't list everybody. I hope I got everybody. Then we have also, perhaps more importantly for this talk, and part of the feedback that we want to get is that maintainers have been getting involved as well from the kernel community. For example, I will give two examples. One is the K-unit maintainers got even their in their maintainers entry, they got the files listed explicitly already. So this is in mainline, and they take care of those files. This is what we would like to see happen. The goal is that because otherwise it doesn't scale. The goal is that we start getting Rust files or maintainers maintaining their own Rust subsystem side and growing from there, rather than, because this is a common question, rather than maintaining everything in the Rust subsystem, which was never the goal. The Rust subsystem is meant for the beginning, a bit of everything, but then the idea is that the Rust subsystem takes care of core things that other subsystems do not take care of. We also got, as another example, the second example I have here, we have Matthew Wilcox, who has said very recently as well, I think 1 week or 2 weeks ago, Matthew said that I'm happy to commit to keeping the Rust implementation updated as I modify the C implementation of folios, but I appreciate that other maintainers may not be willing to make such a commitment. So this was in the context of the discussion of how we keep the abstractions in the Rust side in sync with what the C side is doing. So, for example, him is taking the lead and saying, well, I will just do it, and I will take care of that, which is useful in certain cases where we need to, there are certain technical details where we don't have a way to automatically maybe see a mismatch between the two sides. So there is really someone, at least right now, that needs to know that if you are updating one of the sides, you need to update the other. In particular, for example, we want to introduce perhaps comments in the C side to warn people modifying that code that there is already an abstraction on the Rust side, because this is really the uncommon case right now. It's very, very rare to have a Rust abstraction. So it's very easy to miss that, well, you are touching some C code somewhere and you are not modifying the Rust side as well, right? Hopefully this also gets easier or solved when we start moving all the files from the Rust kernel crate into the spread, basically put them in the right places all over the kernel tree. So I want to mention, of course, the sponsors and the industry support. So first of all, I want to thank you, ISRG and OpenSSF, because they are sponsoring financially the project. ISRG in particular within their Proximo effort about bringing memory safety to the critical infrastructure that is used by the internet, basically servers, etc. And then we have in the second, third row, and Sulip as well in the bottom, we have all the companies that have given us a statement of support, a public statement of support that we have in the webpage, as you can see in the links there. So these are all the companies that have stated publicly that they want to see Rust in the kernel and that they are interested in seeing Rust in the kernel succeed. As you can see, we have quite a few big names already piling up, and I want to thank you, all those companies really, and the engineers behind them, pushing their managers to get through, legal, etc., to get this happen. Yeah, so I want to highlight the ones that we got last year very quickly. ISRG, of course, they are a sponsor, but they also gave us a statement of support. You can read there. We also got Samsung. Samsung is employing Andreas, who is working on an NVMe driver again. And they seem interested, as far as I understand, on getting the NVMe driver written in Rust to work and be upstream, maintained properly. Also, Cisco is interested in Rust, and we have Ariel from Cisco. Cisco employs Ariel, and Ariel is working in PassLFS mainly, and they are interested in having that in mainline. Then we have Collabora as well. Collabora gave us very recently a statement of support, and as far as I understand, and I hope I don't get this wrong, they have an interest on video for Linux in Rust and codecs in particular. Yeah. So I don't exactly know the details on how it will go. We were discussing in Cangrejos, which I will mention later, how to get this into upstream. As usually for all these different projects and companies, we see a recurring theme, which is we want to get this into the kernel. What do we do? How do we get there? So yeah, and Daniel Almeida is the person. Sorry, Daniel Almeida is the person that is behind Collabora doing the codecs in Rust. We also have distributions like Ubuntu. So they have very early, I will say, they have very early started to prepare we were not expecting that they were so quick to prepare, packages that you see there that you can now install in your Ubuntu distribution if you use it. Packages with the compiler, with the tools that we need, so that you can just compile for example, Auto3 modules written in Rust very easily in Ubuntu. So we were not expecting, personally at least, I was not expecting this to happen so soon, because again, the Rust support is still experimental, we are still streaming the basics of everything. But Ubuntu took the lead, Andrea Ricci took the lead on doing that, and now we have packages there. I don't know if they will enable it for the LTS, probably not, I don't know, but we will see. But the idea is that, and I hope other distributions do as well, we contacted other distributions as well. They have not, as far as I understand, packages so far, but we contacted other distributions, and they are willing, the major ones at least that I talked to, they are willing to support something like this as well in the distributions in the ways that fit their distribution. So from the perspective of the cost of maintaining these packages or these extra packages should be fine for them, basically. At least the major distributions. Maybe minor distributions or small distributions may have a bigger trouble perhaps on maintaining the packages if they have a big workload already. But for the major ones, I think we are in the clear. Let's see if I don't. This doesn't appear. Maybe I can read it there. So where is the community project support for Rust? Companies are well and good, but Linux is supposed to be approachable for hobbyist developers too. Yeah. So the first part of the presentation. Maybe, I don't know if it was after or before the mic started to work for them. But the first part of the presentation, we were talking about how it's growing the general community, basically, the non-commercial, if you will, or hobbyist side. So if anybody wants to join, please, the answer I would recommend is join in Solid, because it's where most of the action is and where you can get help. So sorry. So Cangrejos is a conference or a workshop that we have been doing for 3 years already, 1 online, only virtual, and 2 in person. It has been great. I really appreciate, and I really want to thank you, all the people that trusted me to come in person, basically, into Spain, to meet. And we have had a very nice time. We have here 2022 in Oviedo, Spain. We have some you may recognize some faces from the photos. Yeah, and then we have last year, which was 2 months ago, 6 weeks ago, where we have had one close by as well, Gijón, in the north of Spain, and yeah, we were very. It was very productive. People got, I think, they really enjoyed the experience. Yeah, and I understand that it's very hard sometimes for some of them, especially in the north of Spain. It's not an easy trip, but I want to thank you, all of them. Thank all of them for coming. If anybody is interested in coming, if you're a maintainer or you have a particular thing, please let us know. So far, the event, or probably in the future, if we keep doing it in a personal capacity, it's invitational. But really, if there is a maintainer that is really interested in coming, please let us know. I try to invite everybody that I know that is interested in Rust. But if I miss you, please just let me know. Yeah. So we also got another news. We also got a website. It was not there last year. Now we have it this year. The domain is rustforlinux.com. I have put in the left side the menu, which I will go through very quickly. And we have the first part that you see in the top. We have documentation and resources on the project itself. Things like the Rust version policy, which we will talk about in the talk, the branches, or we will also talk backporting, etc., etc. This could be, or part of them could be perhaps in the kernel tree, as in the documentation folder. But for the moment, at least, some of those things we keep there because it's a bit not just easier to update, but also it depends. Sometimes it's a fuzzy line on where it should be. For example, the contributing one that you see there, the second entry, is currently our P entry in the maintenance file. Is basically our maintainer profile. There is a maintainer entry profile or something like this. It's called in the kernel. Not, I think it's only 5 subsystems that have it so far in the kernel. But yeah, we point to there. So if you have a web page, you can point to the web page, a URL, and that's also fine. So yeah, please, if you are interested in the project, I really recommend reading those pages because they are short and to the point, and they describe some of the FAQs, many common questions that we have had over the years. And we try to, every time we get a question, we try to add more information there to help. Then we have subprojects. The subprojects that we have so far are Klint and Pininit. Both of those have, again, talks in the Rust MC this year. So please go to see the talks. Then we have tools. Tools are third-party projects, but the pages and all these projects, the subprojects, the tools, and the user, all these subpages are maintained by the actual maintainers or leaders of the project. Okay, so we are not maintaining them. These are projects that have committed to maintain that page for us in our web page because we want to showcase the things that are getting ready for Rust in the kernel. So, for example, there you have questionnaire for Rust and Rust C code and GCC, which is the backend in the main Rust compiler to go through the GCC backend. Then we have users. Users, what we call users, is simply use cases. You can call them use cases for Rust support in the kernel. So you see there the NVMe driver, the nullblock driver, Android, the PASLFS. Again, we will be adding more as because we don't want to. We could list all the things that we ourselves that we are aware of, but we prefer that the maintainers are the ones that the maintainers of those projects are the ones that maintain their own subpage in the project. And of course, when Rust in the kernel is not a prototype anymore, maybe it doesn't make sense to keep all those users because it will be used in many places, hopefully, or that's what we hope. But for the moment, we think it's a nice way to showcase what is being done, the major project that we have in the kernel. And they are not yet all of them, but we will also speak briefly about that. So finally, and I have scrolled there in the screenshot to the links. So if you scroll on the page, it's maybe easy to miss. If you scroll, it's a scroll bar, but this is to me still. If you scroll, there are a lot of links that we point to other interesting stuff. For example, the conferences, the LWN articles, or the indexes that LWN keeps about Rust. Yeah, so a bunch of stuff that yeah, it's really interesting. As an example, I have two screenshots. As an example, one is the Cosinel for Rust one that Julia is maintaining, and that I will briefly mention later. So you see an example of what is a subpage there and what we maintain, something simple. Another one is the results from Andreas, the early performance results from Andreas. So we have graphs and plots that you are probably very interested in seeing. So it's just basically to tease you to go into the pages and look for things. So tools, to get a bit into tools, I will talk about three of them, especially two of them. So the Rust C code in GCC, as I said, this is maintained by Anthony Boucher. He works on this backend for the Rust C compiler, which is one of the approaches that we have or we will have for compiling the kernel with Rust. This means the official Rust compiler with the front end and everything is the same except for the backend where we go through GCC using the GIT library. And current. Thank you, Kate. Let me see, I see here. David, the one from David? Yeah. Oh. My experience so far of trying to build code with Rust is that it breaks weekly and that code which used to be fine is no longer absent. Okay, sorry. What is the long-term plan for the Rust compiler support as the Rust code flows into the kernel versions that require long-term support? So we already, I will discuss, maybe I defer that because we have some slide on that later. So as I was saying, we have the code, the GCC backend. This was already, this is experimental still, but it was close to ready. And last year in Cangrejos, Anthony was there in person and showed us how he could compile and boot the kernel with some changes. Well, now he can do it without source code changes to the kernel. Okay, so this is really a nice progress. It's still, of course, experimental, but I wanted to highlight the main point, which is that you can have a kernel full with built with GCC and using Rust with that. Of course, again, a prototype it will take maybe another year. We don't know how long to get into production, but we are getting there. Or Anthony, I should say, is getting there. Then we have GCC Rust, which is the other approach. GCC Rust is where you want to upstream a new frontend for the Rust language into GCC itself. So you will have in the future GCCRS, I think is going to be the name of the binary. So when you type GCCRS, it's going to be your Rust compiler that is included in GCC. So streaming started last year for 13, and they have the planned initial release for 14 next year. Now, again, this is experimental, and I will give a few points that they gave me after this slide. And then we have Cosinel for Rust, which was very recently published and announced publicly. Julia also was in Cangrejos this year and gave us the good news. And yeah, you have the report there, and she has a talk on Wednesday, so please go to see it. A lot of things, as far as I understand, already work. It's already useful for using it in the kernel. Of course, a lot of other things are not supported, but they are working on it. So as you see, basically the pattern that we are trying to showcase here, or what I am trying to say, is that the pieces that are missing, the pieces that you would expect for your normal kernel development, are continuing to be worked on in some cases by the actual people. That is not us, but the actual people. For example, Julia, that was, of course, is the author of Cosinel. Now, for these are some slides or screenshots that Anthony gave me for Rust C code in GCC. You don't need to read it. Essentially, I asked him, can you please show that you can actually do it without source code changes? And show the steps that you need to compile the kernel with GCC right now. So you clone the kernel, you do def config, you do menu config, and then you put there a very long, let me see if I can highlight, it doesn't matter. You see there a very long command line that you have to pass. It's a bit long because he has some folders there, nested folders. But anyhow, you have to pass some flags, basically two of them, K-Rust flags and host Rust flags to configure, to give basically the path of the backend to the compiler and the sysroot. But apart from that, which is essentially, this will be done at some point in Kable automatically, we hope, somehow. But right now, you can already try that. And as you see in the bottom, it's compiling Rust C, for example, a module, the Rust minimal, and it's going ahead. Then we have QM putting and loading that module that I just mentioned, ModProbe Rust minimal, which is one of the samples that we have just to smoke test that everything is okay. Yes, so there is one asterisk that I should say is that by the time that he went to do this screenshot, there is he had to move forward in the the Rust C compiler. He moved forward in history in the branch. So he's using an ILE, and he had to patch the usual patch that we do to alloc every release that we upgrade the Rust compiler. So he patched it also for that, but it's not a change related to Rust C code GCC. It's not something that you will need to do. It's just something that I just wanted to mention, just in case somebody tries exactly those steps and it doesn't work because of the alloc change. But yeah, apart from that, he has some subpage, as I said before, in the website, and he has some instructions that you can follow to get it working. Very nice. And as you see, he also supports now the comment section. So we send the support for the comment section because we may want to use it. For example, Payhole may want to use it to see what is the language or who compiled what language is behind a particular object file. Payhole already has, Arnaldo already added when we requested him to do so, to read the dwarf language. The dwarf at language, I think, is the one. So there is already an option on Payhole, for example, to skip the Rust object files because Payhole is also working on supporting, the features that the layouts that Rust creates that confuse a bit or confused in the past a bit Payhole, and now that is getting solved, so that Payhole is a bit more flexible on what kind of structures it can read. So yeah, but apart from that, for GCC, for this backend, it also works the comment section. And it's not really important, it's a minor feature, but what I wanted to show is that it's actually compiled, like as a double check, the Rust minimal example is actually compiled with Rust C, as you can see there. It's not that it's going through LLVM for some reason. Then we have GCC Rust, where, as I said, they are streaming GCC 13. I will not, it will take a long time to go through this, but yeah, they are streaming patches. They have a lot of patches to stream to GCC. They gave me this, also Arthur gave me these slides to show what they are working on, what is the upcoming work, the streaming that they want to do for 14 and the initial plan release. As far as I understand, the initial plan release is very, very minimal. It will only be able to compile, some the core library and minor programs or very basic programs, but the progress is there, and hopefully by next year. So last year they were in Cangrejos as well, and last year they were still dealing with a lot of details. Now, as far as I understand, they are way closer to compiling core. For example, they have there the format args, built-in macro support, and so on. And next year, I hope that but it's my words, it's not theirs. They have not promised that. I hope that by next year we can perhaps, for the Rust version that they support, which is not the latest, that we can compile STD. Then we have Rust for Linux for Compiler Explorer. This is a project that I was working on the side. It's a very simple thing, but it can be very useful, I think. I talked about it and I proposed it to Matt Gottwald about basically being able to compile a Rust module in Compiler Explorer. You just type the module there, you copy paste it, and it will show you the output with the flags that exactly the flags that we use in a dev config, basically, and a normal kernel build. So not the normal user space flags that we use, but the ones that we use in the kernel. So basically, many cases where we have been working in the past year, we wanted to see the output, and it's sometimes quicker to just put it in Compiler Explorer, and it's easier to figure out what the compiler is doing, playing with flags, play with the source code changes. So we want to have that. And Matt said, well, that's a great idea. I gave him a prototype of how it would work, because it was a very simple change, actually, to support it. We discussed how much resources we could put, and he told me that a reasonable set of versions and kernel configurations could be supported. So we could have a small matrix of things that basically that you pick a kernel and it will compile it for you. And it's very quick because it's pre-compiled. All the big parts of the kernel will be pre-compiled. So it's basically instant, compiling a Rust kernel module, and then you can see what the compiler is doing and what is the output. It's also useful for training, of course, maybe for talks, etc. So yeah, and ideally, but I don't know when I will have time to work on that, but ideally I also want, and he also agreed that this is a very nice idea, is to, in Compiler Explorer, if you use it, there is a way to execute some code rather than just compile it and show you the output. So the idea is to run QEMU there. So instead of executing it in user space, wherever, in the Firecracker or wherever they are using to execute the thing, you it in QEMU. And even having an extra window to write a unit script, so you can use ModProbe or whatever to insert it, remove it, and do everything Compiler Explorer. So I hope that's very useful for all kinds of stuff. Probably more training rather than, yeah. There is also other things I will not mention, but I leave them in the slide. We want to have some more features that I would like to see. Maybe we implement them ourselves. I don't know. But these are things that I think Matt and the team will be okay with, as far as I understand. I hope I don't misrepresent his position or he changed his mind. No, Matt is, in all seriousness, Matt is a very nice person. He was very helpful and very receptive of these wild ideas of having the kernel in the Compiler Explorer. And maybe in the future, when people see it in Rust, maybe you want it also for C, to be able to compile C modules in Compiler Explorer as well. So we have also the documentation. We are going to have a domain Rust so instead of docs kernel org, we are going to have a subdomain there, not for the normal documentation / documents in Rest written in RST, but for the generated documentation in Rust, the one that goes along with the code, which is where actually we have most of our documentation, because it's much better, instead of putting things randomly in the docs folder, we believe it's much better to put them near where you want to document. So for example, if you are talking about a type or an API, you put the docs in the very same file. This is how essentially Rust does it, and we are doing the same thing. Yeah, the idea is to have those generated docs in a subdomain, because they are not the rest ones, and it will appear there. So Konstantin was okay with this. I have to work on that and finish the thing. What I want to have is also, it will be possible to have per tag access. So like in Bootlin, for example, or even in the docs kernel.org, you will be able to select, or at least type the URL. We are discussing still that. Type the URL to see the docs for a particular version. The generated docs, there are some details to discuss, but for example, what configs do we use exactly, because the docs are generated for a particular config. What versions, what the top bar, to have a top bar to select the version rather than type in the URL and things like that, but they are details, basically. One way or another, we will have this domain so that people can see the docs much more easily. Sometimes it goes forward, sorry. So mitigations, yes, mitigations. And we have not much time. When is finishing at the top of the hour? I think so. At the top of the hour? I haven't, yeah, okay. So mitigations, we have mitigations being sent. You can see the details in the slide. But essentially for Red Poline, SLS, and Red Hank or Red Hank, we can basically, the object tool warnings go away if you put those two pieces together, and hopefully we get them in mainline soon. Also, Ramon sent me this text on CFI and kernel CFI support. He has been working on the Rust compiler to make that work. He's getting there as well. He's close to being ready, and as far as I know, already. But I don't know if it boots already. I think it boots, but I don't want to give too many details. I don't know exactly the status, but he's actively working on it. So reviewer documentations, recommendations, reviewers recommendations, a document that Botune is working. Botune is here. You can also ask him in person. Sorry, I don't have much time. But it's a document that we want to write and publish, make public. We have it. We are working on it, or Botune is working on it. But at some point, we want to make it public, and reviewers can, essentially, it's a list of things that you should check when a patch is submitted and how to review it. And we want to do it especially because we think it's helpful for other maintainers in the kernel that are going to start reviewing these Rust patches, what the things they need to look for. So in the beginning, I think it's going to be useful for them. Then a bit of branches. You can see more details on the URL. But we are deprecating the Rust branch. The Rust branch is where we had all the code we worked for the last 3 years. Now, basically, it's frozen now. It's not, we don't use it anymore because the latest major user that we are aware of, at least, the NVMe driver from Andreas, is already ported into Rust Next. So there is no more major users that we are aware. So it's deprecated now. We will keep it there, archive, but please don't use it anymore. And we are also introducing a new one. We remove one, we introduce one, which is the Rust branch. It's intended to like a sort of experimental, very quick, rebased all the time branch that Potune maintains. Rather than the Rust Next, which has more constraints because it's in Linux Next. It's merged into Linux Next. So upstreaming, very quickly, we did some initial merge, as you know, with very, very minimum support for Rust. It's very, very minimum the support we added in 6.1. And in 6.2, 6.3, etc., we started to put abstractions in, for example, for the synchronization primitives. We incremented the Rust versions, etc. But the main point here is that why we are doing it like this. We have been essentially taking the Rust, the things that we worked for the last years in the Rust branch, and we have been porting them into the Rust Next branch, redesigning sometimes the API, iterating on them, because over those few years, we learned some more things. We learned new ways of doing things, fixing also, soundness issues if they appear. So we have been iterating on that, and then we are moving slowly things into mainline. And we go through their maintenance. We go, for those that don't know, the policy is that not just that we put things in the Rust, through the Rust subsystem, we actually go to the maintainers, and the maintainers are the ones that have to give the okay for the Rust support. For example, the work queue, Taejun took it through history, the work queue abstractions, and worked with Alice to basically finish the last details and put into production. But that takes time. But nevertheless, we are working on we have other major work streams. For example, Binder, NVMe, DRM, file systems, PHY, video for Linux. Those are all things that are being worked on, but they depend on a lot of abstractions that will need to reach the kernel. And this is basically a process. We have like a pipeline where all these things are coming. We are trying to do our best to make the critical path as short as possible, but it takes time. But basically, what we are trying to say here is that even if the things that we have mainline may not seem like much, we are doing a lot of work on this side to support those use cases and to get them into mainline. Okay, this I will go over. These are the slides for talks that are in the RustMC. So please go to RustMC to see what they have been working on. We have been doing pin initialization. We have Kalen, which is a tool to statically, so at compile time, detect context violations. Very, very interesting. So please go to see it. It already detected problems, catch at least 1 or 2 problems already that we made. Issues that we created in the Rust code. So it's very, very interesting. Please go to see that one. Block layer abstractions. We have been working, of course, on the NVMe. As I said, Andreas is working on that. He has presented it in other conferences. Binder, again, the LPC, I already mentioned it in the talk. So please go to see Alice's talks on it. And Carlos, I think, as well, is presenting. And then we have VFS, which Wesson, who again is in the chat and is responding to questions as I see. The VFS read-only abstractions are there already sent, and Matthew Wilcox and others are, Alviro as well is interacting with, and Christian Browner, I think, is also discussing with Wesson to upstream this. And we have 2 file systems in Rust, pure Rust, that uses them. And in particular, I don't know the second one, but at least TARFS is written in full safe Rust. So no unsafe code in TARFS. Okay? So if the abstractions are correct, you cannot introduce undefined behavior. You cannot have a memory safety issue in TARFS. Okay? So discussion topics until the end. And we have 6 minutes for maybe questions that Wesson has not answered yet, maybe. So we want to ask, so maybe there's no time to discuss, but we want to ask 3 main things to the community. The first one is that we are currently trying to take soundness issues. Soundness issues is, as I mentioned several times in the talk, is something that could make you introduce, using only safe Rust code, undefined behavior. Okay? So it means that your abstraction is not wrapping the unsafe code correctly and is leaking away, or even if it's not present in the in tree, even if this doesn't materialize in a particular compiler or kernel tree, but it's still a way that you could do it, right? So we still fix that. It's like an extra layer of protection over the C side. So C doesn't have that because you for example, you call a function with a pointer, you are supposed to not pass a path pointer, right? So in Rust, we don't do that, and we are supposed to fix these things. And we not only fix them in the current version, but we also backport them. So this is still experimental. We are trying to backport them. We have been doing so far. We have not had trouble. It may be hard in some cases, but as we get more Rust features stabilized in the Rust compiler, I think it will become easier. About the question that somebody, David asked, I don't know what he meant about breaking that Rust code breaks. It's not true. If you are working with a stable Rust, the language guarantees stability, and I have it here. The next slide. This answers a bit the question. The Rust language is stable. It promises backwards compatibility for the stable features. There is some unstable features that we have to use for the kernel, but we are working with the Rust project to stabilize those. And we have a meeting coming up, and we have had meetings in the past about how to deal with all these things. And perhaps we want to ask them to give a special support case for the kernel in the beginning, so we can reach a point where we can have, for example, a window of versions supported or something like that. We will see. Or at least, even if we use unstable features, that they promise not to break them right away, or they warn us so that we can be ready for the change or change it, or they give us a window where we can use both ways and they deprecate the other way, etc., etc. So again, I don't have much time. I want to finish. Sorry? Okay, yeah, thank you, Gabe. Yeah, that's enough. So the main point here is we are tracking the latest version right now because due to the reason that we are using unstable features, we cannot use, and we have to, for example, fork the alloc library from the standard library. We cannot use several versions. I mean, we could, but it would be a maintenance burden that, since there is no in-tree kernel user right now, it's not really important. Even if when they are there, it will take a while to get all these things sorted. So the main point here is we are tracking the latest version, and that's why we do it. Some people get confused about this. It's something that we would like to see done something only temporarily, and eventually, as the link there in the URL explains, eventually we want to have a window support of Rust versions, Rust compiler versions, right? So it's not something that is something temporary, and when we get to that minimum version that is in the future, we will establish the minimum version. And finally, it is the last slide. There is the duplicate drivers exception. So a few maintainers are open to the idea with experimenting with Rust, but sometimes they want to do it with a simple driver that they already know about, that they already have in C. So upstreaming that driver until everything else is ready, you cannot do that because then you would need to drop, if you don't want to violate the no duplicate drivers rule, you would need to drop the C driver. And it's bad, and it's a maintenance burden, and we have been warned by high-level maintainers. I see Greg here in the room. We have been told, no, that's a mistake, and we actually agree that this is a mistake, but to break the egg and chicken problem, the chicken and egg problem, we are requesting to have an exception for Rust and C drivers for a while until you get all the abstractions in. And we have also other reasons why we think this could be a good idea and helps maintainers to start with Rust, because otherwise nobody starts if we don't have a way to get the abstractions in without breaking also the no-dead code rules, etc. So for these other reasons, we have submitted this maintenance summit topic, and there is one post there where you can see all the details. So that's all. Thanks a lot for joining. Sorry for the the time, and if we have time for maybe 2 questions or 3, thank you. And also thank you for all the people that sent me the slide, not the slides, but the content that I wanted to present for everybody. So I'm representing here a lot of people. Sorry.
So I'm curious about the GCC RS backend. So once we're in the state where we can use GCC to build Rust modules in the kernel, how hard will it be to make that work across all the architectures rather than just the architectures that already have a Rust user space port?
In GCC, as well, I think Anthony told me that it's not be a big problem to use the different architectures. Actually, the main point for us to use the Rust code GCC for the kernel is to access the architectures that maybe LLVM doesn't support. So yeah, so we hope that's. I think he works on Intel. I don't know if he has tried already ARM. Maybe it's too early for him to try several
Right.
architectures.
I assume the 5 architectures that are most widely used will be no problem, but then we have 20 other architectures that have very small user base and don't have a Rust supporting user space.
But you mean in the normal Rust compiler?
Right. So
Yeah. So
things that don't have an LLVM port or Rust C port.
yeah. So the Rust. Sorry, I don't know if I understood the question, but the GCC backend allows you to use the other architectures. That's the idea, basically. The idea to have that backend is so that we can access all the architectures that GCC support. Exactly. That's the main. And of course, also to have 2 compilers to compile the kernel. It's always good to keep that.
Miguel, hello.
Yeah.
I want to raise the point of like potential user reachability. What I mean is like, right now, maybe we should start pushing distributions to try to enable Rust in their kernel, especially in the generic default kernel. Right? I'm biased on this topic. And so, but projects like, for example, the CodeGen GCC or the GCC RS, they can help a lot to increase the user reachability because they can provide Rust across architectures. But let's say I'm a kernel developer and I'm working on my own, I don't know, file system. And if I need to pick either Rust or C, right now I would just say, well, if I write that in C, it will work everywhere across all the distribution. So if we have like coverage for architectures and coverage for distributions, Rust can be a valid replacement for C.
Yeah.
So what's your opinion?
So I think we are basically, the answer is we are getting there. The one thing is, until GCC is ready, I think, until we get enough abstractions and a major user merge, I think it's a bit too early perhaps to talk about how to reach users, because there is no entry use case, although we have, of course, Asahi Lina, for example, the Asahi project, that already people is using with the GPU driver written in Rust. But of course, that's a very small distribution that they can take that. For generic distributions, I think it's still, it will take some months or a year or maybe 2, we don't know. But I think we will get there. I think is the answer there.
Thanks.
Thank you, Andres. Thank you, everybody.
Thank you very much. And just to let people know, we're now for a break for 30 minutes, and we'll be resuming back here at 10:30. So go get a coffee and buy a break. For those online, it's your turn for a break too.
My experience, sales pitches that I could
can be Linus Torvalds, someone between the maintainer and the Linux. So I have here a few topics ideas. So I will mention a few things about the expectations about the maintainer tree and what the maintainer should do. So that you should be in the Linux next. I will share a few tips and tricks how to improve the workflow of a maintainer, including how to work with the Git kernel org. There will be a few questions, a few things about the PGP keys and dumping the mailing list, because we should not use mailing lists maybe. Feel free to ask the questions in the middle. We have some microphones, or wait till the end. I hope I will have time for the questions. I should have time for the questions. Yeah, you can interrupt me. Yes. Feel free to interrupt me. Some more people are coming, so yeah, please join. Great, so who am I? My name is Krzysztof Kozłowski. If you don't know how to pronounce my name because you are not a native Polish speaker, then you can say it Krzysztof. I go by Krzysztof for foreigners. I work in Linaro in Qualcomm landing team. I maintain a few Linux kernel subsystem parts. The biggest part is device tree bindings, so I review quite a lot. I send also a few pull requests, mostly to the ARM SOC guys. Why I'm talking here? Because none of the upstream maintainers were complaining about my pull requests, so I think I'm doing a decent job. But more importantly, I'm sending quite a lot of patches, really a lot, and I noticed some patterns, and I hope that this talk might improve the experience of other people who send patches to the mailing list. I will start with the integration tree and the robots. So let's imagine Schrödinger's cat, or exactly not a cat, Schrödinger's patch. So Schrödinger wrote a patch, or maybe a few patches, and sent them to the mailing list. And he received some of the answers. Imagine that Schrödinger received the answer like a thanks applied, one option. Second option, the Heisenberg reviewed his patch. He received reviewed by Werner Heisenberg, or he received nothing, a silence. So month passes, and Schrödinger gets back to his patch set and wants to see whether it was applied. And he looks at the Linux next. Linux next is the next integration tree for the next kernel release. And he doesn't see the patch in the Linux next. Where is it then, right? There are just 1,000 kernel org repositories with the Linux, so maybe you should check every repository, or just check 500 unique Git repositories mentioned in the maintainers tree. Obviously, if you also consider the GitHub, GitLab repositories, it's not feasible, it's not possible, right? So there can be also another case that Schrödinger prepared a patch set, and some of the patches were applied or received this message, thanks applied. And then after 1 month, he wants to resend everything, and he rebases his patch set on top of Linux Next. And then he also sees that his patch is still in the rebase patch set. So it was not applied, but he received thanks applied. So what's the problem with the Schrödinger's patch? If he received the thanks applied message, but he cannot find the patch in the Linux Next, so what shall he do? Shall he resend or shall he ping? The patch was applied. So who votes that he should resend the patch? Raise a hand. Okay, who votes that he should ping? Raise a hand. Much more people for pinging, and maybe the rest says that he should do nothing because patch was applied. Right? So if he received reviewed by, then this, and the patch is not in the Linux Next, this means that obviously he should resend, because reviewed means that patch was only reviewed. It was not applied. This is obvious, right? I'm talking about the real cases which I, by the way, experienced. And the third case, that Schrödinger received nothing. So this is, I guess, the most obvious thing. He should either resend or he should ping and ask what's happening with the patch. So he does it. Imagine that Schrödinger pings or resends the patch and receives from the maintainer a message that, yeah, come on, I applied it. And why you are pinging me? So Schrödinger is pinging because he's confused. He checked the Linux Next. There is no patch in the Linux Next, so how it could be replied? And if the patch receives a tag called reviewed by, it means that it was not applied, it was only reviewed. So this is the problem with the Schrödinger's patch. So when the maintainer takes the patch, he should then not rather call it that it's reviewed, even though while taking a patch, you are reviewing actually. When the maintainer takes the patch, it will be going to the upstream maintainer, eventually to the Linux storeballs during the next merge window. If the patch is not in the Linux Next during this time, we miss quite here a lot. So there's a reduced visibility, reduced testing. So none of the bots are testing the patch. People also are testing, I'm testing Linux Next. So if the patch is not in the Linux Next, I will not test it. Many people will not test it. Eventually, submitter contributor is confused and he thinks that his patch was ignored and wastes the time. And by the way, Linux also expects that patches will be in the Linux Next before the merge window for a few cycles, for a few days, week, or whatever. So the solution for this is quite simple, and I'm quite surprised that there are maintainers who are not in the Linux Next, because you should add yourself to the Linux Next. If you ever collect patches for the upstream maintainer and the upstream, whatever your cycle between you and the Linux Torvalds is, add yourself to the Linux Next because it's free. I mean, so Steven Roffel, who manages, does not send invoices. It's not free from the effort, though. So, of course, if you are not a kernel maintainer, don't add yourself to the Linux Next, please. Add yourself if you are a maintainer. How to do it? Very simple. Send an email to Steven, CCing also the Linux Next mailing list, and say where is your repository, what's the name of repository, to whom you are sending, and also most importantly, mention the 1 or 2 branches, one with the patches for the next release, for the next merge window, and the second one for the pending fixes, if you have fixes for the existing release. What are the rules for the Linux Next? So if your tree gets included to the Linux Next, you will receive the email from Steven describing few of such rules. Read the email. I will not quote the email here. More important is that you can still rebase your tree, because Next is rebaseable. If you, as far as Linux Next is concerned, you can rebase your stuff. One important thing that some maintainers are sending the patches to the upstream maintainer, not as a pull request, but as a set of patches. And in such case, once your upstream maintainer takes the patches, the Linux Next will have duplicates from you and from the upstream maintainer, because applying a patch creates a basically new commit. So these are not the same commits, right? So in that case, you will receive an email from Steven that he will notice that, yeah, there are duplicated patches. So maybe you want to remove, once this happens, you want to remove the patches from your for next branch. And one more important, or actually the most important rule here is during the merge window, you should not add the new material to the Linux Next. Merge window happened like 2 weeks ago. I mean, this Sunday it finishes. We have a 6.7 release candidate, first one. So during the merge window, your future Next should be frozen. You should not add new material for the next tree. You can, however, still add fixes for this merge window and for the current release. So these fixes go usually to the pending fixes branch, but also they could go to your Next. Linux Next brings us to the testing. So the most known testing bot, so which tests everything, is the Intel 0-day, also called LKP, Linux Kernel Performance Testing. The emails are sent by kernel test robots, so these are all the same names. There are a few other bots, like kernel CI is very well known, or Linaro Kernel Functional Testing, LKFT is also known. But the Intel 0-day focuses on testing, on building everything. This is why I'll be focusing now, talking about the 0-day here. So if you ever apply patches and you have a kernel org repository, then probably kernel test robot already builds your patch, builds your tree. If you have repository in some other tree like GitHub, but you are in the Linux Next, then you will also be built just with a 1-day delay. I mean, when the next release happens, Linux Next release. If you have other case, so you are not in the kernel org or you are not included in the LKP, then the bots will not find your patch, right? And this leads us to the previous talk that if you are not in the Linux Next, then sorry, no one is testing your commit. And it's quite easy to add yourself to the LKP, and there's a benefit even if your repository is in the kernel org. Why? Because you can say which branches you want to test, and you can receive more detailed notifications, what is being tested, what is being built, success for every build or failure for every time. So I actually encourage it even if you have kernel org repository. And you could add your development tree, which is, for example, on GitHub or so somewhere as well. So this is my case. I have my maintainer trees on kernel.org and development trees on GitHub. And whenever I push something to GitHub, I receive the emails from the kernel test robot that, yeah, everything is fine, build was success. And this kind of saves me the public, maybe not humiliation, right? But let's say public messages from a kernel test robot that I introduced a warning in this patch set, because I will get it earlier when after I push to the GitHub account. How to do it? There's a GitHub repository for the LKP, and you just have to add there a new repo file, and add a new one or edit existing one if there's a one for your entry for the kernel.org account. And just look for the examples so you can check how the other people add the repo file for themselves. So check for existing pull request. There's a bit more extensive wiki, because this repo file describing the repository for LKP has some arguments, some configuration options, so you can customize it. So I encourage you to go to the wiki or the questions and then check how to do it.
Microphone.
So what was the question? Can you repeat?
It's still free beer, right?
Yes, free beer, yeah. So it's still coming for free as a free beer. And so far, the LKP guys never said that it costs them something. Obviously, it costs them computation power, but they don't complain if you add your tree there. Maybe after this talk, they will start complaining, but then it happens. So it's still free beer. Yeah. Next topic will be the applying patches. So I wish we have one tool which will help you apply the patches from the mailing list, and that people will not look for the patch, look for the tag which they receive, then download the patch, git commits, so on, right? So many people use different tools, different setups, complicated workflows like a patchwork client or mat or saving the patch and then git am. So whatever workflow we are using, quite likely B4, which is a new tool, does it better. So I encourage anyone who handles the patches through the mailing list or mailbox to switch to the B4. B4 is a Python package, so it's in pip, but also it's in the distro repositories. What are the benefits of the B4? First of all, it creates really nice thank you emails. I will also say a few things about the thank you emails. It can integrate with the patchwork, at least with the kernel.org patchwork. I'm not sure if it integrates with the free desktop, the DRM guys patchwork. It can apply entire series or individual patches, and once applying the patches, it automatically collects the reviewed by, tested by, and act by tags, and adds a nice link to the Linux kernel mailing list discussion. And all this comes automatically. B4 also detects newer versions, so if by any chance you apply older version of the patch set from the mailing list, it will find that there's a new one and will grab the new one. There's also a nice command B4 diff, which allows you to compare the versions of the patch sets. So V3 with V4, for example. And there are quite more. So I encourage you to read more at the Konstantin. So on the last Plumbers, or 2 years ago Plumbers, Konstantin gave nice talk about the B4 and the LoRa. So just go there and he explains a bit more. B4 has a very simple configuration. So in your kernel.org repository or maintainer repository, you just have to add one section for the thank you emails, if you want the thank you emails. And if you want the patchwork integration, then there are a few more comments. Once you do it, you just run to apply a patch before Shazam. Here I want to have the trailers from the cover letter, which means that I want to have all the reviewed, tested by, act by tags from the cover letter. If someone responds to the cover letter, then I want to have them. I want to add the link to the kernel mailing list. And finally, I want to add my sign off, -s, and I give the message ID. So before we'll grab the thread from the LoRa kernel.org, I will mention what is LoRa kernel.org at the end of this talk. Finds the patches, applies them, and because I have integration with the patchwork, it also updates the patchwork state. So after applying the patches are becoming under review on the patchwork, and they will get accepted once I send the thank you emails. So why I'm speaking about the thank you emails? I mean, why do we need thank you emails? First of all, to thank you, because it's a nice way to do. But also it brings the confirmation that the patch was applied, which is partially solving the problem with the Schrödinger's patch, but not yet fully. And the third thing, that you can put the useful information, like the link to the Git repository where it was applied, or the name of the branch. So the Schrödinger can check that his patch was applied here, and he can see, yeah, the patch is there, even if it's not even in the Linux Next. How to send a thank you? Assuming that you pushed your repository, your for next branch to your repository, you can list the thank you candidates with -l and then send them with -a-s. So this will automatically send thank you letters to everyone from which you applied the patch. You can customize the thank you email. You can add a more complex template. So for example, if you look at the Neil Armstrong or Mark Brown emails, their thank you emails, they're quite big instruction what will happen with the patch. So not only information that the patch is applied here, but also what will be the next step. You can also do it by if you wish. There are a few more useful options for the before. So once again, I refer here to the docs. With the applying patch, we cannot keep one important thing, which is the sign off. So this is not well known by every person, and even maintainers get it wrong. But when you apply a patch from the mailing list, the DCO, so Developer Certificate of Origin, requires you to put your own sign off. And sometimes people get it wrong. And if you do it wrong, you will receive an email from Steven, and your tree is in Linux Next. You will receive an email from Steven, and Steven will say that's missing sign off. You can avoid this email by adding a hook to your own repo. This hook will use a script. In my case, I took Greg KH script, verify sign off. And there's a link here to that script. And the script will check whether the signed off is proper, is correct person. You can avoid yourself email from Steven later. Another useful commit hook would be the one which checks the fixes tag. So the fixes tags in the Linux kernel is we annotate that we have a fix for another commit, and we point the SHA of the other commit. So in that case, we want to fix here some commit like this from the ERM tree. And one of the problems which appear from time to time is that you maintainer applies the patch, and then later applies the fix for this patch, and there is a reference, so fixes, one commit points to the fixed commit, and then the rebase happen. If rebase happen, the original commit which introduced a bug changes. So, I mean, the commit SHA is different one. Therefore, the fix points to the different tag. And this is a really issue. If you check the mailing list, Steven sends like a few emails per month that the fixes tag points to the wrong commit. Again, you can spare yourself email from Steven and use a script which does it for you. So I took the script from Greg KH again, who probably took it from Steven Rothwell, I guess. And this tag, this script will check whether the fixes tag is correct in your case. Now, the script checks a few things. First of all, with the proper commit SHA, but more important, whether this is the ancestor of the commit which you are now doing, right? Because when you create a fix, I mean, you apply a fix from someone, you should fix a commit in your tree. You are not going to fix someone else's branch, right? It's always in your branch. There are very rare cases that you have to do it differently. Now, why I'm speaking about the commit hook? Because two scripts can be employed, can be put together in a commit hook, which will do it automatically whenever you apply a patch. And such hook could look that simple. You put them in some tools repo, you reference this tools repo. First, you run the verify sign-off, and then you write verify fixes. I took this idea of the commit hook actually from Lee Jones, who is here. He was using it for check patch. So I reference here the full hook which I have. And customizing it is very simple. You just have to point the path to the repository with this verify sign-off, verify fixes tag. You copy the hook to your Git repository, to the post apply and post commit, which means that the hook will be executed every time you apply a patch or every time you commit or rebase. So this will detect all the change, also cases where you rebase your tree and introduce new troubles with this. The hook doesn't fail the process, so you can still ignore the feedback if you want to, if you are sure that it's all good. So how does it look like? So this example here, I amend the commit and I introduce the mistake. The hook starts. I have also check patch in my hook. Then the verify sign-off script is executed, and he detects that the author is Raymond, but the committer is me, Krzysztof, and the sign-off is obviously missing. Eventually, he also, the hook runs the verify fixes tag. And the process is not canceled. I mean, I can ignore the output if I wish to, or you can change the hook, up to you. Right on schedule. Next topic, I want to talk about the Git repository on the kernel org. So if you ever have the kernel org account, which might be a bit minority here, you know that you can customize the about page. So this is the Git web interface to the kernel org. And by default, this about page displays the README of the Linux kernel repository, which is quite pointless because there is really no point everyone to read the README of the Linux kernel. But you can put there a bit more information about your tree. So who is going to pull, what's the point of this tree, few things, whatever you wish to put there. Like I put usually name of the branches. We have it described on the kernel org docs. The process of editing it a bit awkward. You have to edit some meta ref. You can do it either in the Linux kernel repository, which you are now changing, or create entirely different repository for this meta refs, up to you. There's a full guide on the kernel docs account. The next topic I would speak with the respect to the kernel org is the transparency log. So the transparency log recalls all the git receive operations the Git repository receives. And this is on the kernel org, and this concerns all of the repositories. We have a nice big explanation on the kernel org docs, but let me show a bit here. So, because first of all, you can browse the transparency log by yourself through the Git repository because it's published, but this is public inbox format, so you can view it also in your browser. You have to set up the public inbox on your computer, which is a bit tricky, but once you do it, you can see something like this. So this is the transparency log for the kernel org account, and we see here that there were several post-receive hooks, and different people were pushing different things to their repositories on the kernel org. The point of this transparency log is to have a proof, possibly like an audit, that people who were pushing something, and yeah, this commit got there because someone pushed this commit to the kernel org. If you investigate one entry here, so this is the netdev entry, you will see the repository we changed, which user, so this is probably Dave Miller because this is the name of his account, and what was the change for the actual name of the branch, I mean the chance of the branches. And this was a plain push. What I want to speak here more is about using the sign pushes. So even the kernel org docs are saying that there are cases that someone could impersonate or could have access, backend access to the kernel org infrastructure. Therefore, even the kernel org docs encourage people to use the signed pushes. Signed pushes means that the push is signed, not the commits. And hoping that every maintainer uses already signed tags, therefore he has a GPG key on a smart card, it should be pretty straightforward, right? Because everyone has the key on the GPG, on the smart card. If you have such case, right, then signing a push would be just a question from the push that, yeah, they want to unlock the smart card and that's it. If you sign pushes and then look at the transparency log, you will see a bit more information. So this is now example different. I'm showing different entry. The repository is from Greg Karmisk. The user is still Greg Cage, but below there are new entries saying that the sign was pushed, and this was signed with a certificate. And we know that certificate is from the Greg. So this allows us to be sure that no one from Linux Foundation, IT, admins, whatever, no one else pushed this, unless, of course, they have the certificate from Greg. This leads us to the interesting topic, which are the PGP keys or GNU-PG keys. Why do you ever need them? So if you are a maintainer, then hopefully you send a pull request to your upstream maintainer with the signed tags. because you should not use branches. Branches are mutable. You should use the tags. And if your repository is not on a kernel org account, but it's on somewhere on the GitHub, then Linux expects to use the signed tags. So he will reject your pull request if you don't use the signed tag. If you want to participate in the kernel org transparency log, you also need the signs. So these are both reasons why do you need the PGP key. One of the problems with the PGP key is that we expect them to be signed by someone else. So the usefulness of the PGP key pretty often comes with that it has some signature of someone who we trust. But it's not exactly true, because there's a usefulness of the every key, even if there are no signatures on it. There's a trust on first use, for example. And if you want to participate on the Web of Trust, then of course you need to collect the signatures. If you want to get the kernel org account, you also need to start collecting the signatures of your PGP key. I have very extensive guide describing how to set up the PGP keys, including the smart card. So I will not be going through it, don't worry. That's quite a lot of topics there. So go to the guide if you want to hear the details. But important part here is that we want also to sign the keys, because we want to build the Web of Trust. And usually we sign the keys in person. So this conference is a good idea. But we have also a map of kernel developers. Go to the map and find someone, a kernel developer near you, and go for the beverage of your choice. Signing usually happens, with signing in person, then you have to print the key. It has to be full fingerprint. I was organizing a signing event in the previous conference in Narrow Connect, and some people came with the cut fingerprint, not full finger. You also should show your ID, because you want to verify the person. And then, once it's done, the other participating party will send you the signatures for your key. But you don't have to do it only in person. Pandemic came and we stopped meeting each other. So there's a process for virtual, remote signing keys. So you can do it through a video conference call. The tricky point with the signatures is that once some person signs your key, only you and this person have this actual signature of your key. In the past, we were exchanging such signatures through the key servers, but it's not possible anymore. You cannot share you could try to share through the key server, but you shouldn't, because some of the key servers strip the signatures, so then you cannot. And the ones who don't strip the signatures, you should not use them. So that's why this is not the way how to exchange the key signatures anymore. The only way to exchange the signatures for the kernel org community is through the kernel org keyring. So we have a Git repository for this. And first caveat, that if you want to add yourself to the kernel org for sharing the signatures, you have to be already a kernel org contributor. So again, it comes for free as a free beer. It doesn't come as a free of effort. So feel free to add your key with the signatures to the kernel org account if you are a regular kernel org contributor. There's a bigger guide there, but if you don't want to read it, it's as simple as exporting the public part, the PGP key, with the signatures and sending into the mailing list. The mailing list is public. The second caveat is that you already need to have 2 signatures on your key to be there accepted. So we have a kind of way to avoid unnecessary work. Next topic would be dumping the mailing list. So there's a nice project called Public Inbox. If you never heard of it, it's the way to archive or store the mailing list in a Git repository for people to access, and also expose some front end to this mailing list archive. LEI is the command line tool, local email interface. LoRa kernel.org is the web server which exposes the mailing list for this public inbox. So why do we need it? Because the mailing lists are way overwhelmed. I'm not subscribed to the mailing list anymore, and I just propose to drop them entirely. With the public inbox and this LEI interface, you can follow the mailing list without being subscribed. And you can even customize it better because you can follow specific topics. So maybe you are not interested in entire part of the Linux kernel, or you are only looking for some drivers. There's again, I'm referring to the talk of Konstantin. So he described both before and Lore and Lei. So there are a bit more details in his talk.
Sorry, can you go back just a second?
Sure.
Yeah.
The slides are also available on the LPC events website. So I have here a lot of slides because I would also like this to be kind of reference for you, for your work, or whatever. So grab the slides afterwards if you need. So the Lei is the command line tool, which will talk with the specific server. And the benefit of the Lei is that it can download the emails based on your search query and put them, for example, on an IMAP server. So this, in my case, I store them on the Gmail account. The credentials for the Gmail account then are taken from the Git credentials, so the same credentials which you are using for sending emails or other ways of interacting with the Git. But you can also store the output of the Lei. So all the emails that Lei downloads, you can store them in Maildir if you use MAT or other local email client. This is the example of the search query, how to use the Lei. So I use it from the server called lorekernel.org because these are the mailing lists for the Linux kernel mailing list. I use the outputs as my Gmail account, and I put them under the specific folder, lkmldt. And the bottom is the search query. So I'm interested in a mailing list called device3. Once I set up such search query, I just keep updating it from cron or whatever other scripts or ways. You run Lei up, and this will fetch all the emails which appeared recently since the last run. And you can customize it even better because you can look for specific files. Like if you are interested in specific driver, like UFS Qualcomm, you can use the DFN, diff file name keyword. And this way you can really get some pieces of the Linux kernel discussion which is interest for you. If there's no dedicated mailing list for the subsystem, like for regulators, you can also look for the subsystem in that way, also with the search query. So also with the DFN, diff file name. There are more resources for this. So there's an LWN article describing the Lei and the Lore, and there's extensive help for all the search keywords. There are more search keywords which you can use to get the mailing list on your computer. This is the end of the talk. So I have here references. So this is why you get the slides later. I did all the links which I was talking here, all the scripts which might be useful for you, they're all here. And just grab them later for usage. And maybe we have some questions. Oh.
Oh, okay.
Yeah, that's a question.
So the scripts people tend to run have become more and more agreed, I think, over time. So I run a very similar set of scripts to you. Do you think it's time that we actually did push a few more of those into the main kernel repository so they're always available? Or are people just going to carry on arguing about it?
I think it would be cool. I mean, many maintainers have their own workflows, right? But if you are starting your task as a maintainer and heading some patches, then it's quite a lot of work to set up this workflow. So it would be useful if there's something already there which automates all the checks, all the things which you should do as a maintainer, as someone who handles the patches in the process of handling. So yeah, in the kernel.org.
Yeah, I have the same ancestor fix you do. So
there's one big question. Yeah.
Okay. So I'm one of those maintainers that should switch to B4, and I was wondering, is there any testing infrastructure that I could use before running B4 with real mailing lists?
A lot of the options provide dry runs. A lot of the scripts provide dry runs, so you can run it, get the output before actually submitting it to anyone publicly.
No, I'm good. I was going to say, in addition to the dry runs, you can configure like the thank yous to just pipe out to a mail, and then you can send it with send email. So you can add as much sanity checking. Like I send mine to myself, make sure I've actually sent the mail correctly, and then I actually send it to the people I want to. And you can do all kinds of verification. So yeah.
Okay, thanks.
Yeah. And with the before also you can save the thank you emails and don't send them by before, but look at them and send them with git send email by yourself, for example.
Hey, Christoph. Thanks for introduction to B4 tool. Does it support multi-factor authentication method for emails?
So before is only the command line tool, and to send the emails, it will use whatever the credentials are set in the git config file. So if the git send email, I think supports I think it doesn't support. So then answer will be rather not. I don't know.
Okay. And so to download the series of patches, it supports Patchwork Server 1.0 and 2.0, both versions. PW client script doesn't seem to support Patchwork version 1.
So which patchwork is supported? Then that's a good question. I know that it works well with the patchwork for the kernel org account, but I guess we are now referring to the other.
Yeah, other. Let's say company has internal Patchwork server running.
I don't know.
Okay.
I know that it doesn't work well, I think, with the free desktop org patchwork. So unless someone wants to correct me.
Oh, sure.
Yeah, so we have been using Patchworks internally, and I've been using before, at least in my workflow. It does seem to work okay.
In the interim, the other thing you can do, it's just Python and it's all open source. So you can just hack before if it doesn't fit your exact needs too, which I've done because they're just like, everyone wants to do their own little workflows. So you can just do whatever you want. It's Python.
Yeah, about getting your keys signed. You said that there's an opportunity to do that here in the conference.
Here, I mean, we don't have
GPG.
dedicated
What?
key signing event, but feel free to approach me, and or we can do it after this session if there's a time.
Okay, so I don't think I'll be ready. But so when's the next opportunity to have a key signed? I mean, is it really only in person? That seemed a little odd, but I was just checking.
No, you can do it through a video call. So then you have.
Oh, okay. So
set up
long
with
as they
someone
can
who will
see
sign
a
your
real,
key.
you're
Yes.
not a bot.
Or you can hang out for grab someone on a coffee, right? But then you find a person who is trustworthy to sign your key. I mean, because obviously you don't want to have signatures on your key from random John Smith, right? You want someone who is important in this web of trust. So you have to find such person, invite for a beer, coffee, and then.
I was important once, but I'm not important anymore. So, but we just should contact individuals.
For example, yeah.
Whatever.
Or let's organize it for on the next conference, like Embedded Open Source Summit.
Oh,
or Just
okay.
Open
So it
Source
doesn't
Summit.
have to be the next Linux
Or next Plumbers.
If you do get organized in time, just post on the hallway track and say, yeah, is anyone about? And I'm sure someone will reach out and say, yeah, sure.
Okay.
If they can find the stuff to do it.
So what you need for the key signing is to have it printed, and that's the only fully printed fingerprint. Question here.
A comment, there's B4 also supports sending through a B4 relay. We have a relay service running on kernel.org that will actually, if you don't have an email server that is good to configure with Git can send email, like it doesn't do SMTP, or your company does weird things like replaces all the links with weird sanitized ones, or adds huge disclaimers at the bottom. So you can send B4 relay that goes through kernel.org and will do the right thing with the patches. It's very easy to configure with before prep and before send.
Yeah, I focus on this talk on the maintainer aspect of the before, but before is quite a big tool and has a lot of useful features for the contributors. So whenever there is a person asking how to send a patch, I would say, yeah, don't do that like my way, git format patch, git an email, use before, because it's better.
Yeah, if you do hack before, do send it back to me, because I want to see the hacks that you're doing. I'm the author of before. Thank you.
Any more questions?
as a question.
Constantine, can you
Yes,
throw
can
it
you
back
pass?
behind you? Thanks.
So I saw that you used a Gmail there. I know like 6 months ago or a year ago or something, they changed how you authenticate, and I had to go dig around on GitHub to find a tool. I don't know, what do you use to authenticate if you send patches, or what does anyone else here use?
So I do use still Gmail, and I use the two-factor authentication, but the password generated for the application. So this password is stored in the Git credentials. So this, therefore, it's not like a plain text in your I don't know, home directory, but it's stored in my case, in the lib secret of the GNOME, I mean, whatever desktop there is. And Git credentials get to this secret, and then it gets to the passwords application.
Right. Whenever I have to send an email, I have to like run an application, and then I have to click a link and open it in the browser and then copy something back in. So I was just wondering if anyone else was, using Gmail to send patches and they had a better tool to use for that.
There are answers on the. Can you pass them the mic?
So I'm with Google, so I'm like forced to use Gmail to some extent. The way I hacked around it is I have a Chrome extension that I have binded to a key that greps the message ID out of it and copies it to my clipboard. But it works. It's amazing.
Microphone.
It's just that it seems kind of a one-off solution that I'm using. It's like some Go app that I found on GitHub, and I don't know how many users it has. Or maybe there's a more streamlined way. Because I do have like the app set up, and like I log into the app and it asks me twice, do I really want to log in? Yes. Well, yeah, until it expires, which is.
The next question. To the next question, you guys are together afterwards? Okay, fine.
So on the topic of B4, you discussed from a maintainer's perspective, but I'm wondering if we can make it more usable from a reviewer's perspective as well. So what I kind of do is before AM, and then I get the thread in my local inbox, and then I start editing through Mutt or something and review the patches. So instead, some integration with B4 where you can directly fetch the latest series, or I mean, B4 diff and all is useful that way to check diff between revisions. But to have a B4 reviewed by, where you can simply, automate the reviewed by process, is that something we can consider?
Yeah, I guess the idea goes there too. That man, Constantine. I think it's good. Yeah, good idea. Yeah. Great. Thank you much.
Is it in this one? Everything in there. We're in D. Yeah.
So just basically these arrows. Back and forth.
Like the arrow. So yeah.
Well, like I said, if you wanted to do it, what you're going to do is you've got your laptop set here. So what you
And
do,
then I can make presenter.
and then you just basically you do the take the presenter thing here on that. And you would basically, you give it right now the presenter here, but you take the presenter and then you basically.
Yeah, I know, but.
You're good. Okay, fine. I get you.
Okay.
Okay. So I'll let you.
Yeah, definitely.
I'll hold it. Okay, I got it.
Sorry, I don't have a radio.
Thanks. Yeah.
Am I supposed to start already?
Yes,
Can I go?
go for it.
Okay, let's go.
Yep.
Hello, everyone. My name is Andrea. I work for Canonical. I'm in the kernel team. And I would like to talk about kernel testing. And let me start with the first sentence. Testing kernels can be painful and slow. So what I mean with that is like, so being part of the kernel team in Canonical means that we are providing a lot of kernels with different flavors, different architectures. Sometimes we have to apply custom patches for a reason or another. We try to be good citizens and upstream as much as possible, but sometimes like we necessarily need to maintain custom patches. And when we do that, we want to make sure that when we rebase with new kernels, we don't introduce regressions. So we have large testing infrastructures, but sometimes when there's a problem or a regression, we necessarily need to, put our hands on and see what's going on. And so, for example, I'm pretty sure all of you are familiar with Git bisect. You have tried to bisect regressions. And, Git bisect is amazing. It's really effective. It's probably the best way to track down a problem. But the whole process is not like, it's quite painful, takes time. And at the end, it's rewarding because you find a problem. But to get there, that's not ideal. So, yeah, the thing is testing kernels can be painful and slow, mostly because there are lots of redeployments and reboots involved. Often, I like to start to redeploy a system when I need to run a test because I want to make sure that a run doesn't affect the next run, the results of the next runs. So starting with a fresh image is always nice. But independently on what kind of infrastructure you're using, it means that you need to wait. And wait time leads to distractions. At least I get distracted. If I need to wait and stare at the screen for 5 minutes, let's say, I would just check the emails or, I don't know, go get some food. So it's not even good for my diet. And that leads to unpredictable results, either because I get distracted and I make mistakes or because I don't know, there are the infrastructure fails to deploy an image, let's say. And so, yeah, approaching kernel development, I have the feeling that we are lacking the usual, fast edit, compile, test workflow that we have with user space applications. If you work on a user space application, you just apply a patch or make a change in the code, you recompile and you / the application, or you just click a button and the application starts. So yeah, having to do a lot of these tests was making my life miserable. And I was like, you need to figure out a way to speed up this process. Yeah, I was wondering, what if I can be able to create a virtual copy of my entire system on the fly? I can kind of fork my system and specifying a custom kernel and create an ephemeral image where I can do whatever I want. That would be an exact copy of my system where I can do all the changes that I want in a safe way. And when I'm done, I just power off the machine,
virtual machine, let's say, and I'm done. In this way, there's no redeployments involved because it's just immediate, start immediately. And can show you with some tricks we can achieve also extremely fast reboots. That doesn't save like the time, like doing a git bisect, for example, that doesn't save the time needed to recompile the whole kernel. But yeah, let's address that into a separate topic because now we're focusing at the deployments and reboots. So I started to look around, see if there was something, and I found this amazing project called VirtMe that is written by Andrew Lutominsky. So big shout out to him, because this tool allows to do what I was looking for. It allows to virtualize your running system, like create a live snapshot and specify a kernel that you just recompile or that you download the package and I don't know, you have a file with a kernel, you specify the kernel and it creates this live snapshot. It uses 9PFS to export the host file system into the guest in read-only mode because it's supposed to be safe. Like if you destroy your host, it's pointless. You can just reboot into your host. And writes are allowed in a tempfs home. So how many of you are familiar with VirtMe already? Raise your hand. Oh, so many people. Nice. So yeah, we should use VirtMe. I'm done. Let's can go to lunch. Now, the thing is, I was super happy when I found this tool, started to use it, but there was like, let's say it was covering like 80% of my needs, but there was still like a 20% that I wasn't happy about. And yeah, so this is the thing that I wasn't happy about. First one is limit and testing capability, meaning that exporting the file system in read-only mode makes impossible, for example, to install other packages, and I'm still limited to do certain tests. The other thing is performance. Even if like 9PFS is amazing and we had some big improvements in the 9P protocol with 5.15, still the performance were not like pretty cool. For example, just to give you an example, a git diff in the Linux source directory was taking 5 minutes to complete. So yeah, cool, but I couldn't do certain tests, like it was just impossible. And as a consequence of that, also the boot time was not ideal. Because like it was amazing, like it was taking like 15, 16 seconds to like get a console and me being able to run commands. But I felt that there was room for improvements. Last but definitely not least, the project is not maintained anymore, sad face. That was quite disappointing. I was quite disappointed about that. So because at some point I was sending pull requests on the GitHub page. Other people were, Marcus, other people were doing so, and they were just sitting there. So yeah, but hey, that's the beauty of open source. So we can see the source code, we can forward that, and yeah, and this is what I did. I also contacted Andy, the author, and for personal reasons, it doesn't have time to maintain this project right now. So I was like, yeah, sure, just fork it and continue that. So that's what I did. I tried to look at the pull request, merge what I liked. We created a new GitHub project with that. And I did some improvements. So this is a summary of the improvements that I have done, along with many others, but these are the most relevant, I think. So the first one is moving from 9PFS to VirtIOFS. So VirtIOFS, we will see in details in the next slide, but VirtIOFS is, again, file system that allows you to share like directories from the host into a guest, and it's more efficient than 9PFS. It requires a little extra infrastructure, let's say, on the host, like you need to run a daemon on the host. But yeah, with some little tweaks and works, we were able to support with IFS. And the other one is to use overlay FS across the entire root file system that is exported in the guest. And in this way, we can provide like read-write access. It's all ephemeral because it happens like inside the guest in an overlay FS. Like if you try to install a package, you can now. And this increases the amount of possible tests that you can do. Like, let's say you need to install a package and you do want to pre-install the package in your golden system on your real host. You can do that now. The other ingredient, let's say, the thing that I added is to try to use micro VM. I wasn't aware of micro VM before. It was actually a guy on Twitter suggested me, like, because I was tweeting about my progress on improving the boot time. Now I'm 1 second faster, 2 seconds faster. And at a point, he was like, oh, you should definitely try micro VM. It's in QEMU. It's like upstream. You can, you'll see. I have some results later. The other thing was so the original project was using a bash script. It's a custom init script. It was not relying on systemd, mostly because the original design of this project, and it's still the design is not to become a distribution, like a fully featured distribution, but the goal is to provide like the bare minimum environment so that you can do something. That's the reason for the custom init script. However, the bash implementation was relatively easy to maintain, but not in terms of performance. It wasn't amazing for obvious reasons. So I decided to re-implement the same script, basically, to kind of translating that in Rust. The decision behind Rust is mostly because I wanted to learn Rust and I needed to find a project. But at the end, well, it ended up being a nice choice because we can really improve boot time performance moving from Bash to Rust. And I have to say, like, in terms of maintainability, it's good. It's not bad. I mean, we can. I even tried to do that in Python because I was more familiar with Python. In terms of maintainability, amazing. But in terms of performance, it wasn't actually giving much benefit from having the Bash implementation. So yeah, This is getting into more details of the different things that I added. I just want to mention that Virtio FS can provide better performance, mostly because the real I/O happens on the host through the daemon. So it's the daemon that it runs on the host that performs the actual I/O, and file system semantic is exchanged using the fuse protocol. And then there's like a shared memory area where like all the I/O happens on the host and the data is copied on this shared memory area. And then then the guest can immediately see like the files that are read or written. It's an amazing project, really nice. And so this slide should be put on the homepage of Virtio FS. I think if you see the first result, I was pretty surprised to see that like the git diff in the kernel source directory that I mentioned earlier that was taking 5 minutes, after moving to Virtio FS, it takes like 1.7 seconds. So with this change, I was feeling very excited. Like I can almost give the feeling that you're actually running in your host rather than in a virtual machine. this one is a good result. And Git diff is, I mean, we see this huge performance boost because Git diff is generating a ton of file system requests, and that was tanking the 9p way because 9p needs to generate basically a message for each file system operation, and also the I/O goes through the 9p protocol. While with VirtIOFS, you just send the semantic and then the actual I/O happens in the host. The boot time was improved as well, not like amazingly better, but still, the reason is that during boot time we don't have much file system operations. But still, well, we can save some time during boot. Also, want to mention that I regenerated these numbers from using the latest version of virtme-ng, because like along with this change, I did so many improvements that if I would compare like an older version with a newer version, we would get just even better results. But I wanted to make sure that I was measuring the actual file system performance rather than side effect optimizations. So yeah, overlay fast. This one is straightforward. Was an easy change in order to be able to support and give the feeling of like you're actually using it. It looks like you're using your host because you can write whatever you want in the file system. You can read your emails, you can delete your emails, you can corrupt your file system, you can do all the writes that you want, and when you're done, you just power off or you exit from the session, the virtme session, and you didn't actually do anything. It's just you get back to your golden image. I want to mention, this is something, so the last one is something I want to mention. We had a bug where something odd was happening, like we were getting permission denied errors. And that's because like VirtIOFSD in the host runs in unprivileged mode, and it's supposed to access the entire file system of your host. OverlayFS instead is using implicitly injecting no time on any file system operation. My understanding was that it's doing that for performance reasons. But the result was that this no time was sent to VirtIOFSD running on the host. So if it was trying to access, let's say, /bin bash, it was accessing that with no time, but being an unprivileged, unconfined binary, you can't use no time, so I was getting permission denied. But anyway, long story short, this is fixed upstream because in VirtIOFSD, we decided to do like, if you're running unprivileged, unconfined, and you don't have permission on a file, we just drop no time. And I wanted to mention this because if you're using this and you're like, let's say you're stress testing no time, well, make sure that you import a separate disk because you can do that in virtme-ng. You create a file system there, and you're not using the actual, virtual VirtIOFS exported file system of your host because you may get weird behaviors. So don't waste time on that. And yeah, last one, well, not the last one, but another improvement, the micro VM architecture. So that it's just, you can pass some options to QEMU and it would boot this micro architecture design to optimize boot time and memory footprint. It doesn't have PCI or CPI, so you can save some time during boot. And as you can see, like the results it seems small, but if you use this tool to do mass testing across different kernels and in parallel, let's say, these small results can be significant. And still it's small in absolute time, but in percentage, it's like, like 2x, it's twice as fast. And yes, last point was to re-implement the init script in in Rust. That was also a big improvement. So when I say boot time 1.2 seconds, I mean that, let's say I recompile the kernel, I just finished. If I type VNG and I press enter, after 1.2 seconds, I'm able to run commands inside this virtualized system. So it's pretty cool if you like, let's say you're working on a bisect, make VNG and you can run your test case. So that's quite amazing. Just showing some graph for the things that I said, so it's already said that. So I was supposed to show a demo, but I didn't want to mess up with the whole setup. So I'll just say, if you want to see the live demo, just stop me, approach to me, and we can, I mean, I have a laptop with everything installed. I also made a video just in case, so if you click on that link, the slides are available on the LPC webpage. And basically, I can describe what I was going to show you. Like, one of the first example was this one that, you compile the kernel, you type VNG, enter, and you have a session shell inside with the kernel that you just recompiled. And in there, you can do anything that you would do into your host. Another example was you can use virtmeng to run scripts, like batch commands, not interactive sessions. So you can specify a command and it would run that in the virtualized environment. And that's cool because you can, I implemented the possibility to use standard input and standard output. So you can literally combine commands on your host, pipe something that runs with this kernel, pipe something that runs with this other kernel, pipe another kernel, pipe collect everything on the host, and print the result or send the result via email, for example. And in this way, I can parallelize, let's say, I don't know, 10 kernels all at once and collect all the results on the host. And it's pretty fast. I was supposed to show a little live demo of 4 kernels, and it completes in 2.6 seconds. So yeah. And the last example was to show you that you can also use this tool to test to run graphical tests. If you watch the video at the end, there's me running Steam on my client inside the virtmeng session, and I start a video game, Baldur's Gate 1, by the way. It's a cool game, good old Baldur's Gate 1. And you can hear the audio, you can play the game, it's not lagging, and everything is running inside the micro VM architecture. That's pretty cool. So yeah, conclusion. I would like to highlight the fact that maybe virtmeng can be used to finally have this fast edit, compile, test workflow also for kernel development. Also testing a kernel in 1 second, a little more than 1 second is nice. And I put 1 second, these are the results on my laptop. If I use this in my beefy server at home, I can break the barrier of 1 second. I can push this down to 0.8, to 0.9. Another point is I want to, so everything is backward compatible with the old virtme. So if you use virtme, everything should work. If it doesn't, it's a bug, and please file me a bug. I've heard some people saying, oh, I moved to virtmeng, but this particular feature, this particular command doesn't work anymore. If it happens, please let me know. I can fix that because we fully support, want to fully support backward compatibility. And another important point that I want to mention is the usability. I have the chance to work with students. It's a great opportunity. It's nice. I like it. And usually newcomers, or especially students, when they approach to kernel development, they are super excited, but they all of them, they struggle when you tell them like you should test this inside a virtual machine. They're like, oh no, now how do I deploy a virtual machine? I don't know what to do, and they get discouraged. When I showed them this tool, they were like, oh, okay, it's amazing because kernel development is not that difficult. So it's like, I think it's, potentially a way to attract new people. And I think that's interesting. I also wanted to mention, I put the last point because that was actually the topic of one of my previous talk at the OSPM this year. And I did a talk on how to reduce power consumption during kernel testing using virtmeng. So I put the link of the presentation at the end of the slides if you're interested to get some values. But to summarize everything, the idea, of course, was that you can save the time, redeployment time by using virtmeng, so that's why you can be more carbon efficient during kernel testing. So what's next? So the goal of this talk is to make awareness that this tool exists, increase the user base. I know there are users. Some example of some people in SUSE are using this one right here. Marcos is using for testing live patches. There are people from Google that are using it. People that we also have a Debian maintainer now that maintains the package in Debian. His name is Riccardo Ribalta. Big shout out to him. And so that means we have this package also in Ubuntu and all the Debian-based distros. So you can just apt install virtmeng. You don't get the latest version that gives you all this amazing performance, but we try to be aligned to the latest version. Otherwise, there's a code is on GitHub. You can download that, compile. So yeah, but the main point for me is to collect more feedback. So because now it's been pretty much designed to satisfy my own personal requirements, and maybe a little bit of Marcos as well. But yeah, we would like to improve this tool more. Another thing that I would like to add is but it's not a priority right now, is to fully support systemd. This is not trivial because systemd has its own state. So basically, when you clone your host into the guest and you try to restart systemd on top, systemd finds a previous state and it freaks out. So in order to fix this, we need to kind of mask with overlay FS the previous state, like deleting the previous state, and convince systemd that it's running on a fresh host, fresh booted host. The downside, though, is that it is not going to be fast as the custom init script. It will be still slow, but we can support more tests. So let's say you have a test that requires a systemd-based daemon to run. Then you may want to use systemd. For example, in Ubuntu, at some point I wanted to add the support to run snaps. And in order to run a snap, you need snapd. That is a systemd-based daemon. So if you don't have systemd, snapd won't start. So what I had to do is to kind of trick snapd and convince it that maybe there was a systemd running by creating a fake state in overlay FS, right? So now snapd is convinced and it starts, and I can run snaps inside virtmeng. And there's a --snap option to do so. It's not enabled by default because you don't want snapd running maybe by default. So you have to explicitly enable that. Another point is improve the support across distributions, but I think we're in a pretty good state now. We have the Debian package, Ubuntu, all the Debian derivatives, and people are working to provide an RPM. So if we cover Deb and RPM, it's, pretty much cover everything, I would say. Snaps, flat pack, I would like, that's probably a consequence of the systemd support. Like if we can properly support systemd, then we can properly support any other, packaging that requires daemon running. Snap support is working. I would even say it's stable, but using this tricky, hacky way. So is it reliable? Maybe. We don't know. Yeah, put some references here if you wanna try the tool. That's the homepage. The second link is my previous talk about power management stuff. VirtIOFS, QEMU, some references. And I think I am done. Questions?
Thanks for this work. I think you merged one of my patches, so appreciate that. One thing I could never quite get to work right in VirtMe was totally unprivileged my non-root file system thing. So I pull down somebody else's user space and I want to just exec that, but I can't extract it as real root, and so I have to do some ID mapping there. Have you thought about? Does it work? I haven't tried. Have you thought about it?
Yeah, I don't understand exactly the specific use case that are trying to do, but so are you using still 9P or VirtIOFS?
Either one. Right now,
Either
I'm still
one.
using 9P actually, but I could switch. My goal is just like I'm an unprivileged user. I want to extract some root file system and then run it in a kernel, but then I want to be real root touching the files as my unprivileged user.
So theoretically, like if the because at the end is a QEMU process.
Yes, exactly.
Right? So if QEMU has the permissions to access whatever you're trying to access, then you can. If QEMU doesn't have the permissions,
yeah, there was.
Yes, I see what you're saying. Like we should do something like give boost temporarily the permissions of the QEMU image.
You can kind of hack it. I just didn't know if this is
Yeah.
something you're interested in supporting.
So
fully.
one thing that is similar probably that I try to solve is, let's say, because we in VirtMe with NG we support like multiple architectures. So if you don't have, but okay, of course, if you're on x86, let's say, and you want to start a VirtMe NG session on RISC-V, of course, you cannot virtualize the root file system because the binaries are just incompatible with the architecture that you're trying to virtualize. So that's why there's a --root option where you can specify a different directory.
So actually, this is exactly my
And
use
that is
case.
exa-
Yeah.
So, and if the target directory doesn't exist, VirtMe NG would actually create that for you, downloading the files from the latest Ubuntu Cloud Images.
Okay.
I did that just for me because Ubuntu, so I use the Ubuntu Cloud Images. But to do that, so it gets the image, it untars everything, and of course everything comes as root ownership. So the trick that I used is really dirty. I'm just running chmod to give permission to access those files. Yeah, right now that's the only, but it's a good point. It's a good point. We should investigate something to see if it's possible to, that would be useful. Thank you.
Yeah.
You go.
Yeah.
Next.
Hello, Andrea. Thanks for your work on VirtMe NG. I believe that it would be nice if you could mention some other open source projects that are already relying on VirtMe NG.
Oh, yeah, that's a good question. So Matter, for example, is switched to VirtMe NG for their CI/CD workflow. And yeah, they're happy with that. So they can test their workflow, or I should say their requirement is to be able to test Matter across different kernels from different distributions. So they couldn't find a way to easily and quickly, cover, download all the kernels and then, okay, you have all these kernels, but I don't want to deploy a single VM for each kernel. I just want maybe to use my, a I don't know, a cheat root with the latest matter installed, and they can individually pick each kernel and just, create a virtme-ng instance and just test all of them. So they are happy with that. I know someone, I don't know if I can disclose this, but let's not say any names. Company X is testing webcams with virtme-ng. That sounds odd because I was surprised because I was like, wait, how do you test webcams? You're creating a virtual image. And the guy told me, well, you can specify additional QEMU options. And what they're doing, they simply pass like the USB, create a USB device, kind of pass through into the VM. And therefore, they're able to test webcams over VirtIO, USB, whatever, running different kernels. Other projects, yes, Marcos is using LivePatch to test LivePatch. There are probably others, but these are the ones that I know. Yes.
Are these VMs compatible with connecting to them with GDB?
Yes. So there's actually a --debug option. If you use that, you can the VM will be start with a GDB listener, and then I'm trying to remember because I implemented that and I don't remember. There's a virtme-ng command that you can use to basically, how to say, it would use QMP protocol, and you can generate a crash dump basically. And when you have, if you want, you can generate a crash dump and inspect with crash utility.
And breakpoints and all that.
Or yeah, breakpoint or whatnot. Yeah.
Cool. Thanks.
One question.
Behind you. Yeah.
Okay.
Yeah. You.
So thanks for maintaining that. I really appreciate that. One question. In my case, mod probe doesn't seem to work very often because it's trying to look for the host place for the modules. Is there a way to solve that problem? So mod probe, whatever driver I want to install, look at the kernel that I just compiled?
Okay, so mod probe used to be a tricky problem to solve. What version are you using? Because I think that was solved recently. Before, it was difficult. We had to do some tricks. Like right now, we are. Let's say you just recompiled your kernel. Okay. So what we do is if you point to the current directory, let's say you instruct virtme-ng to run the kernel from the current directory, that is the default behavior, it would implicitly run a make modules install inside .virtme mods and do some magic sim linking and actually mount --bind inside the guest to show your modules directory inside lib modules kernel version. So inside the guest, you should have transparently installed all the modules. So if you run mod probe and you have some dependencies, it should be able to pick up the right modules. Yes, Marcos.
Also, there was a problem that we fixed recently. If you are using a distribution that currently uses the user merge, it should try to load the modules from user lib modules, right? And this was fixed recently. Yeah. So maybe that was your case. At least that using to fail on OpenSUSE Tumbleweed, but that's fixed.
Yeah, and another problem that I found, but this is on Ubuntu in the latest version with Mantic, was that, so in Ubuntu we decided to move to XZ compressed modules, and that was causing troubles. So now that's also fixed. Like if you use XD compressed modules, it will unpack them, so you can load them inside virtme-ng.
So my question is very related to this topic, in fact. So one of the use cases that we have is we would like to build an initram FS to launch with virtme. It's currently possible to pass in an image, but the struggle is signed modules. So are there any future plans, for instance, to update the current init RAMFS functionality within VertMe to support arbitrarily building RAMFSs, so we don't necessarily have to pass in -- installed for the installed kernel and then install our modules in our root file system. So we can just pass in a kernel image, pass in an init RAMFS, have a boot.
Yeah, I'm glad you're asking this because that's one of the things. Like right now, I need to test signed modules, and I'm not able to do that with VertMe-ng. It's one of the things that is sitting there in my secret to-do list. I haven't looked at that because I don't have much. I mean, I know something about signed modules, but it's not my main expertise. And again, that's the goal of this talk, like collect feedbacks, and this is one of them. Like,
yeah,
I
mine
can
is
boost priority of my secret to-do list.
Yeah, I currently have a hack for this at the moment, but it's kind of messy. So I figured it'd be nice to have more support around building complete init RAMFS, swap out busy box for something else if we want to, and things like that.
Yes, that's a good feature that I would like to add. Yes.
For your modules, when you bind mount them in, is that a live mount, or are you copying to something within the guest? From the perspective of if you modify the module on the host, does that reflect into the guest immediately?
So if you, like, let's say you already started a VertMe-ng session, so the virtual machine is already running, and you haven't touched the module into the guest, any change that is done on the host would be immediately,
visible
forwarded to the guest. If your guest touched the module being a copy on write way, of course, at that point, as soon as you write something in the guest, the two versions diverge.
Yeah, just from personal experience, you might want to figure out a way to surface that to the user so that they don't recompile their host kernel and then end up debugging the wrong module.
Yeah, that's a valid point. Yeah, because the module may change underneath.
Yes, and especially if you remove the module to reload it with different parameters, and then you've got an entirely different module, and you sit there scratching your head for a while.
Yeah, thank you. So yeah, that's a bug. Cool.
I haven't tested the Virt.io FS yet. I'm still using the 9p, and there is a -- read write option. So I believe that everything that you write down, it's updated.
Yes, there is a read write option, but even if you use, because in that case we won't create the overlay on top.
I think so. Yeah.
So yeah, but it's it's read write is kind of
dangerous. Yeah. But if you like
if you're brave enough, just
at least so you can specify specific directories to be read write, so it's not that dangerous.
I just have my the modules binding so that you literally cannot add changes from the host.
So okay, you mentioned something interesting that I wanted to highlight. Like, is that even in the talk before this one, I always hear people, that because I'm doing this or I'm doing this, and it's great. And another big goal of VertMe-ng would be to provide a common tool to everyone, so that if you're not super expert and you don't have your little tricks here and there, you can start with that. So if you a newcomer, say, that don't have anything, that you can start with this one.
Yeah, and from a KVM side, it sounds like you don't always use KVM, but if you did, for new users especially, utilizing KVM trace points from the host to glean information about what's going on in your guest, and especially if you are brave enough to hook up BPF programs, you can extract a lot of information about the guest, especially if you have on x86 any kind of exception. We can often trap into information.
Yeah, that's really useful. Yeah.
Other thing too, I don't think it would have to be VertMe specific if you're using. So if we can get into the kernel, I would love that for just any.
I haven't checked if there are questions in the chat. Okay. No. Okay. Cool.
Thank you very much, Andrea. And we'll be resuming at 2:30 here in this room again for the preparatory track.
Okay, cool. Sorry? Thank you.
Your mother. Check, check one. Check, check two. This is Catchbox number 2. All right. Ladies and gentlemen, welcome to yet another quality sound check brought to you by this guy named Angel. Just going to sit here and be listening to various off sounds brought to you by me shuffling a Catchbox microphone into its box. But I know I sound good. Mute. Somebody came in and turned off the boxes, spared the battery. Yeah, I think they be coming in here doing like little stuff in there, like little. Oh yeah, no, I know who it was. It was just like because when I walked out, the Catchbox was still on. I only left it on because the battery is like what 12 hours life, and we have it on from what 8 a.m. to 6 p.m. Replace the battery at the end of the day. Oh, but yeah, I think we are good to go. I checked all 3 of my rooms. I'm gonna go and get the best exercise I've ever had in my life. I can't feel my feet. I can't feel my ankles, nor the bottom half of my shins. It's awesome. Yeah. And then on top of that, that entire statement just helped me with my sound check. Do I sound good? I love my voice. Thank you. All right. So I'm assuming patches are set and keep the lavalier on mute. Let's see if I can get a.
Sing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Thank you. Sweet. All right. You know,
I would, yeah, that was we learned better than fully to make it very clear, like you can see that.
yeah.
Still unloaded or did this disappear? Did I get it?
No. I mean, I was just setting up my own.
No, so. Where is this? Huh. No, it's come
I
see.
haven't touched this.
No, I know, it's come see.
Oh, I was just letting you know that the gas box is happening.
Thank you very much. Okay. Well, I'm here, so let's just, there we go. I've got to get off just a sec. Let's go to the meat.
While you do that, I'm gonna go check on the other room.
Okay, all good then.
Yeah, you just did
There
the
we go.
sound check.
Here's yours.
Recording.
Let's see.
Cool.
Take present here. I'll come up upstairs right now, okay? Because you should be able to select it from here, okay? I had to earlier, but holy shit, it's down there, but it's not there. is. We'll need to take 25 minutes. I'm going to upload the other ones again. I've got 1 minute. Let me just show you how to. Oh, sorry. This is sorry about that. I need to take center here because I was uploading the others right now. And then what we're going to do is go to yours. And now check that everything goes. Yep. Okay, thank you. And everyone's going to take that much.
Sure. Well, I'll see how much interest this talk has anyway.
I have respect for those who are online.
All right then. I guess I'm sorry. Okay. Okay, well, my name is Zeb Figuera, and I'm here to talk about a problem that we've been facing in the wine project that I think we're going to need the kernel's help to solve. So Wine is a free software project that comprises a Windows executable loader and a reimplementation of the Windows API. I've worked on Wine for about 6 years. I've worked on a lot of different areas during that time, both high and low level, for comparatively. When it comes to the kernel, I have exactly 1 patch in a kernel. It's to fix this little device here. But in this presentation, I'm going to talk about a low-level problem that we have in Wine, which is that our implementation of Windows synchronization primitives is too slow. So I'm going to talk about the problem that we have in detail and about the solutions and workarounds that we've tried so far. And how a kernel-based solution could fix this problem. So one of the interesting challenges we face in Wine is that we implement the entire Windows API in user space. So the question of interest to the Linux community is, I think, what happens when a Windows program makes a Windows system call into the Windows kernel? So for some system calls, we can just translate to an equivalent host system call, like file IO just becomes read and write, and memory allocation goes to mmap and so on. And usually the match isn't perfect. So Windows tends to have very over-engineered kitchen sink kind of APIs, which are sometimes possible to implement on top of simpler Unix POSIX ones, but usually we have to do some internal bookkeeping. So we have to implement a whole kernel algorithm in user space. And some parts of the kernel deal with shared state that is shared across multiple processes. And so for that, we have the wind server, which is another user mode process, but it implements a lot of the things that a kernel would. Anytime you have cross-process state that needs to be managed, the wind server gets involved. And anything that would be a system call then becomes an RPC request to the server process. And one of these things is synchronization primitives. So obviously, RPC to another process every time you do a system call is not the fastest, but in the majority of cases, it doesn't really matter. For over 20 years, we've been doing cross-process synchronization and everything else this way. But recently, more and more programs, wrong one. More and more programs, especially games, are making use of parallelization. And this is a screenshot of GPU viz. And basically, in that bottom row with the CPU graph, every little row represents a CPU, and every colored box is a different thread. And so when you have a colored box, that represents the time when a thread is on CPU. So this is a relatively modern game. You have games like this with 16 threads all constantly trying to synchronize with each other. And in order to do that, they have to call down to the wind server. And you can see the wind server process is basically pegged at 100% CPU. And the other processes are just spending all this time off CPU waiting for the wind server to reply. It's a pretty severe and proven bottleneck in a lot of games. And avoiding this overhead can literally double the frame rate of a game. The largest part of this overhead comes from the fact that wind server is a single-threaded process. But even if it were to be made multi-threaded, which is possible but not a simple task, I believe RPC to another user mode process is not going to be fast enough to match a kernel implementation. And of course, all of these calls are one syscall on Windows. So we think that's probably the right approach forward. So how do we solve this problem? I'm going to first explain the problem space. So first I need to explain a handle. What is a handle? A handle is a file descriptor. Okay, so I'm not talking about handles. So yeah, it's not really that complicated, and it's mostly not of interest to the kernel, but I want to add this for completeness' sake. Handles are like file descriptors. You can have multiple handles in different processes that point to the same kernel object, which is a file description in Unix parlance. And in Windows, you have handles representing a lot of different types of objects, more I think than in Linux or Unix usually. But the important ones here are the synchronization primitives. And there are three types of synchronization primitives, which are the event, mutex, and semaphore. And they work about like you would expect. An event is a single bit of state that you can flip to signaled or unsignaled. A mutex is a simple recursive mutex, and a semaphore is your usual semaphore. You can acquire up to a maximum count and release it. And the wait function is essentially like pull, where you pass a vector of objects and an optional timeout, and it tells you which object ended the wait, or if you timed out. But as you may notice, there is no API to acquire a mutex or semaphore, and that's because that's what pull does. Acquiring and waiting are the same operation on Windows. You can also create an event that gets acquired when you wait for it. So this is the basic way Windows synchronization primitives work. There's just three objects, and you acquire them by waiting for them. It gets more complicated. So here's where the Windows API goes from good straight to ugly. So the first weird thing is called pulse event. And what this does is if any thread is currently waiting on an event, it wakes up that thread as if the event was signaled, but it doesn't actually flip the bit. Which begs the question, how do you know whether the thread is actually waiting? And the answer is you don't. But the way it was actually used in practice, and I say was because it's very rare nowadays, is you'd use it on a recurring timer. So it doesn't really matter if you miss 1 or 2 wake-ups. Mutexes have their own little ugly detail, which is that they're tied to specific threads on an OS level, and if a thread dies, well, they have built-in support for abandonment, which is like a pthread robust mutex. But you can't turn it off. This is just on for all mutexes on Windows. Semaphores are okay, but the wait function has 2 interesting problems, where one thing is you can, instead of returning as soon as any object is signaled, you can return as soon as all of them are signaled at the same time, which is not the same thing as waiting on them one at a time, because objects can be signaled and then unsignaled. And the other ugly part is this thing called an alert, which is kind of like Windows's version of SIG.io, but it's done completely differently. Instead of setting up a signal handler at the kernel level, you basically, every time you do a wait, you specify whether you want to get an alert signal. And if you do get one, then the kernel will call your user space IO function for you, and then it'll return back to the it'll return back to the wait function with a special return value that says you were woken by an alert instead of anything else. So this is the problem space we have. Is there a user space solution? It's a common bit of wisdom that you can implement any synchronization primitive on top of any other one. So a few years ago, I started looking around for a primitive that specified or that satisfied all of the major constraints we have, which are you can do a vectored wait and you can use it for multiple processes. And Linux has one that satisfies this, which is eventfd. So I wrote an implementation that's where each Windows object is backed by an eventfd and some extra state for bookkeeping the more complex objects that lives in shared memory. And it works, and a lot of applications get big performance improvements from it. But there are some problems. Wait for all is very badly emulated because you can't just do that with pull. We kind of have to hack around it. And pulse is even worse and basically doesn't work at all, which is particularly unfortunate because most applications don't even use those APIs, especially not the modern ones. But we can't have a broken implementation in the wine tree. And so I've had to maintain these patches out of tree for several years. I'd like to find a better solution. Soon afterwards, I wrote a variation that uses futexes instead. This eventually led to the futex waitv syscall, which is in the kernel now. The idea was that since futexes are faster, assuming they're uncontended, that this would be faster than the eventfd version. And in artificial benchmarks, it is, but in real-world applications, the difference is basically never enough to matter. It's certainly faster. It's again faster than the server, but it's about on the same level as the eventfd implementation. And of course, it has the exact same problems. You can't do you still can't do a wait for all, and you still can't do a pulse correctly. I've thought for quite a long time about other ways we can do this in user space. And really the big problem is those 2 APIs, the wait for all and pulse. Because in order to implement them right, you really need control over the underlying wait queue implementation. But, well, these objects are cross processes, so we need our wait queues to be cross process, which makes things very complicated. I've thought about implementing a wait queue in shared memory, but then you have this problem where you need to take internal locks on the wait queue, and and the wine server also needs to take internal locks on OAQ. And the wine server has kind of a security boundary where we treat it as a sort of a privileged process, even though it's still user mode. We don't want one process to take down the entire wine virtual machine, as it were. So that's not going to be acceptable upstream, even if we can make it work. So after trying a lot of different user space solutions and managing to make none of them work, I tried something else, which is I tried to write a simple kernel driver that implements all these operations into kernel basically directly. So every set, reset, wait operation is just an IOCTL. All the wait queue logic is implemented into kernel on top of your schedule and wake up thread. So all the hard parts are taken care of by the kernel in this case, and everything works correctly. And for the mutex thread knowledge, in order to avoid hooking into any other code, I basically have the wine server keep track of thread IDs, and it sends a request to the driver to mark all mutexes owned by a specific thread as abandoned when we detect from user space that thread dies. All the complicated front-end stuff, all of these hard parts are done in the kernel. All the complicated front-end stuff about handle management, that's still done in user space by the wine server, because we still don't need the create and destroy and open things to be fast, or all these special objects. These special objects that you can also wait on are sort of, we pretend they're an event underneath. And it works. It provides the same benefit as the eventfd and Futex implementations do, but has the add benefit that it also doesn't break everything else. So this is a benchmark from Total War Saga Troy, taken by Dmitry Skvortsov. You can see the optimized version is running at 158 FPS, whereas the version that goes through the wine server runs at 109. So it's almost a 50% improvement from that. Some other games have even greater improvements. So this is a collection of various games from different people on different hardware. Excuse me. Many of these, as you can see from the table, do make 60 FPS even with unmodified wine, but they're also taken on relatively powerful hardware, and so you're going to see the same improvement on any hardware that is CPU bound. So what are the next steps then? I originally wrote these patches intending to submit them as an RFC to the kernel, and maybe that is the right option, but in the spirit of the Linux Plumbers Conference, I figured I would first give a presentation about the problem and see if there's any other thoughts on how we can solve it, whether that's user space solutions that we haven't considered or other ways to design a kernel interface. One thought I've had is, instead of writing this self-contained driver, can we fit the solution into the existing APIs like pull? But I don't really think I'm inclined to think this is not a good solution, because first of all, pull really is not designed for atomic weights, and it's not really designed for wait for all either. And adding these things, which are kind of ugly APIs in the first place, it seems like it would complicate a lot of things. It seems like it would be an easy way to break things and really encourage people to use ugly APIs that should really never ever be used by anyone. One other idea that I had on the train ride over here, which was, we believe that the biggest bottleneck is the context switch itself, the syscall, and we believe this. Well, first of all these APIs are one syscall in Windows. And when developing these, the EventFD implementation, I found that even making 2 syscalls instead of 1 you'd see a noticeable drop in performance from that. So you're really trying to minimize the number of syscalls we make. So, and knowing that, maybe there's a way that we can, and this is a very half-baked idea, but maybe there's a way we can do a syscall trap to another process, which without making a lot of context switches and waiting for that process to be scheduled. There's a lot of complications around how you'd handle virtual memory and such. I don't know if this, I'm not knowledgeable enough to know if this is immediately infeasible, but I thought it might be an interesting enough idea, and frankly, it could be useful in other ways. I mean, if in the future other parts, more complicated parts that are not so self-contained need to be faster, or has implications for Wine's. We have a sort of limited support for running real Windows kernel drivers, which believe they're in the kernel and they're actually running in user space, and all their hardware access gets sort of virtualized, and it's complicated and very low level right now. But there's some things that could be useful there. Or maybe there is a real user space solution that I haven't considered. I've certainly thought about this problem for a long time, but I'm only one developer. Or maybe there's a better way to do this in the kernel. So that's, yeah, with that, that's all I have for a presentation. I guess it's a little shorter than I thought it would be. So the proof of concept kernel driver is linked here, and it's also in my in the page on Indico. If you have further questions or comments after the conference about synchronization or anything else in Wine, please feel free to reach out to me at my email address. Thanks to my company Codeweavers for bringing me here, and if anyone is interested in working with Wine or other parts of the Linux stack, we are currently hiring new developers. And so with that, I will open the floor to questions, I suppose. Okay. If there are any.
I'm going to start off with one question. Have you been looking at the potential implications of working with the real-time patches that are going upstreams and what you've been working on here?
I have not.
Okay.
I'm not aware of, does the real-time, make RPC significantly faster is a big question. We do, because all the RPC to Wine server goes over a socket, and I think
it's not that it would make it faster so much it makes it deterministic. It's just that it's going to be there. So that's
sure.
Why
it's worth testing.
It's worth looking at while you've got the people here. Anyone else? Okay.
So I have a question. Do you have the same problem also for the KID event API? And for the new style, what do they call it? Slim locks or something like that?
So KID events. So KID events, I think, are cross-process.
So sorry for those that don't really enjoy that much Windows synchronization primitives. KID events are kind of the Windows equivalent of futexes, so to speak.
Yeah. Well, it gets more complicated. So Windows has a couple kernel APIs that deal with what's supposed to be like single process synchronization. So excuse me. So KID events are one. There's this other thing called a thread ID alert. The thing about these is they're not exactly exposed in the same way, and I think they're only supposed to be used from a single process. And so all of these other APIs that are used for synchronization, we can actually just implement those right on top of Futex, and we do. And so those aren't a problem. And you'd think, your games and applications would be using those APIs, but some of them do. a real world use case for, doing fast cross-process synchronization, especially with things like cross-process rendering and GPU management.
So the question I have is, when you look at like event FD versus the Qtexes, like was poll always the problem in both those cases? Like you would have to fix poll, or would this be easier to fix on event FD or Qtexes if you were trying to build out something there? Like, and is there a possibility that an API here could be useful for other things? That's why the distinction I would have between doing a separate driver you've got the concept of is that's very specific for your use case, and that could be accepted on that ground. But if there's something that could be useful for everyone.
So the main thing about it is, so the easy parts you can. The thing about it is most of the things you can do with your event FD and poll, or with the Futex vector. The problem is the big problem is Pulse, which nobody should ever use. Microsoft even deprecated it. And wait for all, which I don't know that I've ever. The thing about the really unfortunate thing about wait for all is like I think people that even do use it, they don't depend on the very precise semantics that it has, which is it's one atomic operation. I think people they want a convenient way to wait for a bunch of events at once instead of having to one by one wait for them. That's my suspicion. So I think in terms of having this, so I think there's not really anything that would probably be usable by other consumers, but I also don't have a lot of experience out of wine. I know the people who tend to care about these things are database stack, and I don't have a lot of experience in the database stack. So if there's somebody who could potentially give an answer on that, it would not be me.
Yeah, it seems that the performance justification, like it's pretty considerable performance increase with these kernel space synchronization primitives. Out of curiosity, I don't track the wine project super well, but if this patch was to be accepted to kernel, would this be the first time that a kernel patch was made exclusively to make some functionality in wine perform better, or has there been precedent for this in the past?
So the Futex WaitV was originally for wine, but it had other users. Wine has not tended to require a lot from the kernel, partly because we can implement it all in user space. There's also a talk that's going on at the exact same time. There's a current effort to implement the WriteWatch API where we need to. It has some very complicated semantics that we can't do fast because in order to do it slowly, we need to catch signal access on write. Sorry. Basically, Windows has a copy and write sort of API, and we need to, and we can implement that slowly by catching signals, but there's a current effort to get that, and it's not quite upstream yet. But I think that also has other users too. So this would probably be the first case where we really just need this just for wine, just to make things fast.
I can, for some parts, I like that technical depth, but I have some gut feelings about your approach, and I think you should try to upstream your current approach. I really think the self-contained version is a good start, because then you can have this separate driver and people see what you need. And I think chances are, you can give the reason of the significant performance boost, and if it's a self-contained driver, why not have it? So I think I could imagine it's well received. The only other gut feeling I have is if the IOCTL interface could be, if there's maybe a better solution, but I can't give you one right now. I just wonder. Because IO-CTL interface these days are usually frowned upon, but sometimes it's the only thing we have. But in general, I tend to think go for it.
Okay.
Anyone else? Oh, got one more. Okay.
Could you do something that's kind of like a halfway between doing a complete driver with all of these ioctl APIs for each sort of thing, or just doing something that's like, hey, this is just one ioctl that does what I want with pole, reinvents pole, but just with that one extra semantic or that extra piece, so that you still use Vutexes or event FDs as the base of it, and you build just the one piece. Because
So Vutex is kind of, you can't really do this with Vutexes because one of the things you need is atomic consume on weight, and that's not something you can do with a Vutex because they're really just not designed for that. I looked into not extending pole specifically, but the problem. I tried to look into retrofitting some extra stuff into EventFD, and when I looked at it, it was the way I don't remember the details at this point, but the way that pole is hooked up with EventFD really just I couldn't find a way to do it without messing with the pole method in general and upheaving everything else. So that might be an option. I could try and look into it again, but I suspect it's not going to work.
So since you have any way to combine these primitives with all the other handle types, is there a way to combine like the fast path in user space, full user space, and the slow path in either kernel or wine server?
Yeah.
I mean, I'm sure that you have thought about it.
No,
It's
no,
just...
that was specifically a thing, and I did try this, and the problem is because you can wait on any object with any other object at any time, and you don't know which ones are going to be used cross-process and which aren't, or which ones are fast and which aren't. You can mix anything in a wait. And often you will, you wait on an event or a thread, say.
So how do you combine this kernel driver with other handle types?
So the other types, so for example, you have threads which are signaled when they exit, right? It's like it's your PID FD, and basically what we just do is, so the driver exposes like IDs based on an X array, and so underlying an event, we have an event, but underlying a thread is just an event, and the wine server decides when to signal it. It does a set event call internally on that.
Okay, so you turn those others into these ones.
Yeah.
Okay.
They're basically all events.
We've got on the chat from Rahul. Since this is the first time Wine is looking at upstreaming a kernel module, what's the project strategy for handling kernels that are missing the module in its build/distribution?
It will not be a hard requirement. This will, and for that matter, Wine supports all sorts of hosts. We try to run on anything Unix, and we have a compared to many projects, we have a very permissive approach when it comes to requirements. When it comes to version and the dependency requirements. So we have fallback paths for pretty much everything.
Cool.
So yeah, in that case, we'll basically just fall back to the old implementation on the server.
Okay. I think we've got all through the questions, so thank you very much. And we'll probably have a few minutes before the next speaker, but
sorry, I didn't intend it to be quite that short, but.
What's wrong with that? Yeah. What's next one?
My research API knowledge is like kind of exhaustive. What else?
Hi, I'm audible. Can anyone confirm?
Everything's straight now.
If you can start recording for the next session, just so we don't forget any of those. Thank you.
No, the internet modules, just that's. Yeah. So we need. Well, probably, especially if you care about it.
Right.
It's not like a
Are we missing something? No, somebody just wrapped the building, so that's all.
Yeah, so code reviews. Right, well, it's tough. As you get more not that much shopping volume, it's not exactly. It's, well, not suggestions, but what do we have in Minnesota with lots of large and foreign responsible large corporations? And not lots of, sort of alien. Which is why there's the like a minor company. Just something. Yeah. Well, yeah. Again, it's recognized my mentoring two knowledge, but use it to its I even have to tell you anything that's kind of access. Trying to find the right balance of yeah, well, it also makes like it's tough with you're trying to argue. Please keep it. Have to make it happen.
The biggest concern is like, I know it's like if I come to the kernel and say, hi, I want to do this with this API, this kernel, no.
Which is exactly what you're trying to do. Which is you're doing it for bigger reasons.
But I'm just trying to, I don't think we have a
Too small. And it's like, you're also like, please tell me to don't turn.
like the Americans, I call the thing. I did not want to do that because I didn't want to.
I wondered if they were looking through like conference abstracts around the, wait, we're going to.
I was like, I actually call my state, which is a there.
It is, but I like, it is,
I keep saying whatever he says.
well, I'm here.
Hi, Kate. Can you hear us? Yes, we will be presenting remotely. Uh, can you hear us, Kate? Okay. No, Kate, I'm not on mute. Vamsi, can you try to speak something?
Okay, we've got a remote presenter.
Hi, can you hear me?
We've got a remote
Yes,
presenter.
Vamsi, I can hear you.
Hopefully, we can hear him. Can you hear him? Unmuted, so you should be able to hear him. He is talking, so something's coming through.
Can you hear us now, Kate? Seems like online guys can hear us, but room
Probably
they are
have
not
to
able
fight
to
with
hear
him
us.
saying what to do in case of a remote presenter. Because all this stuff that, yeah, all the stuff that picks up is coming from over there. I'm gonna get
Should I
somebody
go
over there.
turn the mic on over there and then see if it comes through that way?
Um, is there a way to connect the, the computer to have like some type of audio port up there?
Well, just a second, leaving audio. Here's the other device. Here's- Second. Try speaking now, AJ.
Hi, Kate, can you hear us?
Yes, we
Okay,
can, but we're going to have to cut down the echo.
I didn't sign up about this. I didn't tell me anybody about having a remote presenter. So.
Yeah, no, it's been part of the contract. Someone else. We've got a remote presenter coming in and we can't get him. It's not showing up on the audio. Okay.
Is he talking, do you know?
No, I think you dropped off. So, let's see if we can get.
In case you want to go next step, this one just has to be a
So I wonder why there was feedback and stuff like kept echoing. It was like loud, boring sound. I kept going.
You want muted up there, you're gonna have problems. So don't unmute it over there.
Oh, I didn't touch anything up there. I just
Unmute on your laptop.
muted. Oh.
Yeah, he's trying to off.
Let's see it. It'll do blue on the outline. when
Yeah,
it's
it was.
talking.
It was doing blue when he was talking before.
Oh.
Not picking him up.
Can I ask him to do it again?
You guys hear me? Actually. Go ahead, Dan.
Is it fine? Shall we start?
Yeah. Yes. Oops, we got it. Yes, Jay, we can hear you now. Go ahead and start. Hopefully you've got the presenter controls, so you should be able to move the slides back and forth.
Yes, Vamsi will start.
Yep, please start.
Hi, thank you for attending this talk. I'm Vamsi and I have Ajay and we'll be presenting our slides on improving memory usage for SysFS and ProcFS. Next slide, Ajay. Our agenda for today is to go through a high-level architecture of SysFS and ProcFS, which is relevant to these slides, and an access walkthrough when a file is accessed for SysFS to identify the code paths that are relevant. And then we'll be presenting our problem statement, where we go through the different scenarios and the place where we would like to improve in terms of memory usage. And then we have a proposed solution and the readings we have taken before and after the change. We'll also go through different combinations that we have tried and the results we have got. Next slide. So in this slide, we can see a high-level diagram for SysFS. As we know, SysFS is a pseudo file system. It leverages parts of kernel FS, and its primary purpose is to export kernel objects as files, where user space can tune different attributes and adjust to the user's requirements. So there are three top layers here. One is the common VFS layer, and then we have the implementation from core SysFS, and then there is kernel FS from which SysFS borrows most of the code. So the implementations for logistics of creating files and their relevant handles are handled by kernel FS. The root itself is maintained by kernel FS. And SysFS manages the file IO binding between a given kernel object and the actual file handle. The important thing to note here is that for all the files and folders that are created for SysFS, the inode and dentry entries are actually stored or shared with the common VFS layer, which means that the inodes are co-located with other inodes that are present for file systems which are disk-based or block devices. In the picture, we also represented the two shared caches, which are inode and dentry caches, and they are in slab memory, where there are a series of slabs allocated, and each slab could contain potentially one or more active objects. Next slide. So similarly, ProcFS also is a pseudo file system which exposes processes to and their internal data to user space. There are only two layers here. Most of the implementation is within the ProcFS code. The operations are shared from VFS layer, but the cache that are used for storing different inode and dentry entries are within the procfs layer. They are not shared with the common VFS layer. And the primary data that is exposed is of process and their threads. There is file handles, and there are internal values from the task struct that are exposed through file 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 based mechanisms. Next slide. Here we are actually walking through what happens when we try to access a particular path from sysfs. So the path we have chosen to demonstrate this is syskernel boot params version. When we do a cat on it, it prints out the boot protocol version, which currently is 2.15. So the first step is for the kernel FS layer to do a lookup for if that path exists and try to find the inode that represents the path. Because we are first time accessing this path, it wouldn't be able to find it. So it would try to allocate a new inode for the given path, and it would try to associate a D entry with that inode. Once this step is complete, the control transfers to the registration that happened for sysfs, which it tries to find the method that was registered for the read operation on that path. And therefore, it will find out that version show is the function that's supposed to print the boot protocol version. And once it is done, the kernelfs layer tries to unlink the file. But after unlinking the file, it does a dput on the D entry and inode, where it adds the corresponding inode to the LRU list. So, which means it is preserving or retaining the inode structure so that if we access this path once again, it would not have to reallocate it. But as we saw earlier, one of the primary use cases for sysfs is to dynamically allocate and remove, meaning it doesn't have to retain in all scenarios. Next slide. The highlighted portion in the middle is where a new allocation happens and a new association with a D entry happens. And this is where the problem statement and the appropriate solution lies. Next slide. With that background, we try to present the problem statement. Because sysfs and procfs, once the use case for a given path is done, and when the unlink happens, they retain as many inodes as possible in the LRU list. The amount of memory that is allocated to these entries in a given time, let's say during boot or subsequently when a significant amount of paths are accessed within the file system, the amount of page allocations for these file systems would be very high. If you see in the picture, for the given hierarchy, let's say A, B, C, and 4. Once 4 is done accessing, it would stay in the inode would stay in the LRU list. And therefore, subsequently, when we access 3, it would still remain in memory. And as we access more paths and more hierarchy, all of them would be retained until there is a memory crunch or somebody explicitly drops cache on a given machine. Our goal here is to reduce the overall memory required during boot and later subsequently for the amount of memory that is required for sysfs and procfs. Ajay would continue with the solution we have proposed and the readings we have.
Yep, thanks, Vamsi. I hope I'm audible. So here we are proposing a solution where we want to use this flag that is decache, don't cache. So basically here on the left side, we can see a green box which is having few elements which we call as a metadata. So these are the metadata for any file system. Most likely we can say as for the procedural file system. So let's take an example of this sysfs or procfs. So while creating a sysfs procfs, so first we will store the data of file or folder in form of metadata. So in case of sysfs, it's being stored as a kernel fs within the system. So here in this diagram, we can see ABC, those alphabetic boxes are representing the folders, and these 1, 2, 3, 4, these numbers are representing the files. So we can see A is having B 1 and 2. So whenever the user will access, let's say it will access the 4. So this request will go to the VFS layer. So VFS layer will first check whether A is present or not. If VFS layer is able to find, not able to find the A, so correspondingly look up function of that particular file system. So let's say in this example, it's a sysfs. So sysfs lookup function will be called, and it will pick the metadata, pick the metadata for A, and it will create a A. So similarly, again for B, C, and 4. So right now, if we are not having anything, so here we can see the inode used and D entry used are 0. So once we will access this 4, so it will create. And for each element, it will use one inode and one D entry. So there are 4 inodes and 4 D entries we are using. So let's say now we are accessing the 3. Similarly, A and B was already created for the VFS layer. So VFS layer will bypass the calling of lookup for A and B, and it will directly call the 3. So, so as of now, whatever we have seen on the slide, so this is already implemented in our kernel. So now the next step is what exactly we want to change for these procedural file system, most likely for sysfs and procfs. That is, so up to now, whatever we have created as in the form of inode D entries, so these are in the system. Once the user will close these files or last dput we will call. So at that time, these files, as per the current implementation, these will go to the LRU list, and it will remain in the memory till there is no crunch of the memory, till user will not call the drop cache or anything. It will be remain in the memory. So once so once we will call this last dput. So let's take now with our implementation, that is with dcache don't cache. So what is the difference here? We don't want to retain these inode or d entries. So if we will add this dcache don't entry, so it will directly, it will not put into the LRU list. Instead, it will directly go into the RCU list to free these inode and d entries. So now here we need to understand two steps are there. The first step is, if we will free these d entries, it will go back to the cache and slab layers. So it is ready to be reused. And if there are a lot of free of these D entries and D caches, so it may happen, it is actually happening in the system. So in sometimes we will free the slab from the cache, and which eventually free up the pages. So our main idea is to either keep this these to be in the slabs or free the pages if it is not required. With this implementation, these are the readings which we got. So here we are comparing with the current implementation with the don't cache file or folder. So at the first line, we have seen some degradation, or we can say side effect. So boot up time earlier in our system with the current implementation, we have observed like it's 1 point, sorry, 8.143 second, which is increased to 8.3 739 second. So this degradation is because of a lot of access of the lookup. So in the next point, we can see sysfs and procfs lookup called. So this is basically we have measured during the boot up time. Uh, Whenever we will access sysfs and procfs, so the lookup will be called. So with the current implementation, the count is around 10K, and with this implementation, this count has been increased to 45K. This is because in this 10K current implementation, we were not retaining anything. Sorry, we were retaining the files and folders, but with 45K, we are not retaining anything. We are keep on flushing and recreating all the entries. But the benefit we are getting that is here in the inode and D entry. So with the current implementation, just after completion of the boot, we have seen these inode and D entries is being used that is near to the 11K. But with our implementation, because it is keep on freeing and regenerating, so it is near about 2800. So and memory free, we have observed just after the boot that difference is near about 11 to 12 MB. So with our approach, we are having more free memory of near about 12 memory. And there are some experiment we have done, like if we will do the drop cache immediately after booting the system. So these inode and D entries, so which is around 11K. So this is reduced to 1800 in the normal case, and it should be the same. So these readings are almost same with this one. So this is around again 1800, and the memory free in this case is again 7 to 8 MB. So now we want to access the sysfs completely. So with find command, we completely access the sysfs. So this again increased from 1800 to 4700, but in our case, it just increased from 1800 to 2200. So here we can see a difference. So here in this current implementation, it increased like 3000, but in this case, it increased just in some hundreds. And memory free, again, we are having near about, I guess, 9 to 10 MB of memory. So here, as we have seen, there is some degradation which is not acceptable. That is in the boot time. So what we try to improve this is here. So in this approach, we try to apply this decache don't cache only for the files. We don't want to apply for the folders. So if we will apply this only for the file, so what is happening now? So we are basically combining both current implementation and the decache implementation. So current implementation will be for our folders, and don't cache will be for our files. So we have already seen whenever someone will access, so we will be having inode used 4 and 5. So in earlier case, if we will apply don't cache for file and folder both, so these value will become 0 once the access is done. But in this case, it will become to 3, because all the files will go away whenever there is a last deput, and only the folders will remain in the LRU. So in short, with this approach, your folders will be retained, means all inode and D entry will go into the LRU list, but your file and folders will not be retained on the last access on your last deput. So these will be erased. So these will go to the RCU list and will be freed immediately once the access is done. And now because there are a lot of files will be freed, maybe you can say in that during the boot time. So a lot of uh, free slabs will be available, lot of objects will be available at the slabs, and if there are more than files which is present in the slabs are freed, so we will be keep on freeing the slab. So this way, this will give us more benefit in term of like there is no side effect. So here we have added the last part along with this one. So the first middle one is again the current implementation. The second one is don't cache file and folder, and the third one is don't cache file. So in the third one, we can see our boot time is slightly increased, but it is almost same as the current implementation, which is now increased from 8.143 second to 8.60 second. And this reading is because of this 19K. So this is now 19K. Earlier it was, I mean, with current implementation, it's 10K and it increased to 45K. And inode used is slightly more because now we are retaining the retaining the directories. So this difference here from 8 to 2800 to 60 is because of we are preserving the directories. Okay, and mem-free, earlier it was high, like 10 to 11 MB. So now it is less, near about 6 to 7 MB. And if we do the same experiment, so these values are almost same inode re-entries, and there is a slightly difference in the memory because same thing we are preserving for the directories. And if we will access sysfs, so it will be now slightly increased because in this case, direct, I mean, D entries and inode for directory will be retained. And with this approach, we got a slightly not better as much as we have already seen in the file and folder, but better than the current implementation. So near about 6 to 7 MB of the improvement we can see without any side effect. So that's all. If there will be any question and answer, we are happy to access.
Thank you. Hey, this is Greg.
Hi, Greg. Nice to see you.
Okay. Why do you feel that using memory for cache is bad? We have the memory. It's free.
Mhm, mhm.
I haven't understood the problem. So far, you've actually shown that the design of sysfs is working. So what's wrong with using
I can
cache?
try and
I guess my question.
yeah, I can try answering that. So what we have noticed is when we have virtual machines or Linux machines with small memory footprint, for example, let's say something has to run with 256 MB of RAM or maybe 512 MB of RAM in embedded or in a small virtual machine. The short-term memory pressure when booting or when accessing is much higher in the current implementation, which means that the rest of the system, when it has to load other things, would have lesser memory at hand during this process. So, because we do not need all of it at once, one of the special cases is booting, and next subsequently when the system is booting up and a particular device structure is getting accessed. So what we have noticed is that it increases a short-term memory pressure during boot and during specific path access, which could be improved, and therefore more things can run at the same time. Yeah.
Okay. That was a design decision. We did this. We used to have it with no cache, and it was fast. It was slow, and it didn't use any memory. And sysfs, the way this is designed, is to go fast. The problem is big machines, 30,000 disks on a 32-bit processor, 10,000 processors, fun things like that. The people working on this have been eking out small percentages of speed over the past couple of years, and we cannot take any patches to make this slower. It's just not going to work. So I'm all for saving memory, but this is an explicit design decision of this code. So it's working as designed, but we can't go backwards. So short-term memory pressure for virtual machines is, I'd say just fix your user space processes not to scan, or give it a boost of memory or something else. Anyway, that's why it is the way it is, and that's going to be your pushback if you ever try and send patches like this, just to give you a heads up.
I have a question on top of that. So can this be optional for a type of file that is accessed? For example, if a certain machine wants to do this with lower memory pressure, so instead of making something default, we'll leave the current default on, but we could, for example, during opening the file or in any other form, make, or even as a boot param or other ways, make the selection optional, where the default would remain the current default. So certain lower memory machines can benefit from it, and the rest can use the normal methods.
I'd have to see that. I doubt it. You're not going to be able to change user space. And you're not going to be able to change sysfs, because the reason kernelfs is there is to try and do this caching layer. And that's why it's the complexity as it is. That's why the extra indirection is there, and it's all to go faster, because memory is there, the cache is there. So the best thing to do is just boost your memory in the beginning, then shrink it when you're done. You're a virtual machine, you can do that. Booting is very rare. So, and people care about boot times of virtual machines too. Everything's a trade-off, right?
Greg, why this sysfs and procfs is different? Why procfs is not using kernelfs? Anything you are aware of?
Yeah, because it's just history. Nobody did the work. procfs was first, and also the use case is different. procfs, procfs is hit hard, really hard, really fast for lots of monitoring processes all the time. So it's tuned for that usage model. Sysfs is tuned for you open a file every once in a while, and it is not a fast path, except a boot. And then you cache it, and then you walk away with the memory. And then it's just so, I mean, you can try converting procfs to kernelfs, but I think it'll slow things down and make the people who are running the monitoring tools very upset.
Hello there. So my name's Steven. I'm probably one of those people that Greg's talking about that would be that are eking out the small performance gains on procfs and sysfs. So I can confirm a lot of what he's saying there. In particular, these are all shared data structures. There's only one, and when you've got 100 CPUs, it's just a horrible place to all be contending for them. But that aside, it seems like this is a sort of thing that could be done, maybe not on a per file basis, but maybe as a configuration, a config time, or a boot parameter, where they can statically enable this at boot time. Like, I don't want procfs to be cached. That might be an option to look into, and it would satisfy people like me who will never enable that. But
no. I mean, the whole goal is having a general purpose operating system is to work just barely for everybody. So that would add complexity, and we don't want to add module parameters. We want to add command line options. It should just work. And right now it really works well for speed, and that's what it's designed for. Whether you get speed or you get memory, it's the trade-off. We made the design decision of speed because memory is free and speed isn't. So that's just the way it works. So I mean, and you guys proved it very well with the benchmarks. Thank you. So it's working as designed.
All right, so I'll give you a little rest from that one with a trivia question. Why does the system call read of proc interrupts take a long time? Why does it not complete reading the entire file in one read and come back?
So
Do
I
you
have
know?
I have a syscall for this.
Do you?
Like, I do. I have a read file syscall.
Really?
And I propose it every year. It's in my tree. I rely on it on my systems, but it turns out it doesn't really save any time.
Oh.
It turned 3 syscalls into one, but it just, I keep wanting to patch you to what the base for proc or for the monitoring tools. We tried it and it maybe it ekes out some performance, but nobody's been willing to.
I can't
accept it.
understand why this is sitting in memory. It's a memory file system, and I do a read, and I say, here, I have 4K buffer, and it just says, oh, we'll give you the first few lines, and then come back for the rest. I'm like, what?
Well, no, yeah, I have a patch, I have a change for that, but it just nobody wants to take it, and I'll submit it again.
I don't understand the cause. I'm baffled because I actually have some tools, and the slowest part is reading proc interrupts of my tools, which is just blew my mind.
So,
Anyway.
hey, maybe I'll
All right.
let you take my syscall.
I'll test it for you.
Just would there be any advantage in like making a drop caches equivalent that's less, it doesn't drop everything. It just drops these ones. Like, you've gone, because I'm sure the boot they've done is to a shell, not to like when you've got a desktop with UDEV and you've got a whole other stuff like that this is useful for. But when you've got to a sort of I've booted, just
shell.
Drop these ones. You don't
Well,
need
a shell, if you just boot to a NIT, you're not going to hit syslabus.
No, but I mean,
It's
I'm
hitting,
sure they're booting
it's
into
hitting
like,
syslabus, right?
like with a login, just not a graphical login, like with all of the extra stuff that probes. But just to that, UDEV is running. But at that point, is there advantage then to just having like a drop caches just for these bits because we know we're never going to need them again, rather than so just get rid of the LRU after a few seconds. Or
But that's what the LRU does.
does it get rid of it after a few seconds? Or just leaves it in memory.
It leaves it for forever until it leaves until there's memory pressure.
Yeah, but is there an advantage then of asking whether they
Okay, so
drop
it leaves it until memory, but I don't know, does that help?
I don't know. That's what I'm just wondering. Would it make sense to have a drop caches, with less? Don't drop everything.
Maybe on a file system basis, but then you got to touch the BFS and entry by no.
Yeah.
Oh yeah, online? I think it's your turn. You have the raised hand.
Yep. Oh, thanks. Can you hear me?
Yes.
Yes.
So I have a separate question. So if we let inode goes away, how can we persist the security blob so that such as SE Linux label or the SMAC label, which is previously set into the file? How can we persist that kind of information?
Is your question what would happen if there is any SELinux context on the file when it was dropped?
Yes, and we actually saw this behavior with proxy control file where we set some SMAC label, and after the memory eviction, because some memory pressure, all the labels are gone in the proxy control files. So this may be okay for the sysfs file because it has some patches applied more than decades ago. But the same problem may happen in all the proc files.
So yeah, we haven't seen it in this perspective. We'll have to understand when these are. So the use case is to label procfs paths and you wanting to retain it even though there is a drop cache. Is that the use case?
Yes, basically, yeah.
Maybe it's a little beyond what we have presented in the sense since the problem exists for any drop cache, meaning any memory pressure. I directly don't have an answer. We'll go back and check if it's feasible. But if anybody else has something to add, please do.
Yeah, I think it's not too general because if the file system is backed by the persistent storage, the same information can be relayed from the physical device and set it to the inode security blob. But I think this is only for the issue with the memory-only file system, such as sysfs or proc.
I can't say I can add anything to the security here, so I don't want to change the topic unless somebody else is already
Okay.
has more info on that. Hearing none, just wanted to throw out the other thought here that this feels to me like a failure in caching a little bit, or I mean, this is not a failure, but a cache policy choice, and I have had my own frustrations about memory getting used by Dentries in different workloads that and inodes that just sticks around for a long time. And it would be really nice if user space had more control over a policy that was in use for the LRU. Because you're right, as it is, it just sits there until there's memory pressure, and then either memory pressure, like say you're a big system, memory pressure never hits, and then you have some issues due to some other issues due to lots of Dentries or whatever. In your case, the memory pressure does hit, but it sounds like then it's too slow to free up that memory or some other issue. Perhaps a solution for everyone here is some sort of policy management on the LRU.
Isn't there a C group for that?
A C group, yeah, that's a good idea.
I
for some of
mean,
that,
just
yeah.
do the init and assign your sysfs walking program to a smaller memory allocation, and away you go.
Idea.
Hey, it's solved in user space. UDEV and systemd should probably be in its own C group anyway for that.
Here, here.
I know. I mean, seriously, there's nothing wrong with that. Okay, thank you very much, and everybody will be back in a half hour.
Thank you.
I bit my tongue so hard. Look, it's turning into something.
You are currently the only person in this conference. You are currently the only person in this conference.
Happy that he was able to kill that real fast. Right. Because there was a simple mistake that could have happened in the end. I'll trash these old batteries. Are y'all good with batteries? We just, did we change the catch box? Okay. Angel. Okay. Nice, look. You've been holding it down. I ain't gonna lie to y'all. You've been holding it down. You know it. I don't know. He seemed like a rookie now. Yeah. Even though it wasn't something just happened. Yeah. The internet got disconnected. That's how it was. Because it showed the two blue screens at the top, and then the middle screen was what would be doing in the other. But it turned blue and showed no connection where the screen is at. So we're all set. Thanks a lot, man. No, I'm not talking to you, Tim. I've been giving you your credit all day. I mean, Tim was like, thanks, I do it all the time.
No, I was thinking you.
Oh, me. Yeah, well, they got it straightened out. It went offline. They must have got it straight off. I don't remember that. I don't remember. Yeah. What room was that? It was in B. He closed it up. Okay.
We can just forget about that.
Hey, it was a power outage. A power outage. I was stuttering.
That's what we'll say.
When I left, that happened. It's like the third time I came over. The first time wasn't on me. The second time it came over. And they said, well, they mentioned me about that in October. Stop. That's why I just told my guys. Because we keep leaving. We need to have runs that have this. Like when it comes to questions. Yeah. And we got to leave. My guys. Trying to test me like, how do I work? And I always think that's not your job. I'm not mad at that. Why don't we fix it?
How we looking, bro?
We good. They set everything up.
Yeah, Magnolia was a 10-minute break, but you got that situated.
You know anybody need any 9-volt batteries?
That's a negative so far.
Come on now. Everybody say that, but you don't talk to somebody on the phone, or you go in somebody's house and you don't hear that detector going on. Smoke detector going on. I be hearing people in the smoke detector beat like
to drain batteries.
Yeah, the 9-volts are not good.
Right, they're supposed to be industrial alkaline.
They always tell us to do it earlier.
Do you have the pen on you, your marker? Yes, I does. Make sure y'all bring y'all marker tomorrow, because I ain't got no more markers for y'all. I'm gonna leave it right in my bag. Well, you can leave it right up here. Well, yeah, I can leave it right there. I'm just, wary of people snatching markers, because I'm guilty of snatching markers. Well, I'm gonna tell you now. I thought I brought mine with me. Oh, no, well, I have 12 back. So I have 12. So we're still pretty good. Did we wipe these? You said you wiped everything down. Oop, yeah. And I left everything out. One is showing that we have 2 bars. I just installed that one, like literally. That's why I said they be acting up. Yeah. It'll show you 1 bar on here, but 2 bars on. Like we don't even have this. I did not switch the. Oh, did we switch 3? Huh? Did we switch the trackers? Because that's the one thing I did not keep track of. The trackers. No. Did we switch it? We didn't switch. Yeah, you just switched the trackers. I didn't do anything. Some of these, they probably came here and did it. So. Yeah, because they did. Still. Those are dead. So we must have switched the tracker. Okay. Can we see the count? Is it moving? Can we get a check on your pen? On the tracker joint? No. Can you gotta let it get a feed on one of the trackers. You got 2. This one's 2. Or 4, whichever one applies. I seen it move. It's not moving now. I think it's moving for yours. So I'm the other one. We're good. You can't follow me that fast. That's on him. Cool. You took it off the charger. So when you took it off, it started reading it, and you can cut it on. So now, can you put it on 1 for me? You mean 3 or? This should be 1. Oh yeah. Whichever one I was on. Yep. There we go. All right. I see it moving. 301. Still on there. I think it's 4. There we go. Yep, we good to go. All right. So with your Sharpie, make sure you write that down. So this one's 3, this one's 4. Yep, 3 and 4. So 2 is considered 3, 1 is considered 4. Or you want to just put tape on top. This is all. Something I just noticed that involved in the I'm trying to think. I'm going to make sure that
This is it, right?
It's a little drop. Really wet. There you go. 2 New York. What part of New York? From Queens. See, how did I know? I knew both of y'all. I'm from the Bronx. But I've been down here waiting. Let me get that paper. This is. Yeah, switch it up. And then tomorrow we'll go back. Well, this is tomorrow we don't have a different paper. Yeah. You put it on yours too. I mean, it's a memory thing. This won't stick because I had it laid right here. It's probably 1, 2, 4, C2. Okay. Because you got the 1 and 2 on the other side. Yeah. more so other.
You about to be loading or you about to stay here?
I'm back and forth, but this kicks off in like 2 minutes, so I'm gonna stick around. Still left.
See what's going on. There's been a lot of funny stuff going on. Our presentation.
It's shown on the master sheets.
Yeah, something else popped up before. I think it just.
I'm gonna let you know. So that says as soon as they wrap up, and make sure all rooms are. They ain't wrapping up till 6. I know. I'm trying to leave it till 6. It's my Ravens game. You did. Oh yeah. I saw the end of that game. I just heard about it. I took a nap. I sat there and said, "Oh, I know this guy."
I mean, I watched him occasionally.
Okay, I just need to.
Terrible.
Hey, if you're a fan, you got to stick with the bad. It's been.
Okay. But I don't need anything else rather than just next and thanks.
I scream bloody.
Okay, and if somebody asks a question,
Somebody asks a business.
Yes, yes.
A local Jersey boy. A local Jersey rookie. Like, man, just throw it. Every time you throw
Yeah, no problem. I'm not. Yeah,
I didn't see it.
Okay.
I didn't see it. I just seen this. Nah, I didn't. But look, he did. Hey, look, he did the one thing that Jones couldn't do: score.
Yeah.
Are you a fan?
Hello.
No, I'll just be watching like every now.
Okay. So, I'm Abel Vesa, and well, Visa actually, and I'm here to talk about the powering up of. Powering up of discoverable bus attached devices on DT platforms. Or how Linux Valet put it, discoverable buses that aren't quite discoverable, which, I mean, could have been the title of this talk. So let me first start to talk a bit about who am I. I work for Linaro, and I mainly focus on bringing Qualcomm upstream support. I've been involved in almost a year now, which is how long I've been, well, actually a year and a half almost, which is how long I've been with Linaro. I've been working on bringing up 2 of the latest Qualcomm platforms in upstream. One of them is still ongoing. I'm also the maintainer on IMX, the NXP's IMX clock drivers. And yeah, one of the coolest things of working in for Linaro on Qualcomm platforms is, well, I get to understand the hardware bits, but with a kernel perspective in mind. So I'm a software guy after all. And by the way, this is my first attendance at LPC, so yeah. Thanks. So I've split this talk into 5 parts. I'm gonna talk about, introduce basically all the players and what's the disconnect between the discoverable buses and devices on DT-based platforms. Then I'll go through a very specific use case, the Wi-Fi and Bluetooth use case, which is found on quite a few Qualcomm platforms, not only, but and including the laptop that I have right here, the X13S, Lenovo ThinkPad X13S. And I'll go step by step for this one. Then I'll go through some of the solutions and workarounds we were considering for fixing the PCI Wi-Fi issue we had. Then I'm gonna talk about the power sequencing subsystem, a proposal that was done, I think, in the last decade or so, and how it would solve at least half of the problem. And then the second part of that would be USB onboard hub use case, which solves the other part, basically, and how it could be still a good fit for us, but it's, let's say, more hacky. And then at the end, I'll share some of my thoughts and ideas about the possible solutions and what could work. So let's go through introduction first. Why is this important in the first place? So since it becomes more common and the problem itself, and it's having impact on both the power consumption and adding support for new hardware, and I'll explain that later on. I should probably describe what a discoverable bus is and then non-discoverable bus as opposed to discoverable one, and what a DT platform based is, just to make sure that we have the basis. So a discoverable bus is basically any bus that you have any kind of interrogative action over the bus in order to figure out if there are any kind of child devices attached to it. Usually you have a controller that starts this action and then enumerates whatever is found on the other end. And examples of such buses are PCI, USB, SDIO, Slim bus, so on. On the other hand, non-discoverable buses rely on information provided solely by device tree, board files, ACPI tables. Examples of non-discoverable buses are UART, SPMI, I2C, and so on. So what's a device tree-based platform? So compared to any other ones like board files or ACPI, the devices along with the resources are described in device tree files, and most of the ARM-based platforms nowadays are DT-based platforms. So what's the disconnect between those two worlds, the discoverable buses and DT-based platforms? Long story short, discoverable bus, a device that sits on a discoverable bus needs to be powered on in order to be discovered. And since DT platforms don't have a way to do such thing, most of the time we end up forcing resources to be always enabled. And this has an impact on power consumption, obviously. So I know the title of the presentation is about discoverable buses in general, but I thought that discussing a specific scenario would help make it more relatable, and maybe we fix it sooner. So I know there is also another talk in the PCI micro conference about this. I just found out it's not the same topic. It's similar, but not entirely the same. And there's also a buff tomorrow at 11, I think, where we can discuss. So if you're interested, be sure to check those out. So the Wi-Fi and Bluetooth case on X13S. Since I daily drive the X13S, I'll talk about this specific case because it affects me directly. Leaving resources like regulators always on or things like that have a hit on the battery life. But this issue is not limited to X13S or even Qualcomm platforms. In fact, every DT-based platform out there that integrates any device over PCI actually suffers of this exact same issue. And the PCI is just one of the discoverable buses, so this issue is actually more common than we think.
But what is X13S? Can you share a few words?
Oh yeah, it's the Lenovo ThinkPad, this laptop actually, and it has, I'm gonna go through this, it's Qualcomm-based platform, so it's a DT platform basically. But yeah, I'll go through this shortly. Right, so PCI, Wi-Fi, and UART Bluetooth on X13S. So we have three components, basically, three players in this case. We have the WCN 6855, which is the Wi-Fi Bluetooth combo chip. We have the PMIC, which provides the regulators for the PMIC, and we also have the SoC, which is a Qualcomm one. Most of the support upstream has been done by, at least for the Wi-Fi, has been done by Johan Hovold, and he takes credit for this, but I had to do the same thing a couple of weeks ago for the latest compute platform from Qualcomm. But I'll focus on X13S because it's more available and everything that I'm presenting here is already merged upstream. So if anyone wants to have a look, yeah. Also, the X13S scenario is interesting for another reason. It's because it also uses a non-discoverable bus, the UART one. So we can see the differences between the discovery process and what's missing with respect to the discoverable buses. So the X13S uses WCN, as I said, and then the PMIC and the SoC. And there are a couple of things that are controlled by the SoC on behalf of the Wi-Fi chip, so the regulators and a couple of GPIOs. And those are important because there is an order of doing things with respect to powering up, which I will be getting into in the next slides. So this is how the hardware looks like. Now let's move on to kernel support. So we define the regulators, whatever, in the PMIC node. And this is just one example. By default, these regulators are left in a specific state by the bootloader. But when it comes to Bluetooth, we don't really care because the Bluetooth driver takes care of them itself. But on the Wi-Fi part, that's where the things are a bit complicated. And that's basically the problem that we're trying to address. So enabling the Bluetooth, basically we add all the regulators and the GPIOs based on the schematics that we were looking at, schematics. And the first regulator here is needed by both Wi-Fi and Bluetooth. Second one is just Bluetooth. For the last four ones are only Wi-Fi. Then they need to be handled in a specific order. And this is what we call a power sequence. And it involves toggling the enable GPIO and the software control GPIO as well. And again, this is part of the presentation as well. So for now, we'll focus on the Bluetooth. And if everything is correct, and from the point of view and obviously the driver, we have the Bluetooth driver probing successfully. Everything was easy, so let's just look at how the discovery process has handled this. And we can't really call it a discovery, but why not? So it's basically initiated by the Gen controller, and using the off-platform populate, which loops through all the child device tree nodes and registers each one of them as the device. This is why the device doesn't need to be powered on beforehand, and as it relies on device tree data only. So if the device tree says it's there, then there is no doubt about it. Now let's move on to the Wi-Fi. And we'll compare facts after. So In order to enable the Wi-Fi, we enable the PCIe instances along with the PHY. We boot, and if we're lucky, we might end up having the ATH probing successfully. But on the other hand, if we're not lucky, we don't get anything. So it doesn't probe. It doesn't get discovered. So we start digging and trying to figure out why it doesn't work. And somebody might point out that, well, we're lacking the device node. So yeah, sure. We should probably go ahead and do that. And so we go ahead and add the PCI host controller and the child device node for Wi-Fi, and we also add the regulators and the GPIO like we did for the Bluetooth. And for the sake of the argument, we assume that the ATH driver already handles those resources correctly, which, by the way, it will have to do due to the power sequencing I mentioned earlier. We'll discuss that later. But guess what? It's still not discovered. So we start digging again. We look through everything we consider might be a problem, and in the end, we blame the regulators and we say, you know what? Let's mark them as always on in device tree just in case. So we go ahead and do that. Maybe that will fix it. And when we boot again, the device is there. So gets discovered, probes. So that means we have Wi-Fi support. Okay, but what about the regulators that we just marked as always on? Those might raise some eyebrows when the support gets sent on the list, right? Well, actually, no, because this is already a known issue by now. But just in case, let's figure out what happened. So the actual discovery, in this case, it's a discovery. It's initiated by the PCI host controller driver via the PCI host probe, which ultimately loops through all the slots this time on the PCI bus, rather than going to the device tree nodes, and does some reads over the bus, and basically, if whatever device it finds, it populates that one. And yeah. But since the device wasn't powered up before, the discovery was failing. So it's obvious that any device that is not powered up will not be discovered and therefore not registered. But let's compare side by side the facts for Bluetooth and Wi-Fi. So Bluetooth is a platform device, which implies the second point, which is it's being discovered solely by the device tree information. On the other hand, Wi-Fi is a PCIe device, which implies the second point here, meaning it is discovered by bus scanning, which means device tree node is totally ignored. Then back to Bluetooth. Being discovered solely on device tree means that the state of the device doesn't matter, meaning it can be powered off entirely during discovery. Then on the Wi-Fi side again, being discovered by the bus scanning means the device needs to be discovered, obviously, and needs to be powered on during discovery. And last thing is that the device tree compatible string is used differently. So in case of Bluetooth, it's used for matching the device against the driver, while in case of Wi-Fi, it is actually used to match the device tree node against the device that has been discovered. Sorry?
No. It doesn't use the compatible property for matching. The mapping between device tree nodes and discoverable devices is done as the tree is walked, and it looked at the range property to find the slot number on every and device number on every.
So it looks for vendor and product.
No. The mapping between device nodes and PCI devices is done actually positional. Look at the depth cell. It look at the slot. Yes, you have to do that. Yes. I mean, I wrote that code.
But the device tree node gets attached only after the discovery.
No. The device tree node is attached to the device during the discovery. The device tree node is attached to the device during the discovery. By the time the driver gets loaded, the device tree node has already been attached. Yeah.
Okay, maybe I'm missing something here. So if the device, so first thing in the device discovery is reading the vendor ID.
No.
Yeah, because we do that before.
The order things happen is you read the device ID out in when you add the device, and then the node is added after that. So the problem is you can't.
It's part of the population of the truck PCI day.
Sure, but you're before you can even know to look for a vendor or device ID, you have to know where to look.
However,
that's coming from DT.
So I mean, we had that conversation the other day, but yes, let's not go down that path just yet.
Okay, all right.
There are a number of solutions here.
Okay, but
I mean, I had that problem on Macs.
Can I make a meta comment?
The point is, whatever you describe in DT doesn't help bringing up the device.
Okay,
So that's
I agree with you. Why did the hardware designers think this was possible?
Great.
This breaks the PCI spec. This is not okay. This is not a real. Yeah. I guess. So, on a meta comment, how does Windows do this? Oh, it's ACPI platforms. I hope so. So does the Windows ACPI plugin just know it's there?
No, there's some magic driver in Windows that does
we're
horrible
talking
things.
about DT-based platforms now. We don't really care about the other ones.
Well, no. This is an ACPI. It's an ACPI platform, right? This is ACPI giving you the device tree. Oh God.
Yeah, so it's solved in the Windows case by ACPI. When you power up either a controller or the root port, then it will behind the scenes power up the device as well. Well, it solves the problem at least.
Well, okay, so I mean, well, all right. Let's take a step back. It's an old problem. I had the exact same problem on PowerBooks and PowerMac 15 years ago. And you can understand for power management reasons, you might want to avoid the power spike at boot because suddenly you have to turn everything on to be able to probe it. That kind of suck. So I think there is a legitimate reason to want to be able to describe things that are not powered on. And there might be ways to do that on discoverable with PCI, such as PCI or USB. But let's not go straight to the solution just yet, because I think you want to say more things.
We have a both session tomorrow, and we also have another talk by Lizzie Hu. Oh yeah.
So I mean, I'll make a meta comment. We were asking for the people to design hardware to use the discoverable buses like USB and PCI for forever because they would solve the problems. They did.
We know
they
it
did
doesn't,
half of
though.
it. they put it on there, but they still didn't make it discoverable.
Yes.
But Greg, you have to realize this is Grant right here. So Greg, the reason PCI was really targeting servers and more higher power environments, and we're talking now about lower power environments.
Oh,
where
I know, but we've
right?
had
So-
PCI on these tiny things before.
Right, but the design wasn't originally coming up from that level, and the designers here were trying to save power, and they did.
I agree, but it's almost there. So close. Okay, fair enough.
Okay, so yeah, point is device tree node doesn't help with respect to powering up the device before discovery happens. That's the bottom line. Okay. So now that we know how this is happening, let's move on to the power sequencing that I mentioned earlier. I've said that there is a specific order that the resources need to be enabled to have Bluetooth working properly, and obviously Wi-Fi. So the way that the Bluetooth driver currently does is basically first enabling the regulators, then the clocks, wait a bit, then you enable the GPIO, which enables the entire Wi-Fi Bluetooth combo chip. Then you wait a bit again, and then you check for the clock supply from the SoC. This is all specific to the WCN6855. Other Wi-Fi combo chips have different requirements with respect to enabling those resources. Even the order differs sometimes. So for the platform devices, we handle this in probe, usually. The probe is the perfect place to establish the order that the resources might need to be powered on. But in case of the PCI device, the Wi-Fi chip that we described earlier, that's not the case, at least not for the power up sequence. You can handle those resources, but not when it comes to the power up. And this is where the power sequencing subsystem was suggested as a solution for this specific use case. And I'm going to talk about that for a bit. It was, so basically the idea behind was that you have a power sequencer that would be an entity that would provide abstracted power on, power off, reset operations for the consumer devices that have such a need. For example, MMC SDIO devices, the Wi-Fi Bluetooth combo chip that I just mentioned earlier, and onboard hub device, onboard USB hub devices, and list goes on. It's not limited to those. So it was initially proposed back in 2014 as a standalone subsystem. For some reason, it wasn't merged that way. So it was merged as part of the MMC subsystem. Then, fast forward 7 years later, there was another try to make this a standalone subsystem. And here is when we consider that it might be a solution for the Wi-Fi PCIe power-up sequence. So let's just look at how that's supposed to work. Basically, you would have a device tree, sorry, a driver for each PowerSiC device, provider driver that would implement some of those ops, not necessarily all of them. And then you would create the instance and you would register it with the generic framework, like the provider and consumer case that we already know. Now, someone might point out that this is actually overlapping with the GenPD functionality. Well, at least on the list somebody did. But the difference is that the GenPD is supposed to be used only for on-chip power domain providers, while this could be used for complex power sequences that use off-chip resources. But then somebody might say, why don't you do it via reset controllers? But the reset controllers does not offer, or at least does not map one-to-one with the ops that a power sequencer might have. So this is where basically the range of use cases for the power sequencer might be, and we might still need it after all, even for this problem. Now, moving on to the consumer side, you would get that instance and you would control it via some generic APIs. This can be extended later on if necessary, and we don't really have a specific list of ops that a power sequencer driver might need. So maybe you need a post power on or something like that. And from device tree point of view, you would have the power sequencer device tree property that is used by the consumer. And I think this is where Rob had a comment about the bindings, because it was using, I think it was something like BT-PVR SEQ. And he was against the bindings, so kind of died there. So in case of Bluetooth, this would work fine. We would just add the BT property instead of all these existing regulators and the GPIO, like so, and then you would have the same support that you had for Bluetooth. So on Wi-Fi, even if we do this, since it didn't work with the
That's actually, it should be really, it's really simple to write a PCI hot plug driver because I did it and I didn't know what I was doing.
I argue that doesn't solve the problem. We'll talk about it later.
It really does.
No, it doesn't.
It's simple because this is just like the old, and then away you go.
Guys, I think Abel needs to move on, otherwise we're not going to get done
Okay, fair
today.
enough. But I mean, this is almost what the USB onboard hub does because you're describing DT, a hub, and you know you can power it on because they had a DT binding, and then after that, all the USB devices are found.
Yes, but then we would have to go through all the Wi-Fi, so in this case, the Athero drivers, and add a
No.
platform.
No. You have so the USB onboard hub is all it is a hub driver. So
Yes.
you describe your USB devices underneath it, and you have an out-of-band power to turn on and off, control power management. Your DT, the way this works, the DT says, I have some USB devices under there. Here's the resources for powering on. And away it goes. It creates that, and then those new devices are found by the USB core, and away you go. So the way PCI hot plug works, you scan it, you find it, and then you hand it off to the PCI core.
So if I understand this correctly, you're saying add a hub.
No,
something like a hub, like
a slot. It's a slot.
Okay.
The slot is going to do your power management for this PCI device behind it.
But it still needs to handle every device out there that's over PCI.
Exactly. That's why PCI hot plug works today. You don't have to write. There's like 5 PCI hot plug drivers in the kernel. You don't have to. All it controls is the hardware that powers on and off a slot.
Okay.
Yeah. So the problem is that
we have support for that already.
Slot is
for slots, but that's standard PCI because it defines what the power rails are.
Well, no, you can have. Well, there's also platform-specific PCI hot plug drivers.
Right.
Because it came before they decided to standardize it.
Yeah.
So it can handle the kernel can handle any of these crazy things.
The problem is that here it's not platform specific. It's specific to the device that's behind it.
But, yes. So you write a DT that says the slot. Yeah. You say I'm slot 4, and 4 you then and you go and you create a PCI device behind it because then you probe the hardware. You can read the vendor ID.
So you would have a generic compatible that would match against the platform driver, which would enable all the resources, and then the PCI device would be discovered.
Yeah,
not a platform driver.
No. Well, there's a platform driver for the PCI slot.
Yes. Like yes, exactly. Yeah. Okay.
And keeping it out of the Wi-Fi driver means that if we have multiple different ways we attach the same Wi-Fi chip, that difference will be described in the slot representation or in the hot plug representation.
And it'll work for any PCI. It'll work for any PCI driver.
So a single driver for slots, basically.
So again, just like onboard hub, you do not have in the onboard hub a description of all the USB devices beyond that.
Well, they actually have.
They have. Those are describing the hub. Yeah, they do some other crazy stuff, but you can put anything beyond that, and it doesn't matter.
There's another solution here, and it's already done with the MDIO bus, which is also discoverable. And that is basically if your DT has a device declared, but you haven't discovered it, probe it anyway. So in PCI case, you would have to skip any config space accesses and jump into.
Yeah, that's going to be. Well, your PCI bus driver, that'd be a platform bus driver logic. That might be a lot more work than this.
Yeah. Isn't that what
you don't need a second driver?
Your Qualcomm PCI driver.
Yes. Yeah. So, Greg, I just want to point out the concept of a port under USB and a USB hub is sort of the equivalent of a slot. It's
totally.
The notion of that. So I just want Abel to realize that there's a parallel between the two buses and how they're discovered.
Exactly. Yeah.
Okay, let's go through the slides.
All right.
We can discuss this. Again, there is a BOF session tomorrow, so make sure you're there. Right, so it was merging 6.0, and with the purpose of working around the power up of the USB hub, which basically depends on resources from device 3. So just like the Wi-Fi and Bluetooth combo chip.
So remember, Wi-Fi is a device functionality. It's not a bus functionality. So it's independent. You can have the same Wi-Fi controller on a USB bus or a PCI bus. It's independent. So don't think of these as the bus issue. not the driver that implements either Bluetooth or Wi-Fi. Those are independent.
Okay. Yeah, it solves basically, so you already know, but it solves the problem by having a platform device which has the sole purpose of powering up the hub in order to be discovered, and then the onboard hub takes care of, the USB device takes care of the rest basically, and even the power sequence, the runtime PM of the USB calls basically API from, so this is what's weird about the USB onboard hub. You have two drivers which share APIs for powering up and powering down the hub. So that's why we wanted to
because
avoid that.
we don't have a standard API like we have for hot plug for USB to enable the driver of the device to interact with the power controller.
Yes, we do. That's the hub driver.
Yes.
That is, we have hub drivers. We have a generic hub driver. We have this now.
But this is
we wrote generic hub drivers, and these were the first ones to actually use the API.
Was that actually implemented
20
as a
years
hub
later.
driver? This is actually implemented as a hub driver.
Yes.
Because he said he has private APIs.
This is a hub driver.
Okay.
It creates platform devices, which I hate, but it works. We couldn't. Again, 24 cycles of that patch set. Who wrote that? They're here. Thank you. You put up with. You put up with me. That was horrible. I'm so sorry. But I mean, you understand my hatred of it. But it works, and it actually is. It's done in a way that's been flexible enough. It's handled like totally different platforms, and they all seem to work. So you did a great job. So PCI slots should do the same thing.
Hey, Lauren wanted to ask something.
Yeah, there's one thing that strikes me as a difference between USB and PCI here, is that mostly for USB device, you will have, at least if it's a hot pluggable device, you will have the V-bus, you will have your 5 volt, and hopefully that's most of the things you'll need. While lots of PCIe devices that would be on board directly will have a much more complicated power sequence with multiple supplies. So I am having a bit of trouble understanding how this generic slot driver or hub driver for PCI would work in that case, because the supplies that it has to control and the order in which they have to be powered are heavily device dependent. So they're not generic. It's not generic at the PCI level.
That's what the power sequencer subsystem would come
Yes.
into play.
Yes.
Okay.
I was reacting to what Greg was saying.
Yeah. I agree. It's going to be complex. It's not going to be as simple as you want,
Okay.
but you will be able to write a platform driver for your controller that's going to power up the slot.
Right. So going straight to the conclusion, because onboard hub is already known, it seems. So discoverable buses don't use DT for discovery. This is actually what we're trying to solve. The devices don't get discovered if they're powered on, and usually such buses, well, lack support of powering up the devices beforehand. So that kind of forces us to keep regulators always on, which impacts, again, the battery life. As for the power sequencing subsystem, this is useful, and I would say optional if we're able to implement that sequence in the driver's probe. But since we would go with the onboard hub approach, you would still need the power sequencing. So we need to respin that as well. Sometimes you don't have a power sequencer device, so it might not be accurate from hardware point of view. So describing a power sequencer in DT, somebody might ask, and I guess Christoph here or Rob might ask, well, is it actually a device, or is it just something that you want to use to power up another device? So maybe that's another problem.
Which is a device. There's nothing wrong with making a zillion devices. That's a device. It's addressable. It's a device.
Hardware-wise,
it's a device in Linux. It's not necessarily a device.
Yeah, it's a device in Linux. Yeah. Wait,
Okay.
sorry. It is not a device in DT, or it is a device in DT?
It's not.
Okay, and obviously onboard hub is useful but hacky. So yeah, guess that's it.
When is the BOF?
Tomorrow at 11, I guess.
Okay.
it's a last minute addition, I guess. So yeah, and trying to solve this as soon as possible. Again, I'm using the XFS.
The BOF is at 11:30 tomorrow.
Okay.
Oh, okay. Thanks.
What's next?
I'll run away.
Okay, take it out.
Yeah.
Fast kernel boot, it's here, right? Okay, so these work and these work. And try to speak closer to the microphone. Thank you.
It's good to start. Good to start. Hi, my name is Osama. I'm part of the kernel team at TikTok, and today I'll be talking about improving kernel boot time. So we'll start with the reason why boot time is important. We will mostly focus on the host kernel live update use case. Then we'll go through some of the different optimizations that have been done to improve boot time. This not only includes optimizations in code path that all machines would go through, but also specialized optimizations, for example, in huge pages in PCI devices. And then we'll conclude with if there's anything more that we can do to improve boot time and what are the large areas of boot time left. So starting with the motivation, why do we want to improve kernel boot time? So in both private and public clouds, once workloads are started, once virtual machines are run, people don't really want the host environment to change. So they don't really want to upgrade the host kernel and try to keep it the same as long as possible. But updating the host kernel, updating the host kernel can cause severe disruption, especially if it results in a very large downtime for the virtual machine. But updating host kernel brings about obvious security, functionality, and performance benefits, which not all of the alternative methods like kernel patching can deliver, which is mostly meant to be for critical security fixes, bug fixes. So there are two ways to upgrade the host kernel. One is live migration, and the other one is live update. So we'll briefly go through live migration in this slide. Live migration is the process, I guess most of you will know live migration is the process of moving running virtual machine from one physical host to another without causing too much disruption. It has one very big advantage over the other method we'll discuss, is that it can be used to deal with physical hardware issues. But this is not a problem over here because it's not a problem over here because what we are trying to focus on is host kernel live updates, and you won't try to update the kernel on a machine that has physical issues. However, it does come with quite a few challenges and costs. In terms of resources, the most critical resource used in live migration is the network. All the data of the VM, including its state, its memory, and even this data in non-shared migration needs to be migrated to a network. So network bandwidth is a large requirement for live migration. So the speed of the network connection and its bandwidth directly impact the speed and success of the live migration, and a slow or congested network can lead to quite large prolonged migration times. You also need to have a separate machine to transfer the virtual machine to, and you need a separate machine just to update the host kernel, which is not quite nice, I guess. The second thing is that you need to deal with the performance impact on the virtual machine. For example, in post-copy live migration, if the virtual machine tries to access a page that has not yet been transferred to the target, then it will cause a page fault or a network fault that goes over network to the source and tries to fetch the page. And if there are too many network faults, then the application on the target VM will slow down. And live migration also has quite a lot of complexity built in. For example, if the network fails, then you need to checkpoint and go back to the source. So there are issues with live migration. So the other method of updating the host kernel is live update. This works by pausing and snapshotting the virtual machines running on the host, then kexec booting into the new kernel, and then restoring and resuming the virtual machines. The biggest advantage is that you don't need all the extra resources that you need in live migration. So you don't need all the extra machines. You don't need all the extra bandwidth that you needed with live migration. However, this does come with a few issues. Just as a comparison to live migration, you can't use this to deal with physical hardware issues, but this is not a problem we're trying to solve here. We're just trying to update the host kernel. Then a second problem is the large downtime that the VM will encounter with live host kernel live update. And this is what we'll try to solve in the rest of the presentation. There are other issues as well. For example, if a PCI device is passed to a virtual machine through VFIO pass-through, then you need to preserve its IOMMU states. My colleague Fab from TikTok tried to present a solution for this in KVM form using persistent kernel memory. It's linked in the slide if anyone's interested. There's another issue with host user space applications like DPDK and SPDK. So you'll need to restart them, and they can have a large restart time. I tried to present a solution for this as well in DPDK form last year. So that's linked in this slide as well. So what's involved in the downtime while doing a live update? So downtime is the process of so it's a total time added by pausing the VM plus the time to snapshot the VM plus the time to reboot the VM into the new kernel plus the time to restore and resume the VM. And in our experiment, we found that the largest time was taken by kexec reboot, and that's what we'll try to focus on in the rest of the presentation. Before we go into making optimizations and measuring time, just wanted to say how we measured downtime. So the total downtime for the virtual machine is measured as the time gap when the guest VM could not transfer data over network to an external machine. And the kernel boot time is just measured from the kernel timestamp logs. So it's from the first log that gives the kernel version to the log which says that it's running the init process. This slide also contains details of the test machine we're using. It has 128 Intel CPUs across 2 sockets and 512 gigs across 512 NUMA nodes, 512 gigs across 2 NUMA nodes. So in order to get a good idea of which subsystem takes a large amount of time to boot, we can create an SVG bar charts of the kernel log, where each color in the chart represents a kernel timestamp log. In this slide, we can see that without any changes or optimizations in the kernel, it took just about 4 seconds for the kernel to boot to init. And we see in the highlighted red boxes that the largest amount of time was taken for the initialization of struct pages. It's about 40% of the total boot time. So the solution to optimize this was quite simple. Just enable the deferred struct page init config option. This defers the initialization of struct pages from a single thread at boot to parallel threads to parallel threads when the kernel swap daemon starts. The biggest time now left from boot was SMP boot time. That's also highlighted in the red box in the slide, which was more than 50% of the total boot time. So this was the next target for the optimization. So before we go into the optimization for SMP boots, just a little bit of how SMP boot works on the Linux kernel. Up until 6.4, I think, the CPUs booted serially one after the other. And during CPU boot, each secondary CPU goes through a state machine. And the state machine is divided into different sections, each having different states. So the first section is the prepare section, in which the boot CPU, your primary CPU, tries to set up your secondary CPUs, the secondary CPU that is being online. The next section is the starting section, where the online CPU sets itself up going through different states with interrupts disabled. And then in the last section called the online section, the online CPU sets itself up with interrupts and preemption enabled. So when the time taken for the CPU to go through each of these states was measured, it was found that the largest amount of time was taken with the BP kick AP stage. So that's highlighted in the red box in the enum for EPU for the enum for CPU states. So this state is where the boot processor just sends a startup and init IPI to the secondary cores, and then waits for them to come back online. And this was taking a very, very large chunk of time in SMP boots. So when I checked on the kernel mailing list, I found that David Woodhouse from Amazon had already proposed a solution to parallelize BP kick AP stage. So rather than kicking a single secondary CPU, waiting for it to come online, and then kicking the next CPU, waiting for it to come online, and so on, you would kick all the CPUs together and then wait for them to reach a synchronization point. So it's parallel SMP boots. So when I was looking at improving kernel boot time, there hadn't been much activity on these patches for almost a year. So I tried to restart the discussion with a lot of help from David, but there were still a few issues. And in the end, Thomas reworked the patches, fixed issues with microcode loading when hyper-threading was enabled, did a lot of refactoring, and then it was merged. So if you get the latest kernel release, you have parallel SMP boots enabled by default. So this is the SVC charts after you have enabled parallel SMP boots. You can see the kernel boot time went down from 2.7 seconds to 1 second, and the SMP boot time became almost negligible. So now, a small diversion to using huge pages. Up until now, no huge pages were reserved at boot time, but there are applications like DPDK and SPDK that want to use huge pages to be reserved at boot time, because after boot, there might be a memory fragmentation and they might not all be available. So we tried to reserve 500 1 gig huge pages, and you can see that the optimized boot time went from 1 second back to 4 seconds. This happens because the struct page initialization and preparation for the tail struct pages of a huge page cannot be delayed even with the deferred struct page init option enabled, because they need to be available at boot time. The main reason that these extra 3 seconds were added were at boot time was there are about 260,000 tail struct pages initialized per 1 gig huge page. Most of these, almost all of these tail struct pages contain exactly the same information. So there's an optimization in the kernel called huge page vmap optimization that frees those tail struct pages just so that the system has more memory. So the question is, if those tail struct pages just needed to be freed later on, why do we need to initialize them? I sent a path series so that you only initialize the tail struct pages after HVO is attempted and only if HVO fails, which it usually doesn't. So you don't, and then you usually don't end up initializing or preparing the tail struct pages. After this optimization, so yeah, those patches were merged in the mainline kernel. I think they should be in the next release, or they are probably in the current release. So if you, so after this, the boot time, even with using 500 1 gig huge pages, was brought down from 4 seconds back down closer to 1 second. And yeah, the struct page initialization was, time was reduced by almost 3 seconds. So after all the optimizations we have discussed, the total VM downtime is still between 1.5 and 2 seconds. And about 70% of that is represented by kernel boot time. So you might be asking if that doesn't seem like a lot, 1.5, 2 seconds, but there are a lot of applications, especially in machine learning and networking, that have very low latency requirements. For example, in production, a lot of databases that run, if the P99 latency over a specific period goes above 100 milliseconds, alarms start going off. So 1.5, 2 seconds is quite a lot, even though it doesn't sound like it. And I think in public clouds as well, users might start noticing it if you start updating the host kernel. And so the question is, can we do more? This slide covers purgatory, which is not really part of kernel boot time, but it is part of the kernel source code and contributes to the total downtime. So purgatory is the piece of code that runs between your old kernel and your new kernel. And its main task is to do that SHA-256 checksum, the SHA-256 integrity check for the new kernel. If we disable purgatory, we save 200 milliseconds. That's 20% of the total downtime. I tried to upstream this, and I got a lot of pushback. I was told that the saving of 200 milliseconds does not justify disabling the integrity check. In my opinion, having a config option for that is not a bad idea. Especially, for example, in production environments, there are a lot of canary tests that are run before doing kernel updates. So you would know if things would go wrong. So it actually would be good to hear your thoughts about if it's something that's desirable. Okay, yeah. So looking back at kernel boot time, approximately 120 milliseconds was taken up by PCI devices. On the machine that I'm testing on, there were 57 unique PCI devices, and only 15 of them were actually needed to boot the host, boot the virtual machine, and then provide networking and storage to the virtual machine. We made some changes so that we could filter out using kernel command line which PCI devices were probed, and then the subsequent operations were done. And that brought the boot time down by 8%. This is a much more specialized optimization. You would need to know what software is run on your host, your virtual machine, and all its requirements. So it's not a general purpose optimization. It's not what a lot of people would do, but it's something you can do. Looking at the rest of the boot time, the largest time are occupied by two things. The first one is the struct page initialization, which takes about 20%. And then there are ACPI operations that take about 30% of the boot time. When it comes to struct page initialization, even with the deferred struct page init option enabled, more than 100 milliseconds are taken to initialize the necessary struct pages. That's the red box. And then later on, the deferred struct page initialization takes almost between 70 and 100 milliseconds, depends on your kernel. And then from ACPI operations, the total time taken is about 300 milliseconds, that's 30%. About 100 milliseconds were taken to enable the interpreter, another 100 milliseconds for ACPI table load, and then going through PCI device idle states also takes quite a bit of time. There probably aren't that many, there probably isn't a simple solution to solve these times, reduce these times. When it comes to ACPI, maybe it might be possible to preserve the ACPI namespace across kernel boots, similar to how you preserve RMMU states using persistent kernel memory, but it would be a very, very invasive kernel change. So yeah, not an easy solution for that one. So in conclusion, ideally we would prefer downtime of 0. That's not going to happen. A few 100 milliseconds is acceptable, but we are still at 1 second, so there's still more work that can be done. For future work, if there's interest in having a PCI device whitelist or blacklist, we can start a discussion upstream on the mailing list. It might also be used, for example, if you want to probe PCI. If you don't want a PCI device probed because it's faulty, I mean, it can have other purposes as well. Then we would also like to restart the discussion on purgatory, but it would be good to hear your opinion on that, if that's something you would be interested in. And then in terms of boot time improvements, so yeah, the biggest chunk that's left is ACPI operations. If there are any power management or ACPI people here, it would be really nice to hear your thoughts on how we can reduce that. So it's
awesome. Did you measure which part of ACPI took long?
So the largest I think was ACPI interpreter enablement and the table load. So I think it's RDSP, like you get the table from RDSP and then it goes on, right? So I think those were the 2 biggest areas.
Interesting. What I remember from our, like, we have the exact same problems in the same setup for us in Amazon. The main thing that we have been seeing is CPU object initialization. CPU object initialization. There's a pull request on ACP ICA right now that we've done to optimize that, if you want to take a look at that. It's getting rejected. I literally just talked to Raphael yesterday, and he doesn't like it. But he has an alternative approach where you basically would just remove all the CPU objects.
Okay.
And then you get the same result.
Okay. Okay.
James?
Can you go to the next slide about the topics? You had some, yeah. So the first thing is regarding the purgatory. There are other people like us as well. I also work with Alex at Amazon that are definitely interested. Like every few milliseconds make a difference, especially for this use case. Yeah. So that I think it's definitely worth having those conversations. In terms of the PCI whitelist blacklist, another option is you don't actually need to reprobe your PCI topology after kexec, right? It hasn't changed. And in fact, probing PCI and discovering bar sizes and all of that is actually a destructive operation, especially if that device is being passed through to the guest and is actively being used. Another option is to use kernel persistent memory and pass your PCI information across from your old kernel to your new kernel. You then don't need to do any actual PCI probing, you know. Yeah.
So how do you pass that information? That's again.
Well, we have a talk tomorrow, Alex and I, exactly on this. It's called, what is the topic? It's something like, yeah, it's something like passing guest and host state across during kexec, and we're basically looking at options to do this. Anyway, I just wanted to say that instead of saying do probe these devices, don't probe those devices, you can say just pass across your whole PCI information during kexec.
So yeah, so that's like that's one of the things that we have done. For example, for the IMME state, for VFL PCI devices. We pass that across, but that's simple to do, I guess. This might be a bit more complicated.
Yes, I
Yep.
mean, it's a good topic. I just have a question, actually, out of curiosity. The vast majority of the devices that you don't need, are they just basically the switches and the bridges of the slots, or do you have actual devices that you don't care about?
So it was a combination. I remember, so been some time, but I remember a lot of them were Intel ones. So I think they were bridges as well, but they were a lot of Intel devices that I just removed and it's
Yeah,
still-
system devices of some sort, and
They were system, I think, yeah.
Yeah.
So yeah, I think there's one at the back.
Thank you. Yes, I also, in my experiments, saw the time spent in purgatory. And I mean, there are two types of kexec reboots, right? There is a kexec reboot and then a kexec load, and then there is kexec file load. So one goes through the kernel and another one goes through the purgatory of kexec tools.
Yes.
So if it goes through the purgatory of kexec tools, that you can
skip.
modify whatever you want there, right?
Yes, but that's not used in production a lot, right? So that's the older one, if I remember.
Right. I just wanted to mention that.
Yes.
That,
So there's a skip purgatory option in that
y-
one, but I don't think people use that. I don't think the code through kexec tools people use that anymore, or much more. Or-
Actually, we use it.
But I think that's the older way. Like I think the newer way is
we
that.
use it for a different reason. We use it actually for existing bug in VGA, and Linux boot uses it. So it's actually used in production.
But yeah, so that's part of the source code from kexec tools. But the one in the so there's a purgatory in the kernel that you can't skip at all.
Okay, so but I thought that the purgatory. So is it the same? Do we check SHA for only x86 or on ARM as well? Because
ARM doesn't go through purgatory, I believe. So this is an Intel issue.
this is Intel only, okay? Because I remember that on ARM, that if you use kexec tools, it's slow because we have a purgatory with the SHA 256 check, and
Might go through.
if we do the kexec 5 load, it's much faster because we don't do that in the kernel.
Okay.
Okay, and for the struct pages, can you please go back to that slide, to the last slide? So the struct page initialization is now divided into two parts, right? The deferred initialization and then the huge TLBFS where you still initialize serially during boot.
So
But,
the red box is the one that I think those are the kernel decides are the necessary ones that it will need through the boot.
the necessary ones. Yes, so that can be reevaluated because that necessary ones I said like 7 years ago, so and, I don't remember.
So maybe we can reduce that a bit.
Yeah, you could check that because that might not be wrong right anymore.
Go ahead, David.
James.
Okay. Just on the struct pages, I don't exactly know how this deferred initialization worked, but we posted a patch series quite a while ago that we called lazy struct page initialization, where basically you only actually initialize the topmost node in the buddy list, like the 2 meg, the struct page for the 2 meg aligned ones. And then as soon as you want to break that down, then you actually go and initialize all of the rest of the pages. So it's like only when you actually try and use it and break that buddy node, then you go and allocate, then you go and yeah, I don't think that was ever merged, but maybe we could look at that again.
Yeah, that would be good to look at.
I think we called it lazy. Yeah, only when you actually need that, you initialize the pages.
Okay, I'll have a look.
So a bunch of this stuff gets easier once you go and talk to James and Alex tomorrow about passing stuff over from one kernel to the next. And essentially you sort of build this flattened device tree or something with a whole bunch of information that can be passed from one kernel to the next, and then just go and do a bombing run on everything that takes time, making each individual thing pass over that information. You start with loops per jiffy, for example, which you can do on the command line, and it wastes time. And then you do PCI probing, and then you do a whole bunch of other stuff, hardware, PCI discovery, etc. And then you do KVM, because if you go back to your first slide, you were timing on how long does it take until we get to running in it. But what if you could run your guest CPUs before you even run user space? What if you had an asynchronous KVM run, which was running those in a kernel thread or something, and then your VMM can serialize and bugger off before kexec, and your new kernel can start running those vCPUs, as long as they don't need complicated VM exit that actually involves VMM doing anything.
Paolo's looking very concerned. I can see his face.
We'll get Paolo drunk, it'll be fine.
I feel like
and you can be running your vCPUs as long as you have posted interrupts and everything else and don't really need many exits.
But I feel like
don't
that
give
would-
him a mic. And you don't have to wait for user space. You
I'm
don't
not
need user space.
concerned. So I'm not concerned, but I have a deja vu because
It's almost like we have a plan.
No, yeah. So, so he didn't manage in the getting me drunk part, but so I think you're kind of putting the cart before the horse here because there are two different steps. One is making kexec fast, and the other is passing stuff from pre-kexec user space to post-kexec user space.
You're right, yes.
Once you have this thing, then you can do all sort of crazy tricks, like also say, by the way, put this into some kind of KVM run as soon as you can.
Yep.
But I think this is
It starts with a way to pass from one to the other.
This is a different thing. And furthermore, like kind of jump-starting discussion also for tomorrow, what I was talking yesterday to Alex, the task of basically saving the state for post-kexec doesn't really need kexec. It's basically snapshotting the state of a bunch of file descriptors in such a way that you can keep the kernel memory reserved from when they will be needed again.
Yep.
And like it doesn't really make sense without kexec, but implementation-wise, you can just have a snapshot file descriptor that you push other file descriptors in. On the post-kexec part, you get a restore file descriptor that you pull file descriptor out of. It's kind of a key value store for file descriptor metadata.
Yeah, in a way.
Yeah.
Although
so,
I also have this fantasy of the next step, right? If you look at this, we're turning off these CPUs to go and spin somewhere useless.
Yeah.
And then we're waking them up to go back into the vCPU. Why couldn't they just stay in guest mode while the BSP goes?
I mean,
but that really does come later.
Yeah, well, that's like 4 or 5 steps further. But I think that the important thing, plumbers-wise, is to figure out what is kind of the user space API abstraction that you want, and what is the kernel data that that is attached to it.
It starts with the kernel and how we pass stuff from kernel to that, and then we look at
Yeah, and from kernel to kernel is a kind of already a generalization of from user space to
We've
user
done
space.
that with Zen Live update already.
Yeah.
I mean, and that's where you're going to have a bunch of skeletons because the kernel to kernel, you always have a problem is you're going to keep a whole bunch of memory pages around, including all your get memory pages. They may be in a location that is now going to be where the new kernel wants to be. And so
that's fixable. We fixed it for Zen.
That's
fine.
You do see like allocation, just make sure.
and then you need to main block to know about not walking over all of those places. And I mean, there's a whole bunch of things there because the main block allocator doesn't know about all your pages.
It's fixable. It's complicated, but it's.
I mean, it's complicated, right? There is a whole bunch of stuff.
We know how to do it. We've done it.
Okay, you've done it already.
And another thing with the guest MMFD that would be worth looking at, especially if we want to have reserve pools for just KVM, is gifting memory from guest MMFD to KVM for things like page tables, so that when you free up memory, like say you're managing at 1 gig granularity and you want to tax the guest and take from the guest and not from your small reserve pool for the host, you don't have to reconstitute a huge page when you give it back to the kernel because it's just always just KVM is allocating 1 gig chunks. You have to make sure you're not like 1 gig plus 1 byte and then you're just burning 2 gigs, but you got some flexibility there. I think that's a solvable problem.
And then, of course, in-flight DMAs, the
Oh, that's fine. The EPT stays in place. The in-flight DMA. In-flight DMA has to keep working if you can't pause the assigned
but that
device.
means we need to-
That's all fine. The EPT stays in place. You can even collect posted interrupts into a PID while it's still running.
But
Just
as
to, it all falls
So,
out eventually.
As long as we solve the problem of the PCI state, because a new kernel will.
Exactly.
We can't let the probing happen, basically.
There is an order in which we do these things, but it's fine.
In-flight DMA has the problem that also you need to not reinitialize, of course, the PCI devices. So that goes into what he was saying. That
Or the IOMMU.
and IOMMU and everything. So it goes into what he was saying. That well, you don't have to reuse the IOMMU page tables. If you want, you can just pass down the mem slots, whatever VFIO calls them, and flip the PACID atomically in the new kernel once you have finished building the IOMMU page tables if you want. Otherwise, you can keep them. I don't know what's easier.
We built them, we just use them. But yes.
Well, I don't know what's easier of the two, but yes.
But yeah, all this is doable. But it starts with a way to pass information from one kernel to the next, and then we just build up.
I think the important part is to find a decent first step. I think the important part is figuring out a decent first step that gives you something and gives you kind of the momentum to go to the next steps. Because otherwise, you have a huge thing to do and you don't.
Paul, I'm completely with you. I think that the very first base fundamental framework we need to solve, which is exactly why we have the presentation tomorrow, is how do we pass memory as well as metadata from one kernel to the next through KExec in a standardized, backwards compatible, ideally fashion, right? And what I currently have hacked up, and it's kind of working, is a couple of patches that basically take do a serialization path on the KExec down path when you go off. Create a device tree, as in data structure, not as in the actual elements of it. Just the data structure of a device tree. Serialize metadata into a device tree with a standardized nomenclature of the memory ranges. And then I can, on the way back, reassemble my memory slot, my boot, what's it called again? The boot memory array. What? No, not the other one. The one that's in Linux. The memblocks. Yes, I can reinitialize memblocks. I couldn't hear you. I can reinitialize memblocks based on that one, and then have all the memory reserved again, and then on the driver init side, pull every piece again out of the device tree, reassemble it with driver specifics, and you're done, right? And that gives you a base framework. What I have enabled right now is ftrace, because that's a super obvious use case, right? You can actually trace all the way down to reboot syscall, and do things that are sensible without talking about justifications of 100 milliseconds of boot time and things. But once we have this framework in, I think we can very easily go further.
And we've had this working for Zen for a couple of years. We've done much the same thing using the Zen guest transparent live migration ABI, and we just pass that stream, and we don't use it for live migration in space. We use it for live migration in time to the next instance of Zen on the same machine, and it just doesn't free those pages into its buddy allocator as it starts up, and just continues to use them, all the guest pages and everything. And it just works.
Yeah, so the interesting thing is going to figure out acceptable upstream way of having a generic hook into the struct device or whatever for drivers to have the opportunity to serialize state and recover state, and including bus drivers, because we don't want to probe, especially PCI, which is destructive. And that's where I think a lot of the back shading is going to happen.
But that's where we play whack-a-mole, right? We get the mechanism in place first, and then we go and deal with all the things that will
And
pass.
PCI is going to be the big one.
Yep.
Yeah.
And IO.
Well, we can corner Greg and.
For the KVM side of things, have you guys actually gotten to the
He's
point
big, so you
where
know
you're
more
having
of us.
fun run? Have you gotten to the point where you're able to keep the guests running without too many explosions with in-place EPT?
Keep the guest running as in while we're doing KExec, or?
Using the EPT tables from the previous kernel.
Oh yeah, it's hackish. It's not something we're proud of right now. We want to do this properly now. But yeah,
where I'm
works.
trending with this is, I think on the x86 side, we should seriously consider either revamping mem slots or moving away from them. We have a lot of tech debt there in terms of ABI that really hamstrings us.
Yes, I have other thoughts on that issue, and yes, and
Aside from the cleanliness of it, the ABI problems that we have. Yeah, oh yeah, there's lots of things, but I mean, just from a, like we have I've wanted to, like my white whale is the whole VFIO thing where there's a hidden flush that KVM has to delete every single EPT entry when you change a mem slot. It kills me.
So I just want to point out we haven't tried to keep actually using the EPTs while the KExec is happening. What we've kept is the page tables used by IMMU. I don't know if that's what you mean by EPTs, but we keep
Oh,
DMA
sorry, no, I
running.
meant for.
So the vCPUs, yeah. Yeah, we're not in guest mode during KExec. That's a nice, like.
Okay, that's what I was asking. If you had the EPT, because there's also a ton of stuff in KVM that assumes you
That's
have
like
the
the-
current process struct running.
Yeah.
And it's not just, there's like a whole pile of
Like
stuff.
the total North Star here is actually to stay in guest mode.
Yeah, I was
while
asking if
KExec
you
is
got that
happening.
running part yet.
No, so far it's
Okay.
just keep DMA running while the vCPUs are not running, and you're doing KExec.
Yeah, I guess when we.
David?
you do.
Yeah,
full
there's
address
just
space isolation. You've got that mini piece of code which is its own thing, and it will have to thunk back into real Linux, and it can just wait until Linux has come back from KExec.
Yes,
right.
there
And
are options
all
on
these
that part.
jigsaw puzzle pieces do eventually come together in my fantasy, but we'll see if we get
Yeah, well, just where I was going with that is with the, especially with the guest MFD stuff and KVM side, there's definitely, if we're gonna do any kind of redesign or extensions, now is the right time to do it, not 3 years from now, or at least we should be thinking about it so we don't come up with something that's as Frankenstein as mem slots.
Yes, absolutely.
I think about like 5 years ago, the PKRAM patches were proposed as a way to preserve the kernel memory. But I think the biggest problem that I had with those patches was that they can lead to fragmentation. So when the next time, when you reboot kernel many times over and over again, you can have like unmovable pages in random places, and eventually what you could have is like kernel that's just not bootable because of like not long enough memory segments available that are presumed by the first. So I was just thinking if whatever like we decide in terms of like a standard interface how to preserve the kernel memory across the reboots, that it should also prevent the fragmentation from happening, like when we do multiple exactly boots of the kernel.
I understand the question.
So PKRAM, that's PKRAM. That's Oracle. That's something that Oracle proposed in 2018, I think. Yeah. And what it allows, so it builds a of memory ranges that needs to preserve across the KExec boot that can be preserved within the kernel. But the problem is that it can lead to fragmentation, so that at some point you're just not able to even allocate like a memory map or something like long enough to.
But why should that be cumulative? Why can't we move the pages once we've got them? Yes, they're in a certain place and we have to avoid them as we're booting. But as soon as we're booted, nothing should be pinned. We should be able to move anything we like, right?
So early in boot, before those pages actually use like there is some like memblock allocator, some early kernel boot code that require like.
Yeah, you need to have enough contiguous memory or
Yes.
some complexity so early boot mem can work. But that's okay because you just ensure, well, the way we've done it in Zen is we ensure that you don't do any persistent allocations from that region. And you can achieve that by moving them out of that region before you KExec as well, if you want. I'm going to migrate any page that's in my, and then we give the new kernel, this is the region you can use for your boot memory. This is where we're going to load you. And then you go and parse the data stream and work out
That's
which
exactly
pages
what
to
I'm
allow.
saying, is that we need to guarantee that we do not cause this kind of fragmentation, because PKRM today can, and we need to guarantee that before we reboot.
Yeah, no, we know how to do this. This is the thing I was saying to Ben a few minutes ago. Yes, it's complex. We're not going to discuss it here when we're already out of time, but it's fixed. It's fixable.
In the old world as a contiguous physical memory array, and then everything after doesn't need larger locations, and you're good.
Yeah,
Until
it's fine.
you're actually at a point where you can have flexible memory allocations. You're fine. This is
It's a tractable problem. Yes, it's right. We are done. Thank you.
Thank you.
Anybody want to say anything?
Do you want this back somewhere?
Where do you want me to put this?
Very good.
What time do we start?
There's also just so much and for some things where we don't want to do it, or you don't have anything that's material on those scopes, you just want to give memory to the guest.
Yeah, I mean, so a particular bugbear, yeah, is the fact that yes, we just need to punch a hole in the middle of it because the guest wants to put it like. And there's just no atomic way to do it.
No, yeah.
There's no. You have to pause all the CPUs, do the thing.
All CPUs stop interrupting, and then you can change the overlay page, and then you can start it again.
Yeah, because we are
The event has to be exactly.
PSM wants something similar as well. We were talking about.
No, it's not any overlay. They overlay has all the interrupts.
Well, they want it for memory protection.
Well, memory
It's essentially different memory layouts.
Back hardware, something similar.
They have overlays as well.
Well, they have overlays, but actually their overlays are similar layouts.
Yeah, exactly.
SMM is an overlay. This is the only difference between the SMM set of mem slots and the real one, the SMRAM.
I don't think
so.
If our is the fixed array of things.
Old school. So what about mem slots become? We had a way of having a number of them, and you just sort of set up a new one, then switch rather than modifying the one that's in use.
No, we were thinking about atomic switching, and it didn't. Like I was thinking about it, and he convinced me that it didn't really solve anything. And
there's multiple different points. There's the what memory am I allowed to access? That you don't need, like that can be static. And then what you really want is different views, which is different EPT routes.
Yeah.
And those don't have to be tied to mem slots. They need to be bounded by how much memory you've actually assigned to the guest. And then you can restrict it from there. You can have things that are only accessible for a certain. But you don't need to replace the whole thing. You just need to tell KVM which view.
Also, I think with the BSM stuff, they need to
But BTL,
I think you can actually do that for because then it's also from a KVM perspective, I think the number
We'd love to do that.
Doing that in QNU and doing that.
I
I don't think we can entirely wash our hands of how hard this is for you. Right? Yes, it's improving the kernel, but it's enough to warrant the complexity we push on user space. I think we should be held accountable for it.
No, I think to some extent it makes sense. Like there was going to be some kind of separate file descriptors anyway. And having 2n plus 1 versus 2n plus 2 file descriptors, like 1 or 2 KVM file descriptors, at some point is not.
Oh, it's not just, it's
For me, it's the ABI. The ABI that can be taken on in KVM. If it was something where it's like we got to a point and we knew we could rip it out, I would be less hesitant.
Yeah, I think it's a half and half ABI that makes no sense. Either you do it all in kernel space and you have all the complexity that I don't want, but
which we tried and it was hard.
Oh, right, and you tried also, yes, right. And or you just go all the way and have to be the part that is messy is the part where you have to the interrupts where you have to have the one VCPU kick the others
halted while it invokes the other VCPU, or what is now the other KVM.
Yeah.
I see. So you literally duplicate everything and then flip it between two.
Even when you do the VCPUs, you end up having to do that because of the way, like, unless you like completely rewrite mem slots, because the way mem slots work and how they track huge pages and stuff, you're going to end up duplicating memory-wise like 90% anyways. So that's why I'm just like, just go for the whole VM because simplicity is way down for the kernel compared to everything else that we'd have to deal with.
The main complexity is the part that we were discussing about having to wait and like what was it? Where
the
having to wait while the other VCPU is halted, polling on hold. Yeah,
polling on for interrupts in VTL1.
So when VTL1 becomes runnable because or whatever, just becomes runnable. That's when user space should be woken because it was polling, and user space should then stop running VTL0, whichever KVM it's in.
If we were going to do it for Zen, we'd have to do something like extract.
Well, this doesn't help Zen at all, right?
Well, no,
fixing mem slots or whatever to have overlays would solve both problems.
You could have essentially your shadow VM, your running VM, and then literally you set up your new mem slots in your shadow VM. You extract the VCPU state, play it back into that one, and just kick that one.
That's what you're supposed to do. Yeah, no, that's what
you're not allowed to talk.
Right, that's what you want.
That is
the exactly
most
what you want.
hilariously complex way to solve
You keep using the old EPGs.
Oh, your grandmother's ghost. Oh no, because I was sitting here running around switching a couple batteries and another one. Yes. Because the only way I was able to make this work because yeah, that's what caused that.